That's fine, dude. Take it as you want. That's absolutely fine. I really couldn't give a shit.
Man, my discernment was way off with this guy. I thought he was going to be honest.
Oliver?
No, I am honest. I have no positive views whatsoever towards flat earthers.
Yeah, you're extremely biased and closed-minded.
No, I just think you guys are scientists in the same sense that paedophiles are like sex therapists for children.
That's a cool analogy.
Oh, that's TOS.
Do you understand why I said to remove him as soon as he jumped in? He's fucking intolerable. Get rid of him.
Get rid of him! Someone please escort Oliver out for the TOS violation. I would do it, but I am traveling. Welcome, Sebi.
For the banana.
The earth is flat. Banana?
Yeah, it's a banana shaped.
Yeah.
I know you guys like bananas.
Is this Rich?
Who's Rich? Yo, didn't this chat get banned off the server? Why are you guys back?
No. No, we didn't get banned, man.
I haven't seen this chat in a while.
Yeah, we don't like to come in, there's a lot of knuckle draggers. A lot of people come in and talk about bananas as soon as they enter, so,
I was busy with your mom, so that's why I haven't been in.
She's dead.
So,
made you feel bad.
So does anyone in here think the Earth's flat?
Yeah, man.
No way, it's flat? I didn't know that, bro.
Yeah.
Bro.
Yeah.
What makes you think that?
Water being horizontal on the surface.
That sounds like something a British person would say.
What, water?
How does that make the Earth flat?
Because 70% of the surface of the Earth is water. The Atlantic and the Pacific Ocean, for fucking example. So if that's flat on the surface, how the fuck is the surface of the Earth curved like a sphere? All right, is it because it's the beginning of the week of people not completely logged their fucking brains in yet? This is weird. If 70% of the surface of the Earth is water and water's flat on the surface, it makes the fucking Earth flat, you dude. What the fuck?
Yeah, true. Hey, Jedi, have you ever played Skyrim before?
Skyrim?
Do you know
No.
Do you know the Daedric Prince Clavicus Vile?
Okay, so I answered no. Do you think I'm going to be able to answer this really deep question about Skyrim?
It's really not that deep, bro.
Yeah, no, dude. The answer's still no.
Where in Britain do you live?
Really, nigga?
Just south of London.
South of like Essex or Sussex, sorry.
No. Try again. I'll give him a fucking
South.
street name in a minute, mate.
Croydon.
Croydon. Fucking hell, that was specific. No, it's in Kent, dude. What do you want?
Kent, that's it. Oh, I'm just asking, bro.
Oh, okay, yeah, no worries, dude. Do you get the water bit now, though, yeah? You asked why do
no.
we say the Earth's flat, and I said because water's horizontal on the surface.
No,
And if water's 70%, I know, we're just going for it again before you start asking weird questions about where I live.
Chill out, bro. Chill out.
Okay, will do. I'm just trying to egg you along so you can be intelligent, not stupid. Trying to keep you on that side of the conversation. I don't want you to embarrass yourself by shit coming out your mouth. You can do better. I'm rooting for you.
Yeah.
Engage your brain, dude, please.
British people are hilarious, man. Oh, I thought the server name was a joke, to be honest. I was just asking. But I had some aggressive British man come at me immediately.
Let me ask you, Koba. If water is flat everywhere on Earth, right, and it is 70% water on the surface, can the Earth be a sphere? If 70% of it's flat?
70% is flat. What are you talking about? You mean 70% of the world is covered in water?
Yeah, right. Which is horizontal upon the surface, which is mean sea level. You sail on it, it's the surface of the Earth. When you swim in it, you've gone under the surface of the Earth. It's like, fucking hell, dude. How did you get to the age you are today?
Like we agree that there's mountains and hills and valleys and things like that, but water itself.
No, we're too irrational to agree to that. Of course. Come on, that's a numpty statement.
Water is a fluid held down by gravity.
And the Earth is flat.
Really?
It's not a piece of grass. It's not like the ground.
I just want to make sure I heard that. Water is held down by gravity.
That's correct.
Does that mean that gravity pulls everything to the center of mass and makes the Earth a sphere-like planet?
That's correct.
So that would mean that the water would curve upon the surface, wouldn't it?
It does, but it's imperceptible to you and I.
Hold on, imperceptible. Now we're talking about using tools that measure over large distances, like laser finding equipment, surveying tools. If the surface of the Earth is curved, we should measure it over distance, shouldn't we?
We do measure the Earth over a distance. Have you ever heard of Aristotle?
Can I have those measurements, please? If you say that we measure curvature, rate of change of slope over any distance of the Earth, I'd like you to show me, please. That'd be awesome. Thank you.
Jedi, have you ever heard of Aristophanes? He asked.
Sorry, could you say somebody else?
You're going 2,500 years ago to prove your ball? Wild.
Well, because I know if I post anything from that, say you guys are going to immediately discount it. You're going to throw it out.
Well, why couldn't you do
we're going to walk through it and we're going to dismantle it from the inside for you to observe.
But it is a fact, and you can do this in your own home. Just
okay, what can I do?
Just pour some water over a curved surface and watch where the water goes.
Yeah, on the floor. On the fucking floor.
But before it hits the floor, what's it going to do? Is it going to curve?
It's going to drip down the side of the ball and then fall off the bottom.
Correct.
If I put the
Do you know why to roll off the bottom of your bowl onto the table? Because there's no gravity under the bowl to hold the water to your bottom of your bowl.
Yeah.
Wow.
And that's not even
what I'm saying is pour water over a curved piece of paper. What happens to it? It follows the curve of the curved piece of paper.
We asked you for a measurement. how you could prove
It falls off the fucking piece of paper, and that proves a
Grab a cup
wall.
of water and then pour it down something and watch it gravity curve.
Fucking write that down.
Yeah, write that one down.
Is there another British person in here? Is there two British people in here who are flat earthers?
I can go and find you another one if you want.
Are you obsessed with British?
No, I just find it like almost comical that the majority of you are British.
The majority of them are actually American. You to pay attention to what's going on around you.
The smartest people on Earth, British and Americans.
Wait, what? What comic books have you been studying from, dude?
I've never read a comic. I think I've read Asterix and Obelix when I was like 8 years old.
Yeah, well, it's changed since then, dude.
Okay.
Right, anyway, can we get back to the
So we still have.
Go on, dude. You?
Yeah, we haven't gotten any Earth curve measurements yet, but we've heard about dripping water off of paper, which is hilarious, by the way.
Yeah, that's just about as funny as when you ask someone if they know about Skyrim. They say no, and then you ask them a detailed question, expecting a response.
But you got to be honest. Jedi. Has anyone here played Skyrim? Because this Jedi guy sounds like
Koba.
Sorry, brother.
Shut the fuck up about the Skyrim and British people. Either you stay on the topic or you go on mute. That's how it works.
All right, I'm sorry. I'm listening. Please keep going.
So anyways, the Earth curve measurements that we're still asking for, where are those? Anybody got those?
Do you need to be...
Gravity causes water to adhere to the surface of a sphere, and the water is flat on its surface, or appears to be anyway. And so now you've got the surface of water with no topography adhering to the sphere because of gravity. Does anybody have a measurement of that curvature rate?
Wow, nobody. It's pretty interesting that people believe that they live on a ball and there's no curvature to be measured.
Do you guys believe in space?
No belief.
People are like,
no, I want to stick to the thing that actually proves the Earth's a sphere or not.
But do you believe in
what's
space?
A sphere? Or what's a measurement?
Sorry, hold on. What do you mean by that question? Do we believe in space?
Like, do you believe you can exit the atmosphere and go above the Earth?
What, into a vacuum?
And
do you believe it?
Above.
Do you believe it?
Do I?
You believe it? Yeah.
In the way that you described it, mate, no, that's impossible. To leave the Earth's atmosphere into a vacuum.
Yeah. Why do you believe that?
I mean, I'm not exactly. I wouldn't say it's not really something that empirical. Like, I don't really need empirical evidence to believe the Earth is round.
That's true. You don't need empirical evidence to believe, because belief is acceptance without evidence. So the two are contradictory. You're not going to need empirical evidence to believe shit.
Do you believe you're real, Jedi? Jedi, do you believe you're real? Do you believe you're real?
Are we going into these questions now? Do I believe I'm real?
No, do you believe
you're not real anymore?
I think I'm just having an experience.
No, I'm just asking. Like, do you believe you live in like a reality with other people?
Yes.
And it's like not.
Yes.
Yeah.
Yes.
The Earth is flat. But
all right, dude. Before we start wandering off, you asked us if we believed in space.
I'm not wandering off, but these are all questions
I want to
related.
answer your question before we go on to another question. You asked us if we believed in space. That's all right. The answer is very simply no. We don't believe in the vacuum of space uncontained from our atmosphere. That's a violation of natural law. You know, air expands into volumes, right? Yeah. So if there was a vacuum space above the Earth, the air would expand into that vacuum space, wouldn't it? Yeah.
I guess.
Yeah, it would. That's the law of nature. Gas expands because of the temperature, the energy held within the gas, and constant collisions with each other. The power of natural expansion as to fill any volume. You understand what happens when you pop your tyre on your car, right? The air comes out because the container's been opened, right?
That's mad, fam.
Yeah, isn't it? You understand that when you put the gas into the tyre, into that. Yeah, there you go. When you put that gas into that fixed volume, by consequence of the tyre surrounding the gas is under pressure. You understand that, right?
Yes, I'm not following.
Okay. Do you know what gas pressure is?
Yeah.
Cool. What is it?
Well, if you got like a confined space, so like a tyre, and you got a gas pressure pump, you plug it into the tyre and you fill it with the gas, and it fills the tyre, depending on how much gas is in there.
Yeah, because of the fixed volume, the gas is now under pressure because of its power of natural expansion. The force of the gas is pressing against the walls of the container. It's under pressure, right?
Yeah.
Does the Earth have a tyre around it?
No.
Right. So how do you have pressure then?
Well, we exist in like an atmosphere.
Which is gas, oxygen and nitrogen, which is the gas that we're talking about. Atmo meaning gas. So the atmo, the gas, is going to want a container around it to achieve pressure. If there's no container around the gas, there's nothing for the gas to press against. It won't achieve pressure, and it will continue to expand into the vacuum, the available space, won't it?
Yeah, I guess.
Yeah, cool. So this is why we don't believe in the vacuum of space, because it violates fundamental laws of nature.
How does that apply to, like, how does that apply in the case of the Earth and like?
Because we've got air that isn't contained by a tyre. Like Jupiter, right? It's a giant ball of gas, uncontained in a vacuum. Well, that can't happen because there's nothing physically containing the gas and stopping the natural expansion. You can't have spheres of gas in vacuums. Gases only take the shape of that container. So if you want a sphere of gas, you better have a football or a basketball, right? Yes, Jedi.
I mean, I don't know. Yeah, sure.
Thanks, mate. Think about that, dude. Like in the next couple of days or whatever, just think about that. How do you have a gas pressure system without a physical barrier? You can't, dude.
Interesting.
I see you played your Death Touch card, Jedi.
As the days go by.
Yep.
Your flavor text says gas pressure requires containment.
Yep.
Hey, Globers, you're going to be able to buy our trading cards soon, Flat Earth trading cards. Be the first ones.
We should have Flat Earth, Globe Earth, Trump.
Say it again. Jedi got your tongue.
Oh, is it actually quiet?
Yeah. Oh, I'm just like looking up what he said. I'm just like, yeah.
You don't believe that a balloon or air requires something around it to hold it in place? You think that
pressure differentials can do that.
You think air bubbles just kind of exist in your bedroom?
Pressure differentials can do that.
So you think air bubbles can exist inside air?
No, not air, mediums. So like
the medium of air, right?
Yeah, different densities. If I get a jar and I put different density liquids and I blow a bubble, it'll get stuck.
It doesn't
actually
work like that.
I'm gonna put a video in side chat, liar, and then we could be done with it.
Hold on, what's this about jars, dude?
What?
What we putting in jars?
A bubble inside a medium with different densities. Yeah, it'll actually hold in a certain pocket.
Sorry. Different densities of what? State of matter?
Liquid, man.
We're talking about gas.
Yeah, gas and scale
not
acts
the same
like
as
a liquid.
Sorry, dude. Stop.
I'm not here to argue with bullshitters,
no,
bro. So
neither am I. I'm here to incorrect wrong. So liquids aren't the same as gases. When you put different gases into a jar, they'll mix. They won't stratify like the liquids like water and oil and so on, right? The gases will mix. Over time, let's say you leave the jar for 10 years, you won't have a layer of the denser gas at the bottom and the less dense gas at the top because the gases will always be mixed. So not the same as liquid, dude. That's what I'm trying to point out. Forgive me if it sounds rude. I'm not trying to. So we're talking about gases, and somebody said they were researching, and if you were researching correctly, you understand that the definition of gas pressure is the force the gas exerts upon the walls of its container. If you're researching correctly, you might have across the ideal gas formula, PV equals nRT. This will be the mathematical formula that describes the behaviour of gas as demonstrated through scientific experiment. For example, Boyle's law, Avogadro's law, Gay-Lussac's law, Brownian motion. You might have even come across such things as kinetic molecular theory. All of these things, without exception, will demonstrate that you require a container for pressure. If you do not have a container, the gas will expand into the next available volume. Gases do not have a directional bias. The only reason they go in a direction is because of the energy that they hold, because of temperature, and their last physical collision. Because of their last physical collision, they will go in one direction. If they have no more physical collisions, they will continue to go in that direction indefinitely. Gases have the power of indefinite expansion. To have gas pressure, you require a container. If you don't have a container, you cannot achieve pressure, and the gas will continue to expand. As held within the narrative of the heliocentric model, where the Earth, Mars, Jupiter, Venus and Saturn are all uncontained gas spheres in vacuums. This is fucking stupid.
Yo, Jedi, what about balloons in a vacuum? Those balloons are going down, aren't they?
The balloons are going to go down for a bit because of the mass held with the balloon, the solidness, right? Now, the gas inside the balloon is going to continue to expand because it's met with no pressure from inside the vacuum. So it will expand until the balloon pops. When the container of the balloon has popped, the gas is going to expand into the vacuum in any and all directions, filling the limitation of that volume. The gas has no directional bias to the floor.
Oh, I guess that doesn't work.
What about water in a vacuum?
Does a barometer work, Jedi?
Barometer is just measuring pressure. It's not causing pressure.
Oh, darn it. I guess that's not going to work either.
Can you have water in a vacuum?
No.
No.
No, so what happens is we know the phenomena, right, of boiling water. Up a mountain, it boils quicker up a mountain because there's less pressure. If you were to keep going up that mountain and reducing the pressure, you'll notice that the water doesn't actually require any heat to boil. It will start bubbling all by itself. And because of that, it will eventually turn to gas. You can't hold water in a vacuum. It will sublimate or evaporate, or is it sublimate? I think it's evaporate and turn straight into gas. I think the sublimation comes from if you have a block of ice within a vacuum, it won't turn to water. It will skip that step and turn straight to gas. That's called sublimation, which is a bit of a problem when you've got ice rings around Saturn.
Or ice caps on Mars.
Wrong. No such thing.
Darn it, hang on. Let me try to find a way to save my ball. Hang on. I'll come up with something.
What about a gradients? Can I have a gradients in a vacuum?
Wouldn't be a vacuum. You've got gas in it. It's not a vacuum anymore, is it?
And also, yeah, you would have a gradient because there's no such thing as a true vacuum. So you can have it both ways. You can have your cake and eat it too.
Damn.
The only way you can have a gradient in the vacuum is if you have an area within the vacuum that is inputting gas into the system. You will probably have a higher pressure there because it's rushing out into the wider environment. Further away, you will have a lesser pressure because there's less gas molecules. Further and further away, less gas molecules, right? I guess if you're talking about putting something into a vacuum, you could measure the differential in temperature close to the input and further away. That would be about it, but it wouldn't be a vacuum because you're putting gas into it.
What about the ozone layer? Wouldn't that help?
Completely destroys the heliocentric model. This dense gas high up in the sky, according to you, the denser stuff should be on the fucking floor.
Wait, hold on. Okay, hold on. Pause. Let me think of something else. Yeah, that's not going to work either.
That sounds like an Ice Cube song. You can do it, put some gas into it.
I like that. I might use that. That's quite cool.
Well, I conclude outer space is fake and has been abolished.
Hey, hold on. You can't say it's fake yet. Hold on. There's still so many other things.
The story about it is absolute bullshit. But there's still stuff up in the sky. There's more volume up in the sky, right? Where it stops, what it is, I don't fucking know. But the story we're told is bullshit. The sky's still up there, though.
What if we have a dark matter barrier containing the gas on Earth?
Oh my god, it sounds like you're really trying to make this work, dude. I mean, if we want to start invoking, like, dark matter, we might as well start invoking, like, wormhole. And like AI says, right, if they can bring these things in, then so can we. So if you want to bring in, like, antimatter, stopping the gas expanding, all right, mate. You're just going to need to prove it, aren't you?
That means all the stars are inside the dark matter barrier also.
Well, I gotta find some way to save my ball. How am I supposed to do it without invoking dark matter?
Well, I'll give you a hint. Yeah, you're not going to by looking up in the sky. The only way you can save your ball is by looking at the floor and measuring it to see if it has measured curvature. That way and that way only can you save your ball.
Well, it measures flat because I don't even want to say it. It sounds embarrassing to say, but it's so big.
All right, so if I've got a 7-inch observation height and I got 9 miles to the horizon, and what would the radius be?
Well, it could just be a bigger ball. Big, like extra huge.
But like, I mean, I did the math, and that's like 366,000 mile radius. Is that okay?
Yeah, I mean, as long as
that's absolutely fine. If you want to have problems with impacting the moon, we don't need to build rockets to the moon in that case, because the moon would literally be within the Earth's radius itself. Fuck, that's crazy.
All right, so how about 3.5 feet observation height and 13 miles to the horizon?
Well,
that radius is like
fuck, what, 500,000 miles or something?
I want to say it's like 127,000.
Oh, okay. 127,000 miles.
Yeah, and then like if you're a foot off the water and you look out and the horizon's 10 miles away, that's 260,000 miles. 264,000. Is that okay?
No, because your radius value keeps changing.
Fuck. So is my Earth expanding then?
For Lats to keep his ball alive, we'll say yes. It must be, right?
I mean, I'm cool with that. Yeah, that's okay. The Earth is organic, of course. You know, there's trees and stuff on it, but if the inside's also organic,
why don't you feel it expanding or contracting?
Because of what would they say? Gravity.
Fuck.
Gravity helps you not feel things like expansion and contracting of the tectonic plates. I'm surprised nobody's speaking up. Like, am I not butchering your guys' arguments? How many globers we got in here right now? I see like 1, 2, 3, 4, maybe 5. You guys are okay with me arguing for the globe still? You guys cool with that? Nobody wants to come and correct me on anything?
No, you can argue all you want. It's just that every 5 seconds, don't need to have somebody post something in side chat. I want to hear cerebral battle, not somebody getting shit on Google and posting it. I want to hear what you know.
Oh, about the globe?
Actually, I like the ones, I like watching the debates where they're actually physically, you can see them on the camera so you know they're not Googling anything. Those I like.
The camera, but
yeah. No, I'm not on, I could actually turn mine on, but I like watching the people when they're not, so you could see them on the camera, and then you can see if they're actually fucking AIing and Googling shit and then reading it off the screen to try to make themselves look smart.
You're like, I wouldn't mind getting on the camera, but I don't want anybody falling in love with me.
No, you don't have to, but you can tell when somebody's reading shit. I actually have an interface that will actually put it into an AI, and I can tell if they're reading shit off the internet.
Well, I mean, I'm not reading anything else. I just know
I believe
about
you, but I'm saying it's
I'm just one of
I'd like you to do that shit to me. I know 100% I'm not reading any stuff off the internet.
I didn't say you were. I'm saying there's other people that do that.
I know you didn't. What I said was I'd like you to do that stuff to me, because lots of people turn around and say you're reading stuff off the internet when I know that I'm not.
Oh, I know you're not. I know you're not. Yeah. I can tell you're not, and I know you're not, but there's a lot of people that do it.
Yeah, for sure. I completely agree, dude.
And I'm saying, let me see what's in your brain pan, man. Don't read it off. I want to see what's in your head.
Wait, what's wrong with Google and AI? They all know the Earth's a globe. They're just like my little assistant buddies to help me debate against Jedi and Professor Triangle.
Hey, Professor who?
Professor Triangle. Oh, did he change his name again? Wait, did he leave? Oh, never mind. He left. Just kidding. What was it? Sheepdog and who else was talking earlier? Was that Tito? No, you know what? Never mind. Ignore me. I might be hearing things. Never mind.
How does the sun work? Like, I'm not even being a dickhead. I'm asking.
That's a good question. Yeah, Jedi. How does the sun work?
Can you be a little bit more specific with the question? What do you mean work?
Like, how is it daytime in some places and nighttime in others around the Earth?
So that's due to the proximity to the light source. All right. Say, for example, you've got a light in your living room. That can be representative of the sun. So you can stand like under it, let's say, for example, and it'll be noon for you. If I'm at the other end of your room, for example, I have to point at an angle towards the sun. So the sun won't be noon for me. It will be, I don't know, let's say 4 o'clock in the afternoon because of the angle that I have to point up towards the sun. It's the same kind of premises like a sundial, right? Or a stick in the floor that creates a shadow. It's basically showing the movement of the sun across the sky. This is the basic premise for time zones, right? Depending on where the sun is, we can measure its location up in the sky. Now, the sun isn't always observable from every single location on the Earth. Let's say the ratio between the Earth and the sun is the Earth is much bigger than the sun, and the sun is, say, more local to the Earth. So because of this, the light of the sun can only illuminate a portion of the Earth. It is only visible from local portions. As the sun moves across the Earth, it's what creates time zones and night and day. There's going to be an area on the Earth where we can't see the sun. We can observe this in seasons as well. So how does the sun work creating seasons? That's because of the sun's daily movement across the Earth. We will notice every day that it rises and it sets on a different part of the horizon. Let's say it's summer for us. Let's say we're north of the equator. As it turns into winter, the sun will start rising and setting more south on the horizon. For those south of the equator, they see the sun coming towards them through the daily cycle, and the sun will start rising more south to them, closer to their location on the horizon. They will start to experience longer days, where people in the north will start to experience shorter days. If you're so far north in the winter, for example, you will experience perpetual nighttime. You won't be able to see the sun because the distance between your location and it is too far. For those in the south, let's say you're in the Antarctic Circle, you can see the sun for 24 hours of the day for up to about 6 months. So the sun works by creating day and night and seasons by its daily progress across and around the Earth.
Yeah, so the Earth is like what would you say, like a circle, you reckon?
No.
Or it's just like a plane of existence, would you say?
Yeah, to say a plane of existence. The boundaries of the Earth are not relative when described.
When you reach the edge.
You don't know about any edges, dude. We're talking about the sun, I thought.
Yeah, well, it's kind of related, though.
Why?
I was just thinking what you were saying about the light and the room. Like, say we're in a room. The room is like flat.
Yeah.
And the ceiling light is in the middle of the room. And so you're saying, like, hypothetically, if this room was the plane of existence, the sun like moves across the roof of the room. And if the light is on the far side of the room, on say the left side, and I'm on the far right side of the room, the room's still going to be lit up, right?
No, it's not. It's going to be brighter where the light is. It's going to be dimmer where you are, isn't it? And let's say if you keep walking away because of the inverse square law, yeah, definitely, then that light is going to be
you can test that in a room right now, though.
Dude, I'm just trying to give you an example of where the sun's going to be in relation to you, like standing underneath it or going away and having to point up at an angle to it, understanding that you're not directly underneath it and you want to understand how time works. This is why I try to keep things slow and get annoyed when people start talking off topic and about edges. It's demonstrating you weren't following in the first place, which I understand. Just ask questions if you don't understand.
No, I literally, I'm being so nice, bro. I'm being so calm. I'm like trying to be nice to you.
Cool. So you understand why we're in a room and there's a light above your head, and I have to point up at an angle towards the light because it's not above my head because I'm at the other side of the room. But this is how we understand time. Now, if the light can move towards me and then be above my head, you understand that I can point my finger at it in angle and measure it as it moves towards above my head. You, where it was above your head, will start pointing it at, as it moves towards me. Not at 90 degrees, let's say 45 degrees.
Say you're on the left side of the room and I'm on the right side of the room, and the light is above you.
Mm-hmm.
I can still like see the room lit up with light.
Okay, now let's make the room bigger.
But
so I'm really far away. Are you going to be pointing closer to the horizon or at 45 degrees if I'm really far away and the light is above my head?
Why does it matter if where I'm pointing? Like my eyes are absorbing light.
All away now. Is the light lighting you up as well?
Yeah.
Let's put the light 10 miles away now. Is it lighting you up? Can you even see it?
Well, I mean, that begs the question, like, what is the sun? You know?
Exactly.
Well, what do you think the sun is?
We don't know.
At the moment, it's just a thing that we're trying to describe, giving time and seasons and what it gives us day and night. I'm just trying to point out to you that the reason why it's day and night is due to proximity of the sun. Because I could fuck off with that light source and that light is going to have to pass through all of that air between me and you and become displaced. Right? That's why light looks dimmer the further away it gets. That's why you can look at the sun on the horizon at sunset and it looks red. Reason why it looks red is because of all the air that it's passing through. So eventually that air is going to be like a brick wall with distance. That light isn't going to be able to penetrate. But you're already going to see the sun perceptively from your location descend towards the horizon. This is just due to perspective.
Right. Another thing I've got is like the cycle of the moon. I did see this on Google. I won't lie to you, but I was thinking about it. So the argument would be, well, during nighttime, a certain side of the moon is like copying light from the direction that the sun is, which casts a portion of the moon is in a shadow, and say the lit up crescent is visible. How would you how would that be explained?
Okay, so this light, the sun and the moon are above the flat surface. I'm sure if you were to demonstrate this, you'd get a flashlight and a football representing the moon.
Yeah,
and as you go on, carry on.
I was just going to say, can we put this in the same scenario, like the room scenario? Like you and me are in this room. The sun is there, like moving across the roof of the room, and the moon appears. How is the shadow casted on the moon? Or how is the light?
It's just due to your relationship, I would think, between, let's say, right, when you see a crescent, right, that's when the moon ball is between you and the light that's casting it, right? When you see a full moon, you're standing in between the light that's casting it, turning around and seeing the full light that's cast upon the ball that's the moon. This is due to where you are between these lights, underneath them on the flat surface.
I mean, you could argue that it's like...
It's not exclusive.
I don't really understand what you're saying right now, to be honest.
All right.
Can you repeat that? Yeah, or just like...
Okay, so I'll tell you within the heliocentric... In the heliocentric model, we see a full moon when the Earth is between the sun and the moon, right? the full light of the sun is being cast on 50% of the moon. So as we're in between the sun and the moon, we turn around and look at the moon and we can see the full illumination of the moon. Conversely, if we were to put the moon in between the sun and the earth, that would be a new moon, where the light of the sun is illuminating the portion of the moon on the far side where we can't see it. So we see a new moon, which is the shaded portion of the moon. As it moves, what we see is a crescent moon. You understand what I'm showing you within the heliocentric model, yeah?
Oh yeah, I'm following.
Cool. So let's just say that there's a floor and you're standing underneath it with your head that represents the earth. It's the same thing, right? If the moon is between you perceiving it, between the sun and you, then you're only going to be able to perceive the shaded portion of the moon as you stand on the floor underneath these things in the sky. If you were to put the ball on the other side of the room and the light at opposite ends and you stand in between them, you could look at the sun and then turn around 180 degrees and look at the moon that was illuminated by the sun. It's the same thing, you're just standing on the floor.
Right.
Did you follow that, mate?
You lost me a bit at the end there, but yeah.
Yeah.
I mean, if you want to say the last, like... What?
It's kind of hard to explain. So you're standing up, and you've got the sun at the far end of the room, and you've got the full moon between you. Okay. Now
and the moon, the sun and the moon are globes. Sorry. Yeah.
It doesn't matter. Yeah, it doesn't really matter what the light source is. Right. So
wait, what?
A mate with a flashlight at the other end of the room. Okay. Can you hear me now?
I'm sorry. Yeah, I can hear you.
Yeah, of course.
The light bulb in my ceiling is shaped like a light bulb, therefore my floor is shaped like a light bulb.
You're standing in the middle of the room, and over to the far side of the room is the light source, the sun. The moon is between you and the light source. The light source is casting the light on the other side of the full moon, so you perceive the shaded new moon. Right? You follow this. Now, put the full moon on the other side of the room, so you are standing between the sun and the moon. You can see the sun, and then you can turn round and look at the moon, because the light of the sun is being cast directly onto the moon. You can perceive it because you're standing in the middle of it. It's the same thing within the heliocentric model. You're in the middle of the position when you see a full moon. You're on the outside of the position when you see a new moon.
Right.
I hope you followed that, dude. I really do. If you didn't, then it's probably me. I'm failing to explain it to you.
Yeah, I'm not going to lie, bro. I'm not going to lie. Yeah, I'm having a bit of trouble. Do you have like a video or something you can send me or anything?
I'll see if I can find something. Let's put it like this.
Sorry, bro. I'm so sorry.
No, dude, you're absolutely fine. It's just due to you and where you are, either in between the sun and the moon, or whether the moon's in between you and the sun. You know, when we observe a lunar eclipse, sorry, not a lunar eclipse, a solar eclipse, where the moon is in front of the sun.
Yeah.
Now, I can stand on a flat floor, I can have a light bulb that's the sun, and I can get a friend to walk in front of that light bulb with a ball, and I can block out that light bulb with the ball, which represents the moon. Right? That's quite easy to do on a flat surface. Right? Just block the light with another ball. Now, if I was to move to the other side of that, if I was to get my friend to move to the other side of that room that first blocked out the light, and I was to stand in between that light and that ball, I could see the light reflected off that ball because there's nothing in between them. I'm standing in the middle of that path. It's the same type of thing within the heliocentric model. It's just due to the location of where you perceive it. Either the moon is in between you and the sun, or you are between the moon and the sun, either underneath it or between it. Doesn't matter.
Yeah. I don't get how, so do you believe in the heliocentric model, or do you believe that the Earth, that it revolves around the Earth? I guess you'd say that it revolves around the Earth. I guess that makes sense, right?
Yeah, I would say the Earth is the floor underneath the sky. So the sun, moon, and stars do their patterns above us. We're not within the patterns. We're not moving around. We're not like a disk in space going around the sun. The sun and moon are in the sky. They're above the Earth.
I mean, I guess. I mean, you're talking about. I guess this kind of just like late. I mean, yeah. I guess I'm just like so. I can concede that. Sure. I don't know how that like proves the Earth is flat. I don't know if you if you have a video, I'll watch it. Like I'm not.
No, that doesn't prove. That's just what we observe.
Okay. Yeah. Okay.
Like if observations are empirical, then we observe a flat stationary floor underneath the sky above. That's what we observe.
And you'd call yourself you're like a full on empiricist, I'd say. Yeah. Like
with regards to this, yeah. Because this is only geometry at the end of the day. This is all it is.
Okay, that's interesting.
Well, if we're talking about the shape of the Earth, it definitely falls into the category of geometry.
No, I'm not. Yeah, okay. Another thing I was going to say.
I'm not being sarcastic or rude, dude. I'm not. I'm just pointing it out.
No, you're all good. The other thing I was going to ask is the edge of the Earth thing. Like, so how would you explain that? Like, is there a point at which it drops off, or
point at which reality stops, or you'd fall off, or you'd hit a wall?
This observable reality. Yeah. Okay.
I don't know, dude. It's a good question. We get it asked all the time, but it's in that realm of I don't know. I haven't got a clue. I mean, when I say I haven't got a clue, I can give you speculation, but that's about it. And I've given you a few, right? You could fall off. You could hit a wall. You could find the limitation of reality where there was no more three-dimensional space to pass into. You could go into a wormhole. All of these ideas, right? There are loads of them out there, but I have no idea. The best I can give you is if you're within a system and you want to know where the end of the system is, you just point horizontally in any direction. If you're within, then the edge is without. So I know where it is. I have no idea what it is.
Okay, interesting. I mean, I'm not going to lie to you guys. I just used Google. I didn't use it to look up an argument. I just used it to look up the guy's name because I forgot the guy who circumnavigated the Earth.
Dude.
Magellan.
Yep.
So, what would you?
He didn't go in a circle. He didn't go in a circle. He went north and south while he traveled east or west. I'm sorry.
Wait. But how did he reach? How did he get back home?
He started in England, and then he went down around South America, and then back up through Australia, and then back around under India, under Africa, and then back up to England. He never traveled in a circle.
I'm just looking up his voyage right now.
And
I've got to let you guys know because you seem paranoid about me using Google.
No, it's fine.
Not you, Jedi.
Which way did he travel? Was it east or was it west? Even though he went south and he left England.
He actually left from Spain. He went.
Okay, from Spain. Yeah.
He left from the port of Cadiz or Seville, I think that is. Maybe. Oh no, it's Portugal. Sorry, fuck, I'm an idiot.
So east he went?
No, he went straight down the Atlantic across the east coast of Africa, and then he went.
Yeah.
He crossed the Atlantic, down the coast of South America, went around the coast, around the bottom of the South America, and then, according to him, he went across the Pacific Ocean, and then all the way across the Pacific to reach the Philippines.
That's it.
And then he went down to Bali. And then from Bali, he went to the Cape of York, and then he went back to Spain from the Cape of York.
Cool. It was Cook that went the other direction, wasn't it?
Yeah. Cook found Australia. Yeah. Cook didn't circumnavigate, though. He circumnavigated Australia, which is just a continent.
Yeah, which is just circumnavigation, though, right? That's just circle.
Yeah, that's the name. That's the circumnavigation is.
Yeah. So when we navigate, right, we use tools. One of the tools we use is a compass, right? We want directions, right? North, south, east, and west. Now these guys, Magellan and Cook, they predominantly went west, wasn't it? Magellan, we said. So west.
He went. Yeah.
Yeah. So west is 90 degrees to your left from north, isn't it?
Well, I mean, you can't go straight west.
If we get our compass, if we get our compass and that's pointing to an actual location, right? And that we call that north. We got our compass out, which is a circle, north, east, southwest, and 90 degrees to our left, west, right? Cool. So if north is a point and you want to keep west at 90 degrees to your left, you'd travel in a circle, wouldn't you? Being as north is a pole in the floor, an actual location you can go to, and east or west are directions of travel around a pole.
That's you if can you travel in circles that the Earth is flat, though. Sorry to interrupt.
But you can travel in circles on a flat surface, can't you?
Yeah.
Please say yes.
Yeah.
Yeah, of course you can travel in circles.
Yeah.
The circle being a two-dimensional shape that's closed and equidistant. Yes. That point of radius is the north, and east and west are directions of travel around that pole. So Magellan went west. He went south. He went north. He went northwest. He went southwest, but he's going west, right? And he's going to end up where he started from because he went in a circle.
Right.
That's awesome. That's not exclusive to a sphere, is it? You can do that on a flat surface, can't you?
I mean,
yes, of course you can. It's a circle, dude. Come on.
Well, what I'm. It's just what confuses me about what you're saying is like, I mean, it begs the question, like, what do you think the layout of the Earth is like? You know what I mean? Like, do you think
we don't think it's a rectangular map that if you went east or west, you'd fall off the side of, because obviously that doesn't happen. We don't really know what the Earth looks like, say, from a God's eye point of view. We've just got lots and lots and lots of different maps. Now, the maps can take different shapes, dude. Square ones, circular ones. You can wrap them around velociraptors or spheres because they're maps.
This just gets into another argument. It just gets into another thing about empiricism, right? You know, like... So that's the real thing we're arguing here, you know?
Yeah.
At the end of the day.
Yep.
Right.
And empiricism and maps are going to be based upon what?
Human experience and human
measurements.
You know, a progression of the sciences. Yeah. I mean measurements.
Measurements.
No.
Yeah. Well, we're going to be making maps. If we want to know the true layout, we're definitely going to be measuring from place to place.
Yeah, okay.
Yeah, so measurement will be the empirical standard, right? The first measurement is the surface of the Earth. First one.
Yeah.
You want to make a map, you want to make a model, you're definitely going to want to make it representative to the Earth, so you're going to want to go out and measure the Earth. First thing you measure is
like Magellan
on the surface.
I'm sorry, I'm not trying to be rude. I'm just like, it just confuses me, like, because according to the Portuguese, this guy sailed. He went across the Pacific, like, you know, I don't get how the layout would work, you know. If you know, he didn't go from one end of, you know, he didn't go
around in a circle around a pole.
Yeah, but like I don't. Yeah, it's just. Yeah, I guess it just begs the question of the layout of this plane of existence, I guess. Yeah.
Yeah, it does. Like I said, we've got many maps.
Yeah. I don't know what that.
The circular ones as well, right? Which would help you understand, I think, how you would get from one location to another.
I'll look that up.
Yeah, but that's just a map. It doesn't mean that that's what we think the Earth is.
No, of course. I'm just...
Yeah. What you want to look up is AE azimuth or equidistant, or AE map.
AE map?
Yeah.
Oh, yeah, okay. Okay. You can just look up circle map of Earth, but I guess it's...
Yeah.
Yeah, okay. So like the North Pole would be like the center of the Earth.
The North Pole would be the center of the map in this map.
Center of the map, yeah, center of the map.
Yeah. How many poles have we got? We've got 2.
And
this one's only got 1 on it.
You don't necessarily prescribe to this map.
No, and I'll tell you why. How many poles has this map got on it?
2, which kind of is
kind of, yeah. They're not the same, are they?
What? No, I was just saying. No, don't worry. Yeah, keep going.
Yeah. So on the AE map, there's only 1 pole that everything circles.
Yeah, and the Antarctic is just like around the outskirts.
Yeah, just a ring. Yeah, just a ring around. So we would all be inside the ring of the Earth in this map. So the map isn't a true representation of reality. The map works if you use it correctly. There's instructions of how to use it, demonstrating that this can't be a God's eye view of the Earth. But it's a map and it works. But it helps understand circumnavigation. Really, in reality, we have 2 poles. 1.
Okay, but I mean, if we're taking, I mean, I can't really, if you don't prescribe to a model of what the Earth looks like, I guess then.
Yeah.
I guess all I can say is I guess we got to go to the ice wall, bro, and prove it.
So you can go to Antarctica and there'll be a wall of ice, but this doesn't mean that this wall of ice is surrounding the Earth.
Wait.
And going to a location isn't going to prove whether the surface is flat. To do that, you measure the surface.
Yeah. Okay. Yeah, I agree. But
cool.
So how does that in terms of like I mean the globe theory would be what we were talking about earlier about the sun and the sun going across the ceiling of say this flat plane of existence. The sun is going from one side of the room to the other. The idea of the
sun is going in a circle.
Okay. Then there's 2 poles, you'd agree? Yeah?
Yeah, there's 2 celestial poles, yeah.
And how does Antarctica not melt then?
How does Antarctica not melt? Because for 6 months of the year it's in perpetual darkness. And when it is illuminated, the sun isn't really that close. It's, only about, 22 degrees above the horizon in high summer or whatever it is. So it's due to proximity to the light source. The sun is still far away.
I'm sure you're aware of what I'm about to say, but like what a globalist would say is that the Earth is tilted on an axis and the poles are the 2 areas that are least exposed to the sun.
Yep.
So, and that's why they're freezing, Antarctic deserts or poles,
So I guess we go back to our really big room again. And we've got a heat source in the middle of the room. And we understand that heat dispels with distance, doesn't it? The further away from the heat, it gets colder.
But then how could Antarctica be dark for 6 months?
Because the sun moved away.
But isn't it rotating in a circle around the top of the room?
What, in the summer in the north?
So let's say hypothetically, if we're in this room, the North Pole is in the dead center of the room, and Antarctica is. Oh, okay. Where would you concede that Antarctica is on the edges of the room?
If we've got celestial poles, we put them in the ceiling. So we've got 2 celestial poles, and they're on the ceiling. We can stand underneath the celestial poles, and we can call one north, one south. And these would be geographical poles underneath these positions in the sky, the ceiling.
Wait, let me get out. I can't upload photos to the Discord chat for some reason. I think I'm too lower level. Someone's done it here. But I was just thinking, like, how I'm kind of picturing this in my head right now is, I mean, I don't know where you think the North Pole would be, but say we're in this room, right? This square room. All right, we won't say it's rectangle. A circle room.
When we bring up a room, the only reason I'm bringing it up is because it's got a flat surface and you can put things in the sky.
Yeah,
the room, doesn't matter how big it is. Let's just say it's so big we can't perceive the end of the room.
Yeah, like the Earth. Yeah.
Yeah.
You can't perceive the end of the. You can only see as far as your human eyes can see.
Yeah.
So it's,
or you can get some technology out and
okay.
see.
Interesting. But where? So how I'm kind of thinking is, if we're in the circular room, the sun.
Right. How do the lights in the sky work on a room? Right.
Pardon? Wait, can you just let me go for a second? I'm trying to. I just want to get you guys to explain what I'm going to say to me. I'm sure you got something.
Yeah, but the room's not circular. Right.
All right. Well, what hypothetically, what shape would the room be?
It doesn't matter about the shape of the room as long as the surface is flat.
Okay, if we're in a flat room, it doesn't matter what shape the room is. Let's say it's a square, a 10 by 10 square.
No, not 10 by 12. It doesn't matter because we can't see the end of the room, so it makes no difference.
Okay, let's say we have a vision of 10 centimeters ahead of us, and the room is 10 meters by 10 meters, just to make it simple. And you can only see 10 centimeters in front of you. Okay, anyway. The North Pole, in my model that I'm kind of conjuring up, I can't, you correct me if I'm wrong at the end, please. The North Pole would be in the middle of this, plane, and the continents kind of surround this.
I hate doing this, dude.
Well, I thought
No. I hate interrupting you because you said you wanted us to let you go, and I want you to finish your thought, right? But how do we know it's the middle? Why have we put one pole in the middle when we've got two poles? To know where the middle was, we'd have to know the entirety of reality to say that this actually was the middle. We've got no way to know if the north and the south are the middle when we've got two poles. You only seem to be doing one. So, at the moment, let's put two lights in the sky. Let's call one of them north and one of them south. We can stand underneath these lights in the sky and say that I'm at geographical from geographical south when I stand underneath these two lights. The lights are really, really far apart in this room we don't know the size of. So now we've got our north and our south. Now what do you want to know? There's two poles, right?
Yeah, there's two poles.
Yes, and we must have an example of what we observe. We observe two poles. So to represent really don't know the size of. That's all I'm trying to point out, dude. If we're talking about empiricism, then we must go by what we observe, and we observe two poles, not just one.
Why must you go by something you observe? Do you trust all of your senses?
Wait! Don't wait. But I was going to get into it. We'll get into empiricism.
Not granting that the environment we live in is not all physical, that there's spiritual aspects to it. Being obsessed with flat Earth is irrelevant.
Cool, thanks, dude. We appreciate that. High fives on you.
Yeah, you guys seem to be endlessly jacking each other off for year after year, thinking flat Earth is meta. It's not.
Okay, do you want to get involved in the conversation?
There's way ahead of you guys, and you guys seem to want to donkey kick those truthers. So
Jedi, don't listen to him. I'm trying to figure this out.
Yeah, I know you are, dude. You're fine. He's just a dickhead.
Okay, so
I just want to make a statement real quick, Koba, before you go on. The things in the sky do not dictate what's underneath your feet, right? We've said this repeatedly over and over again. If the surface of the Earth measures flat, then whatever's happening in the sky can only happen over a flat Earth. Do you agree?
Well, what I'm kind of getting at is if there's two poles and the sun, exists and rotates
in the south and 24-hour sun in the north.
No, that's not what I'm getting at. That's not what I'm getting at. It's not what I'm getting at. What I'm getting at, you're just assuming what I'm saying, bro. Please stop. I haven't been able to explain this idea.
You're taking a long time to get there, man.
No, because you've been interrupting me, all of you, for the last 30 minutes. I'm just genuine. Please, bro. I'm just actually, I'm hearing you guys out. No joke. Because I'm interested.
Cool. So
we can get into we can get into empiricism, but if we're gonna go back on that again and again.
No, I want you to finish we're in the room and we're doing north and south, understanding that we see north and south, so then we must be a true representation of what we're discussing. That's it.
So the North Pole and the South Pole exist, Antarctica and the North Pole. So if the sun, I would assume that this plane of existence is surrounded by a pole, because that would be. I mean, realistically, the poles are where the sun is the least strong, and that's why it's frozen.
Cool.
Which can only really be explained. I don't get how that can be explained.
Okay, cool. No, can't only be dude. You understand?
The sun crossing across the sky would melt it. No, it would affect the poles, and it would.
Sorry, hold on. When you stand at the North Pole, is the sun directly above your head at any time throughout the year?
Isn't it work like 6 months of the year? It's completely dark.
Listen to what I'm asking you. If you're standing at the North Pole, is the sun 90 degrees above your head at any time throughout the year?
Maybe at like midday. I guess. I don't know. Yeah, I guess at some point. Let me look
I'll ask you like this.
No,
maybe you'll get the.
I don't know. I don't have any.
And you'll understand, dude. I want you to understand.
But this is something you need empirical evidence for, no?
Hello.
This is something you need empirical evidence for.
And I'm trying to point to the empirical evidence, and you haven't got the observation right, because empirically the sun is never 90 degrees above your head when you stand at the North Pole at any point in time throughout the year. Conversely, on the equator is the sun above your head 2 times a year. On the equinox, you can point straight up, and there it is, above your head. If you were to stand underneath it, you would cast no shadow. At the equator.
Can I look this up? Like people in the North Pole?
Yeah, bro, look in the side chat. I got you.
Okay, sweet. I got an ad. Hold up. I mean, after this, we can talk about empiricism if you want, because we're just going to keep coming back to it at the end of the day. But yeah.
When we observe the 24-hour sun and right?
Wait, I'm watching this video, sorry. And I think you're cutting out, sorry. All
right.
It doesn't look like the sun is directly above you at any point when you're in the North Pole, in the Antarctica, sorry. It looks like it just crosses across the horizon and sets, and it stays quite low.
I am from Sweden. I've seen that sun 24 hours. It's never above your head. It goes in a circle around you. Okay. On a globe or a flat plane, it would do the exact same thing.
I'm just going off the video of the
Yeah. I'm just testifying to you as a Swedish person that have actually seen the thing. It will never be above you. It goes in a circle around you. Go there sometime and watch it.
The sun in the sky at Sweden. I mean,
yeah, okay. In northern Sweden, it goes in a circle around you. You can follow it. You can stand there in the middle of that circle and look up. It's never going to go over your head.
God, Google never gives you a straight answer, hey. Do you have a video? Sorry, I'm fucking...
Dude, you can Google any of those 24-hour videos from Northern, and I think there might even be some. There might even be some from the South now.
Yeah, that guy
sent eye links? And come on.
Yeah, yeah. Not gonna lie. I mean, again, we're just going to keep going back on empiricism. Like, that's all this is, really.
Well, at the moment, we're trying to understand how it's cold in places on a flat Earth.
Okay, but...
Right. At the moment, we understand that's proximity to the heat source. For example, if I've got a big room and the heat source is in the middle of the room, the ends of the room are going to be colder. Right, because of proximity to the heat source. Let's say there's even airflow and stuff. The room is constantly heating up over time. But you'd understand that proximity to the heat source. Right, the further away from it, the colder it's going to be. Now, the sun doesn't get anywhere near close to the North and the South Pole. It only gets, let's say, I think it's about 24.3 degrees north or south of the equator, if we want to talk about its progression in latitude. So it moves a little bit north and a little bit south. This is why in the south you can see it for 24 hours as it rotates around the South Pole. In the north, you can't see it because it's so far away, and fucking hell, it's cold. Even though you can see the sun rotating for 6 months of the year, the sun never gets above, I think it's about 24.3 degrees above the horizon. Its proximity to the South Pole isn't close enough to melt the ice that is there. Same with the north, the sun's progression. It doesn't get close enough to the center of the Arctic, as when you stand in the middle of it, you can see it rotate around the observer for 6 months of the year, never getting to higher than 24.3 degrees above the horizon. It's the proximity to the heat source. It's why it's cold in these locations.
I can agree to that. But so you're saying, like, in the North and South Pole, when it is bright outside, the sun will cross the sky, what do you say, 22 degrees above?
It's I think it's approximately that way, yeah.
Okay, but I live in Australia, and when it's the middle of the day, the sun is quite, high in the sky. It's like, I'd almost say it's in the middle of the sky, yeah.
Yeah, but you're close to the equator, aren't you?
Yeah.
Definitely close to the Tropic of Capricorn, I would have thought.
Yeah.
South Pole isn't, it's further away, isn't it? So you would have to, if you're further away from the light source.
Hold on. That there's a curve.
Hold on,
no?
Please. If you're standing in Australia pointing up at the sun, right, let's say it's 80 degrees up in the sky, right, almost above your head. If you were to back away from the sun on your magic helicopter or whatever it is towards the South Pole, and the sun was to stay in that position magically, you would have to point lower and lower and lower towards the horizon as you moved away from that light, right? Same as you would in the room. Remember, you stood underneath the light source and backed away from it and had to point lower and lower towards the horizon, right? This is why the sun appears to be lower in the sky in the South Pole when it's summer for you in Australia. It's high in the sky, but the South Pole's further away, so the angle to the sun here is lower, right?
So what would you say the rotation of the sun is then on a yearly cycle then? Because in here I experience a day and night cycle, yet in Antarctica they have the 6 month period.
Yeah, exactly. So, for example, in the summer in Australia, where you guys are in the Antarctic, they will experience a 24-hour sun. If they stand in the middle of this circle of rotation of the sun, you are standing underneath the circle of rotation of the sun. Right, you can't perceive the diameter to the other side of the circle of the sun, whereas somebody in the middle would perceive both radiuses equating to a diameter. So you can't perceive the full circle of the sun because you're underneath the circle of the sun as it circles directly more or less above your head.
I mean, I'm not gonna lie. I didn't really pick up on that.
Okay, it's fine, dude.
Yeah.
It's
if you
me.
can, I'm here to tap in.
Who's tapping in? Can I?
If we.
Okay, no, I'll let you. Sorry, no, you go, bro. I got to get food. You go.
So instead of having like 2 stars and all that, let's just talk about the sun. I mean, the whole world doesn't see the sun at the same time. If it was flat, I think we could. Or maybe the sun like moves back and forth and it like gets far away, and then we'd all kind of not see it. I'm trying to understand the flat Earth model here.
Why would you think that you can see the sun? Do you have Superman vision? Do you know there's something called attenuation? Light doesn't travel in this medium forever. We have air here. Like if you were to dive
we have air, and I can see the sun, yes.
Yeah, look, it's not transparent, okay? You can see it maybe 300-400 miles at the horizon level, and then you can't see it anymore. It's like if you go into a deep lake or ocean, you dive down, it's going to get pitch black really fast because there is something called water in between you and the light. And, air isn't transparent either. So, no, on a flat surface or round, it's just going to go away eventually. You can see this when there's a sunset, the light turns red. That's the last light you see on the spectrum, right? So it takes its lights with it and it leaves. And you cannot see it anymore.
So, unless we're denying the distance to the sun or the size of the sun, I mean, wouldn't we all kind of not
Yes, we are
see the sun
definitely
at the same time?
denying the size and the distance to the sun.
Yeah, we don't have any empirical evidence for either of those assumptions, right? So if you picture yourself in a huge warehouse, hundreds of miles wide, it's completely dark, and you put a little light above you, and then you move it on a rail over to another place, circle it around in the warehouse. You're not going to see it, and there's going to be complete darkness where you are, and it's going to be light in some other part of the warehouse. Super easy to understand.
I'm not sold on that. I'm not sold on it. So let's say our warehouse.
Hey, just so you know, we are denying your entire cosmology.
Okay, that's fair. Okay, so back to the warehouse. Let's say it's like 100 miles wide and long.
Why?
It's 100 square miles or any
Why
distance.
are you guys obsessed with distance? We don't care about the size. As long as we've got a flat floor and a ceiling, it's fine.
Okay, that's fine. It's a huge warehouse. We won't focus on the distance. And we have a light just going far away since we can't use any numbers here. We would probably see that light. If it's flat, when would it go out of distance? It would fade out.
Okay. So let's imagine, just for a moment, we've got, instead of the long room, we've got a corridor. Now, we understand that when we look down a corridor, the walls appear like they're getting closer together. The ceiling and the floor look like they're getting closer together. Right? This is how perspective works, right? We're going to have convergence of the ceiling and the floor at distance. Now, where that convergence meets, that's not the end of the room. That's the end of our perception. The room still extends beyond the convergence point. So if you've got a light on that ceiling that's beyond that convergence point, you might be able to see the light. You might be able to see light, but not the light source itself. You understand, right? You're going to have a convergence between the ceiling and the floor, or the light source and the floor with distance. Now, if the floor and the ceiling still keep going beyond your convergence, you still might be able to see some of the light, but not the light source itself. If you keep moving that light source away from you, the light is obviously going to diminish. You're going to be left in complete fucking darkness if the light source is far enough away from you. That's why you need lots of lights in warehouses.
That's the core. That's what I disagree with.
What, convergence? All right, here's AI.
If the light source is
hold on, Freddy friend.
then the light wouldn't hit us. Like the light wouldn't hit our eyes if we couldn't see the light. It would be bouncing off the walls of the corridor.
Here's the problem, bro. So it's a well-known, established fact that the atmosphere that we live and breathe in is not transparent, right? So in other words, it attenuates some light. Now, there's actually a formula called the Rayleigh extinction coefficient that you can apply to the wavelengths of light according to the standard ambient atmosphere, that they calculate. And that means that about 300 to 350 miles, the atmosphere is functionally opaque. That means you cannot see through it. So if anything is beyond that distance with a straight line of sight where the light is coming towards you, you won't be able to see it. Now, you might say, well, I can see things when I look up. That's true. That's because the atmosphere wanes off diagonally. So the more you look up, the less atmospheric coefficient there is. So in other words, horizontally, you can only see 350 miles max. But you start looking up, you get a little more distance. So you can imagine the atmosphere as a fence that you can't see over. Now, it's also known that stars and things can't be seen above a certain degree above the horizon for that reason. And so it's already well known that when an object in the sky goes far enough, I know that's great and all, but we're talking about the Earth. So I'm just telling you the facts of the Earth. See what I'm doing, friend, is I'm just foregoing all of these. I know that's fine, But I'm just foregoing all of these metaphors and just telling you the reality of the physics of the world. Okay?
I can't
so
trust
it's
any
well
of that
known
stuff you just said. I have no clue what that means. So the light.
I know. Listen, friend. Let's be clear here. Mr. Raleigh, who did all of this, is a well-established, world-famous scientist. All kinds of things are named after him. The Raleigh criterion, the Raleigh coefficient, et cetera, et cetera. Okay.
Appeal to authority.
Raleigh hamburgers too.
Appeal to authority.
Dude, just go Google it. You can educate yourself on this light attenuation. This is ridiculous. Admit that you were wrong and you didn't know about
he
this.
butted into this large corridor.
No, he explained it to you, and you need to understand it or go away. Okay?
Well, I'm going to finish what I'm saying, and that is that it's known that in the standard atmosphere, there's a diagonal range where you can't see anything, and they know that any celestial body that passes below that angle from your observation point becomes invisible. And that's above the surface of the Earth before it even would hit the plane of the Earth. So yes, it is the case that if there was a bright light, including the sun, that was in that zone, you would not be able to see it. Keep in mind, when the sun approaches the horizon, it's 23,000 times less bright than when it's above your head. All right. I have to go do some work.
I don't know how to prove any of that. Are we going to continue this large corridor experiment?
Listen.
Can I butt in real quick?
Let me give him this point, and then I'll shut up. Listen to me. Have you ever seen mountains in the distance? They look a little bit like blue. You don't see them too clear because they're too far away. Do you understand why that is?
I mean, can we return back to the long corridor? I'll answer that. That's fine. But are we just abandoning
Just answer
this thought
it.
experiment?
Have you ever seen mountains in the distance? They have a little different color. They're like hazy because they're too far away from you.
I don't know.
You've never seen a mountain turn like bluish or hazy in the distance.
I live in the southeast. There's no mountains here.
Yeah, you see things, they haze away. You can't see things forever because there's air here, an atmo. God damn it. You guys do whatever you want with this guy. He's totally retarded and low IQ.
We started this hypothesis where we're in a large warehouse,
low IQ,
and then we switched it to a corridor.
Low
now we're
IQ.
abandoning it. Let's go back to it.
Just take him out.
Someone butted into the conversation, and now we're trying to steer away for some reason. We were talking about a long corridor, and we were doing a thought experiment.
Yeah, what about it? Right, let's entertain it. Go ahead.
Let's get back to it. Okay, so if this is something like where a light source goes down this very long corridor, the light would fade out. We wouldn't see it get out of perspective.
Well, it depends on how long the corridor is. Okay, like AI Overlord was trying to explain to you, there's a maximum distance that you can see through the medium of air. It's 300 miles, 400 kilometers. That's under perfect ideal conditions. Think of it like this. Let's say you have a perfectly clear pane of glass. Okay, you can see through it just fine. As you keep stacking and stacking and stacking more panes of glass, it becomes more and more opaque because it's not perfectly transparent. Same thing happens with the atmosphere.
I accept.
Yeah. Like if you're standing on a mountain and you can see mountains going off into the distance, each one gets a little more hazy looking because you're looking through more air, and then eventually you can't see them. Same thing's going to happen anytime you're looking through the air. Depending on how clear the air is, you're going to see less or further. And you could check the visibility report anywhere on the Earth, and usually it'll be 20 kilometers, 30 kilometers, or something like that. Sometimes 50 kilometers. Just depends on the location.
I completely accept that. So, is this saying that the sun is essentially fading out and fading in every day?
Well, we also see in perspective as well. So, while the sun may appear the sun's much brighter than anything else that you're going to be looking at.
Yes.
Okay, so you also have linear perspective to take into account. So, the same reason, say we're looking down the hallway, like you gave the example of, everything's going to. Okay, everything's going to converge into what's called a vanishing point.
Yep, I accept that.
Yes, yeah. So the same thing happens when we're out in reality. If we're looking at a plane going off into the distance, or something like that, right? It looks like everything goes down and converges into a vanishing point. Okay, so we see the same thing happen with the sun, the moon, the stars, planes, clouds.
The problem is that the sun doesn't vanish. The sun essentially goes out of view, like below the horizon.
Well, if you go onto YouTube and you try to find a sunset where there isn't there's a difference between the natural horizon, right? Like the perspective horizon. Some people call it the apparent horizon or the true horizon. Or you can have what's called a local horizon, and that's when you have something blocking the actual horizon. Let's say you have some mountains, or you have some big ocean swells, or something like that, or just land in front of you that's a higher elevation. In that case, it does look like the sun sets uniformly from bottom to top. Okay, but if you go on YouTube, and I spent a whole day the other day watching sunset videos. I watched all the ones I could find. If you can get a nice clear day looking out over the ocean when you don't have any local horizon blocking the horizon, the sun doesn't quite do what you think it does, right? You got to zoom right into it and watch it go down, and you watch what happens. It kind of vertically compresses into the horizon. The horizon's kind of, you can think of it like the vanishing zone, okay, due to the way perspective works and also the atmospheric conditions. And I guarantee you, if you go and look for sunsets like I'm talking about, it squishes into the horizon and then it just kind of fades off. I can put some examples in the side chat, but I couldn't find a single example where it didn't do that, or it didn't do something completely crazy. Some look like a mushroom cloud, like it does some crazy things, like a pyramid or just something insane. But most of the time on a nice clear day, it will sort of squish into the horizon, unless you're watching it set over mountains or behind big ocean swells. Like if you're down low to the beach and you're observing the sunset and you've got big waves in the foreground, that's classified as a local horizon. It's going to be blocking your view of the actual horizon. And then it's going to look like
DJ, I just wanted you to know. Sorry, there's a shit ton of evidence inside.
Oh, thanks. But yeah, go and check it out. It's interesting when you look into sunsets are not some uniform thing that happen the same all the time. There's lots of footage where it just looks like it just goes off into the distance and it just fades off into whatever you want to call it. Some people call it the atmospheric deck of opacity or the vanishing line, and it kind of vertically compresses into that.
I mean, the problem is that the sun doesn't get that much smaller, really. I mean, if any at all, as it passes through the horizon. Like, if what you were saying is correct, the sun's getting further away. I mean, similar to a plane going far away, we just simply can't see it. It would be like fading out.
Yeah,
it just gets smaller and faded out.
No, look, it's a perfectly logical statement that you just completely agree. But it's very different if something's in your very close to you, like a big object's very close to you, and then it moves away from you. You're going to have a huge change in its angular size as it moves away. Like, let's say you lay down on the floor and you got a tennis ball in front of your eyes, and then you roll the tennis ball away. It's going to look huge, and then it's going to get tiny as it rolls away. But if you stand up and look down at that same tennis ball and then roll the tennis ball away, as it moves away from you, it's not going to have that same dramatic effect again. So if the sun is already a huge distance away from you, and then you're just seeing it go down a bit in your perspective, right, in your field of view, it's not actually having the opportunity as say that ball was when you're very close to it, or a plane or a car, right? If there's a car in front of you and it goes away, if you look at that same car from a higher height, as it goes away from you, it doesn't have that dramatic effect. Now, the sun does change in angular size a little bit as it goes down towards the horizon, but it's only about 0.5% or something. It's not a huge amount. But if you watch it through a solar filter and then compare when it was higher in the sky to when it's lower, it definitely changes a little. It's kind of hard to wrap your head around. There's some good demonstrations that show how it works, kind of like with the tennis ball example that I was talking about.
Can you send in a video, Goblin?
I just posted a picture, and we can ignore all the text, but I mean, if this was truly the sun getting further away, wouldn't it look like that? We would clearly see the sun getting smaller and then fading away.
I'll tell you this much. If you take that picture and you take that top sun and you put it next to that bottom sun right before it starts to get obstructed, the bottom sun's going to be smaller than the top sun. It's just a fact. You're not doing everything you can to take your measurement.
Yeah, it would absolutely not do what it looks like in that image there that you posted. I don't know who made it. That's silly. That's what something would do Like if something was right in front of you, your face, and then it moves away from you. A cruise ship or a car or something like that. The sun is an apparent light in the sky that's already a huge distance away from you. You're seeing it in an apparent location personal to you and your field of vision. Okay, so as it's moving away from you, it's not a huge distance away, that horizon that you can see. It's appearing to go down due to perspective, not because it's some crazy distance away from you. It's a perspective effect, and it's an apparent light in the sky. And you're seeing it in a unique position, depending on your location.
Can I butt in real quick?
Sure.
So I think this is just going to end up coming up on claiming empirical evidence. We need empirical evidence of this. Another thing is when you're looking at a sunset, obviously the sun produces a glare. The observable light that you see in the sky of the sun and the glare that it's or the light emitting off it it's producing isn't necessary in the observable eye or even in the camera. It's not necessarily it's not like the sun's getting bigger just because the glare gets more intense. Is one thing, but I'll let you go off on that. And then can we
when it gets down lower to the horizon, it's kind of like a natural solar.
Yeah, but that doesn't
stare at the sun when it's.
You could that could definitely be the case if the Earth was a globe. That doesn't really.
Yeah. Look, there's an apparent light in the sky. Look, this is what the determining factor is. If we can just go out and measure over the surface of the water, we can easily determine if it's flat or a globe. That's what it's always going to come back down to. Looking at lights in the sky and making a bunch of assumptions about them, that's not really going to get us anywhere. It's going to get circular. But if gravity is real, right, if they say mass attracts mass and everything's being drawn towards the center of the globe, right?
Ugly dog, please mute. Please mute.
Whoever's doing that, mute immediately or we will mute
Ugly dog. Ugly dog. Please mute that cunt. Holy shit.
Yeah, he only did it because DJ's getting to the crux of the matter and he has to interfere. Same thing that always happens.
Yeah, look, if
carry on, DJ.
Jeez, India. Yeah, if gravity is mass attracting mass, like they say on the globe, and we have, say, 10 miles distance over the surface of water, anywhere on the globe, any elevation, ocean, lake, it has to have approximately 20 meters of curvature or 66 foot of curvature over that distance. If it doesn't have that, that would debunk gravity. That would debunk mass attracting mass. That would debunk the globe. But we haven't just checked that one time. We've checked that hundreds, if not thousands of times over 10 miles, over 20 miles, over 30 miles. And we're consistently getting the results of zero curvature.
Yeah,
we can show all of this as well.
I mean, again, what you say about you can show all of this. I mean, it's your argument that it's. I mean, you can only claim the empirical evidence of the things that you can perceive in your own vision, right? Is kind of what you're getting at. But in the same way that.
Go ahead.
No, you go.
Well, look, we have high definition videos where people turn up to a location. You can see them setting up their camera equipment. Okay, they're logging their observer height. They're calculating the distance across from point A to point B. Then they're saying, okay, on a globe, the horizon should be at X distance, and there should be X amount of obstruction of what I can see on the other side of the lake. And if it's not doing that, then that's a problem for the globe. So then we can test it, and then we can test it again, and test it again, and test it again, and do all sorts of different methods, and say, hey, every single time we check the Earth, we can't find any curvature. Who checked it? Who actually has the empirical evidence from the globe side that it's actually curving? And then once you start digging into that, that's when you'll start noticing, oh, shit, there isn't any.
So you claim that flat earthers have empirical evidence that they can measure. Well, obviously you can measure the ground in, if I'm in a plane of, let's say I'm in an area of the plane of existence that we live in. Take a 10 by 10 chop of the world anywhere, middle of the desert. And this desert is... hypothetically, there's no dunes on this desert, and it's just like flat. We're on a beach or something, and it's dead
like
flat.
the surface of water. Because they say 72% of the surface of the globe is covered in water, so that's the best place to do it because they call it water level, right? So on a globe, they say the water level is, an equal distance from the center of the sphere. So you would want to do it somewhere where you don't have elevation changes in the landscape. Okay, so the surface of water, frozen lake, regular body of water, whatever.
I mean, there's so many questions this raises. If you're gonna get into like gravity and shit, it's like, how do these globes in the sky orbit our plane of existence?
Well, whatever's happening in the sky, right? If you can validate that the ground's not curving, let's say you have a room in your house. You can take different measurements all over the surface of your room on the floor, and it looks flat and it measures flat. Whatever's happening up in the sky above you with the lights up in the sky, it's not going to make the water start curving. It's not going to make the floor start curving.
But the argument of like, I don't know, a planetary scientist would be that, the Earth has a center of mass, which dictates the there's a way in which
it makes the Earth a sphere.
This is hard to imagine in my head because I'm constantly switching between the heliocentric model and the idea that these planets are revolving around our plane of existence, but
they're not revolving. I mean, you're trying to make up things in your head, like of how it works, how the sky works.
I've been very nice, India.
No, I'm not being mean, dude. What are you talking about? No, you're just making shit up in your head. What's the evidence any planet orbits the Earth?
All right, well, we're getting into empiricism again. So this is kind of where I wanted to go with it, because we're just going to keep folding back on this. So, all right, we'll get into this. So you guys claim for everything in your life, do you need empirical evidence to believe something? Or do you believe things without...
No, I'm saying that, dude.
Believe, empirical evidence for a belief. Belief is acceptance without evidence. We need empirical evidence for knowledge.
I wasn't done, but yeah.
Well, you saw me in, so I let you continue.
I'm just gonna talk and hope that no one interrupts me, I guess. I'm not gonna go for long, I promise you. Okay.
Just let me get my straw man in and don't interrupt my straw man.
All right,
no one believes what you just said. So we demand empirical evidence for claims about the natural world. It doesn't mean that things can only be proven empirically. Obviously, that's not true. Because there's things which aren't empirical, such as numbers, mathematics, logic, which don't exist in the physical and natural world.
Yeah, because they're
empirically. Yeah. They're transcendental categories. They exist. They can be true. But this isn't a transcendental issue. This is a matter of what exists in the natural world.
Okay, yeah, that's an argument of empiricism, no? And that kind of gets into the idea.
It's not about truth.
Well, I mean, what? Anyway.
This is an ontological question. This isn't an epistemological question. Okay?
Yeah, before you start wondering if your senses are reliable, let's just see what you sense first. Let's just go through what you sense.
Me? Yeah, can I? This is kind of what I was gonna. Can I go first? I'll be like 30 seconds.
Yeah, please, dude. Please. Yeah. What do you want to say?
I'm trying to get it in, but I'm not allowed to, apparently. Anyway.
No, you will be.
All right. So what I was just kind of going to go off is like, do you, if you guys require, empirical evidence to believe that the Earth is the way that you imagine it, do you guys have anything in your life that you kind of believe without empirical evidence? Say, I'm personally religious. Like I have a belief in a God, and I can't confirm that God exists, but I have admittedly a blind belief in it. The same way I kind of blindly believe that the Earth is a globe. It just feels like you guys are being selectively, being like selective about how you are cynical about these things.
How long did it take you to construct this sophistic argument?
It's not sophistical, bro. It's
sophistic. Sophistry.
Well, you're the one being sophistical, but
let's try and be specific.
I was very specific. I said empirical about things of the natural world. God is not the natural world. So you're comparing apples to oranges right off the rip.
That's true.
So do you? Let me. I mean,
by the way, Raul,
it doesn't have to be God.
Raul,
let me ask you this: are all things proven the same way using the same methods?
Yeah.
No.
Yeah. Oh, dude. No,
Using
they're
logic,
not.
yes. Using logic, yeah. Using your logic.
Well, that's to make the argument because you need the 3 laws of logic and you need certain things, but you're not using the logic as the proof of the thing.
I'm not. I have a blind belief in the Earth being a globe. You are correct. I do.
Yeah, do you know why it's a blind belief?
Why?
Because you have no qualia from which to believe that, meaning you have no sense data of the external world that tells you that the Earth is a globe.
And
there's nothing in your memory that you can look for and say, yes, I remember the Earth being a globe at this time, at this place, when I experienced this. Nowhere is it in your memory. You have no qualia from which to substantiate it. Whereas the Earth being flat, you have plenty of that. You have your entire life.
Like what? Like what?
Just anytime you've been to the ocean, a river, a freaking beach.
None of that proves the Earth is flat. None of that is empirical evidence. We live on a flat plane. No, it's not.
Seeing a flat Earth is not empirical evidence of a flat Earth.
Okay, bro. Like again, this
is it or not? Is seeing a flat Earth empirical evidence of a flat Earth? I didn't say proof. I said evidence. No, you're trying to rationalize away why it's not proof. I said
yes, I am trying to rationalize it.
Why it's not proof?
No,
I asked you, is it evidence?
It is like very shaky evidence that can be disproven by other evidence. It can. Well, it's just as shaky as the evidence that the Earth is a globe. So
why is it shaky? No, you have no qualia. You have no qualia.
You are being selectively skeptical of what.
No, that's your shtick. You're going to try and pull your fucking weak ass argument, your sophistic argument.
Give me a rebuttal. Give me a rebuttal. Give me a rebuttal. Give me a rebuttal.
I just did. You have no qualia from which to believe the Earth is a globe. There's nothing from your.
Neither do you.
Flat. I just gave it to you. I go to the ocean and it looks flat.
That's dude. That you have what you see isn't the definition of reality.
Really simple.
In your vision.
Okay, when I go to the ocean, shut up, dude. When I go to the ocean and it looks flat, what is that evidence of?
What is that? That's evidence of nothing, dude.
It's evidence of nothing. Looking flat is evidence of nothing.
Right now, it is evidence. It is evidence.
Flat is evidence of nothing, dude.
Stop interrupting me, retard.
Oh, now I'm a retard.
Yes, I mean, don't worry about it. Looking out at the ocean is not. It is evidence that due to the limitations of your perception can perceive that the Earth is flat.
How
do I know that you have? How do I know
the
that
man on TV told me so?
Vision.
Sorry, it doesn't matter about the limitations.
How do you know the limitations of your vision make the Earth look flat, and it's not flat just because it is? It looks flat because it is flat. How do you know that? Because you know what looks flat? Flat things. And using Occam's razor,
the man on TV told me so.
Yeah, so the simplest explanation, if you use Occam's razor, says the Earth is flat because flat things look flat. It is evidence that the Earth is flat. You don't have any sense evidence that the Earth is a globe at all. None. Zip. Nada.
Neither do you.
You looked in a book.
Neither do you.
I just gave it to you. Looks flat. I don't even have to get into measurements or laser tag or anything like that.
Dude, you have to understand that you going out with, and you're a human being. You have,
I do understand your argument, but that's a second level argument. Okay, we're still at just perception of reality. Just a blank perception of reality is that the Earth looks flat. Okay, you're trying to think of reasons why that perception is false.
Well, there's plenty of evidence that proves that it is false.
Like what? That proves that it's false. Like what?
Bro, I don't know. I forget the
dude. I don't know. There's plenty of it, but you don't know what it is.
I'm about to answer you, fucking idiot. How about the Greek guy that measured? How about the Greek guy that measured the obelisks in Egypt? He measured one at Alexandria and he measured one in Nubia. And
and how does that?
The shadow was different.
We went through this earlier. Sorry, Indio. We actually went through this earlier. He's
no way. He really went back.
Oh no. We're not, because we're not digging into science. I'm making an argument about empiricism. This is just an example. I'm not. We talked about this earlier, and it just leads into an argument of, do you believe in the empirical evidence or not? And it's like, yeah, that's not...
Indeed. We showed you and we walked through what the empirical evidence was, as in what Eratosthenes did. He measured a shadow length to calculate an angle.
Yeah.
That's what he did.
That's the empirical evidence.
Curved. Yeah.
No. Why? Why do you say that?
Well, it's just as good of a case of evidence as you saying, well, I looked into the distance and I saw that the Earth was flat.
No.
Can you understand
because
that?
What I'm doing, because what I'm doing, looking at the surface of the Earth, is looking at the thing in question. You're looking at shadows, not the Earth. You're looking at a shadow length.
Oh, I mean, we're just running into a wall now because as soon as
then you don't understand basic logic. That you're making indirect inferences off of looking at something that's not even the thing. Okay, let me ask you this.
Well, Raul, like what I'm hearing from you, Raul, is you're saying there's no way to come to a conclusion on it. If that's the case, then there's no conclusion that leads you to the Earth being a globe either. That's in your term.
He's not even looking at the thing in question.
Well, no. That's kind of exactly what I'm getting at. Is that if we're going to go off empirical, I'm conceding that in reality I have a blind belief in the Earth being a globe. The same way I have blind belief in many other things in my life, and I'm sure you guys blindly believe things in your personal life.
Nobody believes anything blindly, but that's a separate topic.
Well,
in this case, they do believe the globe blindly because they don't see one.
Well, let me ask you. I don't know who I was talking to that wasn't Indio, but I want to talk to that guy.
Of course, you want to talk about DJ. You want to talk to anybody but me.
Indio, you lispy retard. You have a thick head of a brain, and that's why I don't want to talk to you.
No, you don't. No, you're a sophistic cock, and you think you're slick, and you think you're going to get away with it, but you're not. I demonstrated how you're a sophist. You literally claimed that looking flat is not evidence of anything. You are an utter retard, sir.
I actually said that it's proof.
Looking tall is not evidence of being tall. Looking short is not evidence of being short. Looking flat isn't evidence of being flat. Looking curved. Hey, dude, when we look at the Earth as a ball in space pictures, that's not evidence of it being a ball.
Yeah, neither is you looking into the distance. That is proof. That is empirical evidence that through your limited perception of reality, you can see.
How do you know that?
How do I know that your perception of reality is limited? Because you're not fucking God.
How do you know that? No. So that was a two-part thing. Okay, you said because of my limited perception of reality makes it look flat. How do you know that?
I know that your perception of reality is limited.
No, dude.
What are you asking?
Dude, I just told you. You just did the same thing twice like an NPC you are, okay? You said a two-part thing. It looks flat because we have a limited perception of reality. Is that correct? Is that your claim?
Yeah, due to your vision.
Okay,
and
how do you know that? Okay, how do you know that? That it just looks flat because of those reasons.
Repeat that, sorry.
Yeah, you don't. You don't
repeat
know
that. I asked you to repeat your question because I didn't understand what you said. I just said repeat it.
How do you know that it looks flat because of those reasons?
How do I know that it looks flat? What do you mean? You can look out into the sky.
Dude, don't do it again. Don't do it again. Don't do it again.
Don't do what again?
You straw man one more fucking time, you're getting banned. Okay, that's 4 in a row. Literally 4 in a row.
Do you guys ban like people? This is interesting. Anyway,
why will you be getting banned? What did I just tell you? Repeat it back to me. What I just told you. Why you're going to be banned?
Indy, I'll tell you what. Indy, I don't want to be loud. I want to have me and Jedi were having a great conversation. It's very civil.
You have 3 seconds.
Great to talk
3, 2.
Don't ban me. I want to talk to you, bro. I'm genuinely interested.
Answer the fucking.
I forgot what your question was. What was your question?
No, you didn't. That's the 5th time you didn't hear the question.
I forgot.
Yeah, shut up, dude. Sorry to spoil everyone's party. That dude's a cunt. I don't know what kind of cunt, if he's an English cunt or an Australian cunt, because we use cunt different here in America, but he's a fucking cunt.
Can't understand normal thinking kind of cunt.
He's an inbred kind of cunt.
Yeah, according to him,
absolute dishonesty. It's just absolute dishonesty, dude. Just pathetic. Now these are the people that really make me mad because he's trying to obscure the truth intentionally. Even though he just admitted to us he has a belief. So he's trying to obscure the truth to protect his own belief so that people believe what he believes. How fucking retarded is that? If anybody wants to talk to him, they can unmute him. But I have to not listen to that shit. Because I'll wig out.
Yeah, according to him, even though Indio looks like a lumberjack, he could still be as beautiful as Jessica Alba.
He has no idea what I look like. Shit his pants if he saw me. He would, man. He'd blow a fucking load of diarrhea. Thinks I'm a fat fucking, Dorito muncher like him.
I'll give it another go, mate, but not if you're going to leave the room.
No, I'll listen. I just won't say anything. I'll just bite my lip or something.
Am I muted? Sorry. Can I talk?
Should be. Loser.
Does anyone want to go first?
Go on. Yeah, go
on. You want me to go first? So first off, I want to say I'm sorry, Indio. I forgot the question you asked me, which is why I couldn't answer it. I would have been happy to do so. I don't know
how many questions did you forget. How many? The last how far back? Because I've asked you a bunch of questions. How far back? When's the last time you actually heard the question I asked you? Yeah, that's right.
Well, what do you mean? That's right.
Yeah, 4 times in a row you asked me. I didn't hear. It said to me, "I didn't hear your question. Can you say it again?" 4 times in a row.
Yeah, because you weren't telling me what the question was. Anyway, we're not going to go through this again.
Different questions, different times, not just that specific one. You did it previously. You think you guys are slick? You're not, dude.
I can debate
you and count how many times you're dodging questions and how many times you're fucking repeating yourself. I can do all this stuff all at the same time because you're speds, dude. You're not clever. Dude. This is like the weakest fucking server. The fucking Indians on the fucking English Hub server have better fucking chops than you guys.
Okay,
can barely speak English.
You can barely speak English, but anyway, I'll talk to anyone else. But anyway, Jedi, do you want to
speak English? Just fine. Ask your mom.
Okay, Lispy boy. Jedi.
All right. What are we talking about?
Well, I was talking about
mom.
I was talking about empiricism.
Okay, is measurement? You were speaking earlier about our limited perception. You understand when we make the using our human really technology, camera.
You're cutting out, Jedi.
All right.
Sorry. Yeah, go. Yo.
Can you hear me any better now, or do I keep cutting out?
You're good. No, you're good.
All right, good. So when we say that the Earth looks flat, you understand that we're not just using our human eyes. Right, when you say that we've got limited perception, we're also using technology, right? We're using binoculars, high-powered zoom cameras, telescopes. Furthermore, we're measuring with tools like lasers, theodolites, other such things. So when you say that our perception is limited, is that based on the angular resolution limit of the human eye, which we know about? Is it based upon the atmospheric conditions, which we know about and can describe? We understand our limitations. That's why we use technology. The point that I'm trying to raise is, if we're even going to start any type of inquiry into the physical natural world, let's say it's going to be scientific, we're going to be starting with observations, right?
Yep.
It's going to be what we see.
Yep. Taking technology. I'll be so quick. Taking technology into account, obviously that does expand our perception of reality. So you talk about binoculars, things like this we can use to measure maybe even you could use radars or things to measure things. How about, satellites would be a good example of this technology we can use to expand our perception our understanding of the world. So what would be, what would you say? Yeah.
Okay. I like the way you jump from things that we can do on the to satellite. We're talking about if we're going to be talking about my personal empiricism, we're going to be talking about things that I can do on the surface of the Earth. Satellites, for example, might say, give me a picture of the Earth being a sphere, that if that was true, I should be able to measure the surface of the Earth to be curved like in that picture from the satellite, for example. Right?
Yeah.
Yeah. So this is what we were talking about. You mentioned earlier that we can measure over a small piece of land. That's true. We can. We do it all of the time when we build and engineer and construct things on the Earth, right? Bridges, dams, blah, blah, blah. So when we measure on the Earth, we have a standard of level because we want to be level with the Earth when we build upon it. We get level from the Earth. Right? It sounds weird, right? But this is where we reference level from. Level being a horizontal line from from left to right. So to be level with the world would be to be parallel with the plane of the horizon, for example. Understanding the horizon is really the surface of water because we use water as a leveling standard, right?
Yeah.
When we measure over the surface of water with tools, measure it to be horizontal. Where, at the distances that we measure, there should be curvature, right? There should be curvature over the distance of the Earth that we measure. Approximately 8 inches per mile squared. Over 10 miles, that's 66 foot of descent from a horizontal from, say, point A. If point B was 10 miles away, it would have descended by 66 foot from point A's horizontal tangent plane. We don't measure that. We measure the surface of water to be parallel to, let's say, the laser that we cast across a body of water. For example, if we have a laser 1 meter above a body of water and a target, let's say 10 miles away, 1 meter above the surface of water, we have a direct line of sight demonstrating the water is parallel beneath the laser. If the surface of the Earth was curved, the laser would act like a tangent. The target would be lower than the laser line. It would be above the target. There would not be a direct line of sight. So when we measure the surface of the Earth, we have direct line of sight where we shouldn't do. That's why we say, empirically, when we measure the surface of the Earth, it's measured to be flat.
Well, I mean, the whole thing about sea level is like, obviously sea levels, there's low tide, high tide, so the tide comes in and out.
Because mean sea level, the average between the separation of high tide and the water level being higher or lower. That's not curving the water, that's the water level being higher or lower.
Yeah. No, I agree.
Yeah.
It's just like, we talk about empirical measurements, and we say, you reject the idea of a satellite being an empirical measurement. I accept that.
So hold on. Sorry, you said satellite. What did it measure?
What does it measure? It fucking according to the globe theory, it rotates around the globe, and we use it to take photos and do various things and relay.
So for me to empirically verify that the picture of the Earth that shows a sphere is true, measure the surface of the Earth to verify the claim. To verify the claim that the satellite is rotating around a sphere, I would prove the Earth is a sphere by measuring the curvature of the Earth to validate that claim about what that's doing then. Right? All of these claims say that the Earth is a sphere. The dynamics and how the satellite operates rotates around a sphere because of gravity, it falling towards the Earth but not actually hitting it because of its speed, blah, blah, blah. But this all requires the Earth to be a sphere, something that we should measure upon the surface. We don't measure the surface of the Earth to be curved, so it can't be a sphere.
Yeah, but I mean, this isn't really empirical though, is it? Because do we get lasers?
Sorry, how tall are you, dude? And you can tell me you're 6 foot tall, and I'll believe you because you'll say, "Well, I measured myself to be 6 foot How do I know that my shelves are level? Well, I'm going to measure them using a tool to know that they're level. These are empirical standards. You'll use your height on identifying documents, for example. We measure things all of the time. It's an empirical standard. You might want to argue about the accuracy of the tool and the measurement taken. That's fine and reasonable, but it's still an empirical standard, dude.
Yeah, we do measure stuff all the time. But like, what I was kind of thinking about is like, you know, if we want an empirical standard of the Earth being flat, we'd want a really large empirical measurement. You know, I don't know any. I'm sure you guys would know of examples of like
is multiple measurements over different distance sections. So 10, 15, 25, 30 miles. We would have lots of measurements over different distances, lots of measurements in different places, lots of measurements in different tools, in different meteorological conditions.
But have you done this empirically?
We would build up a sample size over time with a body of evidence. So that body of evidence has been growing for the last 10 years, and it's flat.
But you haven't got this empirical.
What do you mean? This empirical? What do I need to do now? My empirical standard is it looks flat.
What you're saying right now is not an empirical standard. But yeah, no, finish.
What measurement?
Well, measurement what you're talking about is
time in different places. How's this not empirical?
Well, it's just empirical.
Show us empirical right now.
My standard of empirical evidence would be like, you know, some fucking astronaut on a spaceship taking a photo or filming.
Show the empirical evidence that's flat right now.
But that's it's anecdotal in the same way that, you know, you measuring things over.
You can do this yourself.
He can't do it. He can't show the empirical evidence that's flat right now. He won't do it, bro.
I'm not. Listen, I'm not arguing for empiricism. You guys are. So,
my friend, the difference between me making an observation or measurement on the surface of the Earth compared to that, say, an astronaut gave you about going to the moon, is you could do the same thing that I've done. You're not going to be able to do the same thing that he's done, unless you're going to give me a story that, but if you studied hard enough and went to the right universities and were a good boy, you could go to the moon. But apart from that, you're going to be able to verify what I've done, because people do this all of the time, every single day. They're doing it now whilst me and you are talking, measuring on the surface of the Earth. So you can do that too. This isn't outside of your reach.
For me to like go out and grab like a string line and measure out, you know, I can go into my.
You can go out to the beach, for example, with say some technology, let's say a camera or
a string line.
Okay, I'm just going to stop now. I think.
No, I'm just saying. Hypothetically, we're using.
Well, you're putting words into my mouth like a string line, and
no,
you might want to listen to what I'm saying.
Okay, go.
Okay, so for example, if the Earth was a sphere, we would have a geometric horizon for things like the sun to hide behind at sunset or boats to go over. Now, this is a mathematical calculable position based on the height of the eye of the observer. For example, if I or you are standing at the beach, let's say we're doing this together and we're both 6 foot tall, according to the math of a ball with a radius of 3,059 miles, the horizon's going to be just under 3 miles away, about 2.8. The equation, I think, is 1.225 multiplied by the square root of the observer's eye height in feet. So if we get the square root of 6 and multiply it by 1.225, we end up with 2.8 miles. That gives us a distance to the horizon. Do you understand what I'm saying to you?
Yeah, in a way, but I just don't believe that. Yeah, I mean, I guess I have this blind belief in the Earth being a globe. Yeah. Hold on, let me look at this video. This guy added me.
You watched the video, dude.
Ding, 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 bingo.
Here's a cheap one you can watch and do. It only requires 2 mirrors, or 1 mirror, really, and an observer.
Yeah, you just take your friend to a 10-mile wide lake, Give him a mirror. If you can see that mirror flash, Koba, either your friend is over 30 foot tall, or water is flat. Which one do you think it is?
Don't even need a friend. You could just put a mirror on a stick or a string.
Yep. Yeah, that'll work.
Yep.
So anyway, Koba, we have hundreds of these tests. There is laser tests. People can paste the whole chat full of them. We can present every single one of them. You don't even have to take our word for it. You go out and do the test yourself. You know how much water has to curve if you're on a ball with the radius that they claim. Over 10 miles at the tangent, that's 66 foot. Over 20 miles, it's about 250 foot. So, I mean, we're talking about this, the height of buildings here. You should not be able to see anything 20 miles away, right? Because it should be hidden behind a curve. But we do have these things. We have shot lasers over these over these distances. This is all the empirical evidence you can ever ask for. Hot miking again, Gregory.
The laser test is completely conclusive, but it's also completely out of my budget to perform on my own. Mirror flash, not so much. Camera, I can also afford, and sight.
Besides my voice, what else do you hear from my microphone?
It's kind of clipping. You hear some background noise a little bit now and then.
Gregor, whatever microphone you're talking on is not the microphone you think. You're talking on a mic from somewhere else.
Are you guys debating still, or are you guys just?
No, we're still here.
No, I'm saying is anyone like debating you guys right now, or are you still?
No, we're talking to you. Did you hear anything?
Yeah, bro, chill out. I didn't actually. I was watching a video. Sorry.
Yeah.
What'd you say?
I just said that we have hundreds of these videos of tests people have done. You don't have to believe any of them. The method is super easy. Listen, you can take a friend to a lake that's 10 miles wide. Have him flash a mirror. If you see that mirror flash, either your friend has to be over 30 foot tall or the water is flat, right? So take your pick there. You can do this with laser as well. There is no curvature. There is no curve in water.
But you can't, because it's not like an observable difference in the it's not like something you can observe.
Yeah,
you know, because if let's say like there's over a certain distance, there's we use a simple measurement like I don't know, like 10 inches of
No, do 10 miles.
Let's say I was going to say over a, I don't know how. Wait, let me look this up. Sorry.
Do 10 miles. Over 10 miles, you have to have 66 foot of curvature. If you're on a ball,
let him figure it out. I think he's going to try and figure it out.
I'm doing the math. Hold on.
Yeah, you can do the math, but I'm telling you already.
Penny's going to drop in a second, dude. I swear. He's going to find the curvature rate over the surface of the Earth. We've told him, but we haven't kind of pinned it down to that. But if you need to Google how much curvature there should be over a distance, find it. Because you keep saying that we can't perceive, and the Earth is so big, you're kind of skirting around that idea, right? But according to the math, no, we should see it. We should measure it at the distances that we can measure. There would be a rate of change of slope over 1 mile, over 6 miles, 10, 15, 20. It's curving, right? So it's going to get worse and worse with distance. Not like a slope, it's curving. So it's 8 inches per mile squared. Square the mile, it's 8 inches of descent from point A's horizontal. So if you've got a horizontal line at point A, let's say you put your finger on the top of a ball and you create a tangent. You move across that curved surface to a distance, we'll call it 1 mile, point B. Point B is going to be 8 inches lower. You move point B to 10 miles, it's going to be 66 foot lower. You move point B to 20 miles, 266 feet lower. So with distance, go on.
I was just gonna, sorry to butt in, bro, but I'm just I'm just not following, and I'm just was gonna ask you guys about this. So I've just looked it up. Over 10 kilometer, I'm using kilometers and centimeters because I'm Australian, and
That's fine.
Not following with miles and that. So over 10 kilometer distance, there is 785 centimeters of curvature, which is obviously 7.85 meters. Now, if you're looking out at the horizon, say a 10 kilometer horizon.
Wrong one.
A 10 kilometer distance, and you're looking at the horizon.
From what height?
From the beach.
Yeah, from what height? Different. So let me jump in. First, we've got the rate of change of slope from point A on the surface. If you're going to be looking, right, you're going to have a geometric horizon based on your height of eye. If you're talking about looking, we're going to need to know at what height, because that's going to make a prediction to where the horizon would be.
I will admit I've looked into Google. I will admit I've used Google here, but according to Google, humans can see about 3 miles, in other words, 4.8 kilometers to the horizon before the Earth's curvature obstructs the view.
Yeah. Now, is this if they're on an aircraft, or if they're standing at the beach, or on a mountain?
So it's technically like not possible to view the surface of the Earth as a curve from an empirical standpoint, technically.
Right, dude. The distance to the horizon.
Is that not true, though?
No, we're kind of speaking past each other, dude. You're not listening about that.
No, go.
Right, the distance to the horizon is going to change depending on the eye height. So when you talk about, I just Googled it, and it says you can only see that's going to be where the horizon is going to be based on your eye height. Let's say you're 6 foot standing at the beach. If you're 6 foot, based on the radius of the Earth and the equation 1.225 multiplied by the square root of that observer's eye height in feet or meters, whatever you prefer, then that will give you a distance to the horizon. For the 6 foot observer, approximately 3 miles, 2.8, like I said earlier. Now, what we can show you is the horizon is not there at 3 miles. It's at 10 miles, it's at 15 miles, it's at 20 miles. Depending on the technology that you use, the horizon will increase in distance.
But, I mean, if the Earth, say, you're at the beach and you're at water level. I mean, I'm just asking you guys questions at this point. Let's say you're at the beach and you're at water level and you're 6 foot tall. And you're looking off into the horizon of the ocean, which has 0 waves in it. It's flat as fuck. Still body of water somehow. You are looking, if the Earth is flat, hypothetically, how far into the horizon could you see?
What, with the human eye?
Yes.
Approximately 3 miles.
But isn't that because the Earth curves?
No, it's based on the angular resolution limit of your eye.
Based on the what?
You know, things get the angular resolution limit of your eye. Sounds complicated. You know, things get smaller with distance, right?
Yeah.
That mountain that's far away looks small. The one that you're standing next to is massive. Yeah,
like the sun. Yeah.
Yeah. We can talk about the sun, but we understand this basic law of perspective, right?
Yeah.
Things reduce in angular size with distance. This also applies to the surface that you're looking across. Imagine that water was a giant chessboard, right? The squares next to you and around you could perceive, but the ones that are further away, you would have compression of those angles, right? The horizontal ones and the vertical ones, till eventually you wouldn't really be able to distinguish the black ones from the white ones, till eventually you couldn't actually perceive the surface anymore because the angle was too small. This would limit your ability to perceive the surface. Now create a horizon where the surface that you can perceive ends and it appears to meet the sky. Then we can throw in the atmosphere as well. That's going to cause, some limitation to what we can perceive and so on. Some reflections maybe, but just on a bog standard idea, if we're talking about perspective and angular resolution, appear to you to get smaller and smaller and smaller into the distance until you can't perceive it anymore. Now that's just based on the angular resolution limit of the human eye. Let's get some technology out, right? Let's get a high-powered zoom camera out. Let's get some distance markers so we can maybe estimate a distance to the horizon. Maybe there's some wind farms, oil rigs out to sea. If we can use a map, we can figure out our location. We can use maybe Google, figure out the distance to, say, some oil rigs. If we know the distance to some oil rigs, let's say they're 8, 9, 10 miles away, we can maybe estimate a distance to the horizon. The horizon could appear in front of the oil rigs, so we could say it's at least 6 miles away. It could be beyond the oil rigs, and we could say it's at least 10 miles away. It could be between the oil rigs, for example. We could estimate a distance to the horizon, right? You following?
Yeah, a bit. I lost you towards the end, I won't lie.
I'm just using things out to sea that we know distances to, so we can estimate a distance to the horizon. So if we're, say, I don't know, 6 foot at the beach, and we should have a horizon that's 3 miles away, and we got some oil rigs that are 10 miles away, and we get some technology out, like some cameras, and we see the oil rigs, the horizon looks like it's beyond the oil rigs, we can say the horizon beyond the oil rigs, at least 10 miles away, not at 3, right?
All right.
Cool. So this is what we're showing you in the side chat. There's been some pictures going by of some oil rigs. Yeah. So based on the geometry of a sphere, based on the radius and our eye height on that surface, it gives us a geometric horizon. Based on the eye height and the radius, the horizon should be, I think, in the 8-foot observation, 3.46 miles away, if the Earth was a sphere. When we show the observation, the oil rigs are like 8 and 10 miles away, or 8 and 9. So the horizon's beyond the oil rig, showing it's at least 10 miles away, showing the horizon isn't geometric curvature. And the boat's not going over the curvature of the Earth, because that would be like going over a hill, like a physical thing, which would be observed if it was physical curvature. We don't observe the curvature where it should be. Right? We're talking. You mentioned earlier about our perception. Yeah, we can see quite far. In actual fact, we can see very far with technology. Depending on the meteorological conditions, we can see really, really. But the limiting factor, if the Earth was a sphere, would be the curvature of the Earth, though. If we increase the technology, we wouldn't be able to see over the other side of the mountain. The mountain would be in the way. We wouldn't be able to see over the curvature of the Earth, because the curvature would be in the way. Even if I had a really good fucking telescope, there'd be a curve in the way. I couldn't see that boat. I couldn't see that building. What we demonstrate to you is when we get the technology
out. There's a mountain in
the way. There's no mountain in the way. We see the boat. We see the building when we shouldn't if the Earth was a sphere.
Yeah. I mean, yeah. I'm not convinced, man. I can't lie.
But this is what we start with empirical, right? How it looks. To the best of our ability with the technology that we've got, how we can perceive the world around us. And with the technology that we've got, we still perceive the Earth to be flat, where it should be perceived to be curving.
Interesting.
I'll tell you this: if I saw the prediction that the globe makes, which is the 1.22 math that was just given, then yeah, that would be, I'd be convinced. I'd be like, it's got to be a globe.
He can't be convinced. He's been in here too long trying to stick up for the globe. He doesn't know what to do now. He knows it's flat. If he says it's flat, it's going to make his head melt because he already knows it is.
What else could it be?
Sorry, I'm looking up what you guys are saying.
Here, I got a good one for you to look up because I can show you an example of what I'm talking about, and I can make it really simple with an analogy as well. All right, so let's
I'm not going to lie, guys. Wait. It is really late for me. It is really fucking late for me.
Just hear me out. It'll just
yeah.
Okay, so we got a lake, and it's 34 kilometers across the section that this guy's going to do. Now, I'll just give you an analogy to give you an idea of how much curvature should be over that distance if the Earth is a globe. Right? The Titanic. Okay, imagine the Titanic ship. It's about 175 foot tall when it was alive, right? Okay, giant ship. Picture a cruise ship, whatever. Titanic. Okay, and we've got one person standing on one side of the lake. Okay, and then 34 kilometers away, we've got the other side. Now, the Titanic is right next to you as the observer on one side of the lake. Now, what's going to happen is the Titanic's going to sail over to the other side of the lake, and we're going to pre-assume that the Earth is a globe. As the Titanic sails away from you, it's going to reach the horizon line at about 3 miles. And then once it starts going beyond the 3 mile mark, it's going to start disappearing from the bottom, the curvature of the Earth. By the time it gets 34 kilometers away to the other side of the lake, the whole ship would be completely hidden behind the curvature of the Earth. That's how much curvature there should be over that distance. Now, if you have a high-powered zoom camera and you're standing there, you shouldn't be able to zoom in across that entire 34-kilometer distance and see the shoreline on the other side of the lake, right? The same height that you're standing at. That would be impossible. Okay, that you would have to have a skyscraper on the other side of the shoreline on the other side of the lake, and then you would just be able to see the very tip of the skyscraper popping out from behind the horizon. Does that make sense?
Yeah.
Yeah. So we have that exact observation here, obviously without the Titanic, but we have the 34-kilometer distance across the lake. Right, so I'll just show you a quick clip of it in the side chat. So this is all from a full-length, high-definition video that goes over everything start to finish, but we took a few clips out of it so we can present it quickly. Okay, so this is a screenshot from the Earth Curvature Calculator. Okay, so the first thing we put in is 34 kilometers. That's the distance to the object. Okay, so this is just shoreline to shoreline observation. So the target is just to see if we can see the shoreline on the other side of the lake. The eye height level is 1.5 meters, which is 5 foot high. That means that on a globe, the distance to the horizon would be 4.3 kilometers. And then the shoreline should be hidden behind the horizon, behind the curvature of the Earth, by 68 meters. That's kind of like a 30-story building, 30-story skyscraper, or 20-something story. Pretty big building. All right, so I'm going to put just a little clip of the Zoom footage in the side chat. So there's a huge amount of curvature that would have to be there. Okay, so that horizon should be at 4.3 kilometers. And then when he zooms in across the lake, right, you should see the horizon line, and you shouldn't be able to see this shoreline that we can see on the other side of the lake. It should be completely hidden behind the curvature of the Earth.
In the Giphy.
So just quickly, he's got a buddy on the other side of the lake. 1 second, I'll just bring up my folder because he's got a friend over there that's taking some footage just so we can see what it looks like on the other side of the lake. So I'll just show you a close-up of what it looks like over there. 1 second. Here it is. All right, so there it is in the side chat there. Okay, so take note, that's the shoreline, that's the target right there. That's the edge of the lake you can see meeting with the shoreline. It's a big, giant, long shoreline, and then we can see a big white tower in the background. All right, so now I'll just show you this is a screenshot. So this is from the zoom footage, just a screenshot. So this is what it looks like from 34 kilometers away. Okay, we can still see the shoreline, we can still see the whole big tower, and he actually stays there, and he does it again at nighttime as well, because there's lights over on the other side.
DJ, he deafened himself, and he's also chatting in the side chat now, so...
Is that the same guy? I'd prefer not to.
No, it's not.
Oh, no, this is Koba.
All right,
Koba
sorry,
that we're chatting with now.
Go ahead.
So yeah, have a look at that Koba. There's the nighttime shot from the same location, and there's the daytime shot, the one above it, and then you can see the close-up. Okay, we don't see any curvature over this distance. You shouldn't be able to see all of those lights should be hidden behind the curvature. The whole shoreline should be hidden behind the curvature, and that horizon should be at 4.3 kilometers.
Yeah, the only problem I'd have with that is that, like, obviously, like, people say the globe.
Mm-hmm.
Like, I don't know where this place is.
Great Salt Lake in Utah. Yeah, Great Salt Lake in Utah. Here's a top.
Right.
So here's a top view from Google Earth or Google Maps, and it shows exactly where he's standing. So he shows you in the video. He shows you his coordinates. Okay, he's standing on a little peninsula at the top of that yellow line there, and then he's zooming across to that shoreline there, and you can do a distance measurement on Google Earth or Google Maps. Right, here's another screenshot. This one's from Google Earth. Okay, so that's where he's standing at the bottom of that yellow line, and then I just drew a black line across there. That's where the horizon should be on a globe, 2.7 miles, which is 4.3 kilometers. Okay, that's where the horizon line should be. That's the maximum distance. You should be able to see the water. Right, any more water beyond that will be hidden behind the curvature. And then by the time you get over to the far shoreline, you'd have to be basically, Mm-hmm.
Do you I know this is in the Salt Lake. Do you know what this city is?
Yeah, Great Salt Lake. It's next to, it's called the Great Salt Lake, and it's right next to Utah. I mean,
I know that big. What's
Salt
that city
Lake
next
City.
to it?
Yeah,
Salt Lake City. Thank you. That's all I'm asking. Sorry, bro.
You can go there and do this yourself. I know you're going to book a trip because you said you're not convinced. Remember?
Yeah. No, I'm just curious. This is like a very flat place on the Earth. By the way, it is like one of these.
This is water.
So is water. Water's flatter than that.
So this is the way it works according to the globe model. According to the globe model, right? Any body of water should be curving at a specific rate. You can't have a 20 mile or like a 34 kilometer body of water that's not curving at a specific rate anywhere on the globe, because gravity is meant to be pulling everything towards the center of the globe. So you can't go to some place in Utah or something like that and have a flat body of water over this distance. It has to be curving at that rate. It has to be curving, 67 meters over this distance. It has to do that if the Earth's a globe, if gravity's real.
Yeah. I just feel like this doesn't take into account like several things. Like, I mean, the counter I'd have to that is like, like the Earth isn't obviously, I'm sure you've heard this before, but the Earth isn't like a properly round object. Like, obviously it's like a bumpy, deviated.
Well, this is what they say. This is what they say. Okay, they say that it's almost a perfect sphere. The mainstream scientists that believe it's a globe. Okay, they say that it's almost a perfect sphere. Okay, but technically it's not. You can't call it that because it's slightly fatter at the equator, 14 miles or something like that. So they say that if you were to shrink the globe down to the size of a pool ball, they say it would be the world's smoothest and most perfect.
But that's like perception, because your fingers, the nerves on your fingers.
You could go on AI. You could go on AI right now and say what's the minimum and the maximum amount of curvature over a 34 kilometer body of water anywhere on the globe, and it's going to tell you that it's the tiniest little margin of error, so little that even universities don't take it into account when they're doing their calculation. They just use the same formula. So right. you can so that's why Earth curvature calculators don't require you to put in the location. So basically anywhere on the globe, it's approximately 67 meters of curvature over that 34 kilometers.
Really?
Whether you're doing it over the ocean or whether you're doing at a lake, right? That's high altitude. It's the same. You can look that up. You can confirm that right now if you want.
What do I look up?
Just say how much curvature should there be on a globe over 34 kilometers of water?
Yeah.
Yeah, what was the answer? About 67 meters, something like that.
Yeah, 90.
Yeah. And you could ask it a follow-up question. You could say, taking into account different elevations or the fact that the Earth is not quite a perfect sphere, how much could this curvature vary from place to place? You could ask it something like that, and it will tell you that it's just a tiny little amount. Instead of 67 meters, it'll be like 67.4 meters. It's some different. Probably not even much of a difference. But you could even ask it this exact location. You could say that at the Great Salt Lake in Utah, how much curvature would there be over 34 kilometers, the surface of the, and it will tell you the exact amount.
Doesn't it rain there sometimes and they get like an inch of water over the whole thing?
Usually it's more water, and sometimes there's less water, but it's not like one of those salt lakes where it's like really thin, even layer of water. It's more like a traditional lake.
He's thinking of the salt flats.
Yeah, different than the salt flats.
Global, I have a question.
Yeah. So,
look in the open chat. It's just a little on a minor point, like because I'm tired of struggling of finding the word to refer to the thing that we're all trying to refer to, right? So we're talking about when we're talking about like things going over the horizon, especially the ships going over the horizon. Obviously, their globe doctrine entails that the horizon has one particular type of nature in contrast to what it really is. Like that screenshot there, I'm trying to find the word. Do you think vertex or apex would be the accurate and valid term to use to refer to what they think and what would be there but isn't there?
Yeah, I guess so. I mean, I just keep it super simple with them and say the physical, geometric location.
You fucking bitch-ass niggas. Why you niggas believe in flat Earth? That shit is bullshit.
You should no. It's definitely a globe. Stay on the globe side, please.
Because since they believe the Earth has a ball, then they think that horizon would be the apex or vertex.
Let me see. I got one of Dr. John Dee's memes here. Maybe he uses a good word in that. Check.
And of course, the whole line that is the horizon line would be like the finite set of apexes or vertexes, along that line of your field of view wherever you're looking. So the horizon is not a set of apexes on a sphere.
Could it be a tangent point? I don't know. Usually, I just show them this diagram in the side chat. They usually get it, so I show them this one.
I've typed it into AI and it said it's one of the only places in the world where you can observe the curvature of the Earth.
You can stick with AI, dude, because like you're going to be on welfare the rest of your life. Also,
I'm not, dude. He told me to use. I'm literally fucking. You're such a retard, bro. Oh my god.
So what does it say when you can perceive the curvature of the Earth? Is that because you can see so far and it looks curved left to right?
Is it the Bonneville Salt Flats? Is that it?
Yeah.
No,
Does it look curved?
Yeah.
I'm trying to figure out if it's left to right curvature.
I'll just read what it says. The key is that the Bonneville Salt Flats aren't just any lake. They are.
Yeah, dude.
Okay, but
this is what I'm asking: the perception of the curvature of the Earth. When you're at the salt flats and you look at the horizon, is it suggesting you perceive the curvature left to right?
I don't know. I was just about to read what this says.
Yeah. So I want to know if that's what it's talking about. We can go to the Bonneville Salt Flats, and because it's so flat and we can see so far, we can perceive the curvature of the Earth left to right. I want to know if that's what it's saying.
They aren't just any lake. They're almost perfectly flat, featureless expanse. Here's why it matters. Unobstructed horizon. The flats cover 30,000 acres, 46 square miles, and are incredibly level. This creates a horizon that is free of trees, buildings, or significant elevation changes, which normally block our view. That's a dot point. The next dot point is vantage point for a curve. Because the flats are so flat and wide, they provide a unique vantage point, as one academic paper published in the Landscape Journal notes. The flats are perfectly flat elevation across distances so great that the curvature of the Earth becomes visible to the naked eye. What the next dot point is what you actually see. The effect is subtle, but it's there. The immense flatness means you are, in effect, looking over a very long gradual curve. An archived Wikipedia description of the flats explains that this curvature process produces an optical illusion that makes any of the mountains within the vicinity appear to be floating in the air, since their bases are on the other side. Sorry, I'm fucking dyslexic and it's late as fuck.
You'll find it. Thank you for
Optical illusion that makes many of the mountains within vicinity appear to be floating in the air, since their bases are on the other side of the curve and thus out of sight. The horizon doesn't look like a flat, sharp drop-off, but distant objects disappear bottom first behind it.
Gotcha.
How you can see for yourself and prove the point.
Dude, I don't need to continue. Thank you for clarifying. Right? So we're not perceiving left to right curvature. We're talking about curvature away from us where the mountain is obscured by that curvature. That means that horizon must be at 1.225 multiplied by the square root of the observer's height in feet. Something that we've been demonstrating to you for almost an hour now isn't the case. The horizon, if we were to get some technology out, for example, wouldn't be at that location, as demonstrated with the oil rigs and so on. So this claim is contrary to what we've been showing you, is what I'm pointing out.
Well, the claim that I'm making.
The claim that AI or Google is making. Okay, the salt flats that are really, really flat, and we can see really, really far because it's really, really flat, that we can perceive the curvature of the Earth because those mountains were otherwise be apparently hidden behind the curvature of the Earth. That curvature being the physical obstruction between you and those mountains on the flat surface of the salt plains. We've been showing you the horizon's optical, not physical. So this claim that AI is wrong, we've debunked in the previous hour.
Interesting. All right. It is 4 a.m. with me. I appreciate you guys. You guys have been really cool. Not going to lie. You guys have been nice to talk to. I've enjoyed it. It's the reason I've been here for the last 2 hours, 2.5 hours, 3 hours, whatever it's been. Like 4, actually. Fucking hell.
No, you've been a great sport, mate. So you're welcome.
Have a good one.
Yeah, you're all good.
Again sometime and continue.
Goblin, are you Australian?
Yeah.
Yeah. I know you're not from Queensland, so I know it's very early in the morning for you. You should go to bed as well.
Oh no, I'm in Europe at the moment.
Oh, okay. Where are you?
7 p.m. It's 7 p.m. here in Poland.
Oh, interesting.
Dyslexia kicking you again. Globlin.
All right. Well, I'll let you boys go. Cheers for the. You were all very civil and nice. I didn't expect that. I came in here trolling, but that was cool. Apart from that one guy.
Say I love you, Dob. Say I love you, Indio, and then you may be going away.
Wait, who was he? He left. But that guy who was not civil.
You just say it to the recording.
Oh, he was civil. He's just from Boston, dude.
Oh, that's a good
Indio's
point.
great when you get to know him. Seriously, he is.
All right, cheers, boys. Have a good one.
Peace. So yeah, the Earth does not have an apex of a sphere. It's not a sphere. It's not a spheroid, doesn't it? The horizon is not a set of vertexes or apexes. Now, what should be the next step is I'd prefer not to unmic himself than actually speak up and stop stomping his feet in the open chat.
Later. Hey, sorry, can you hear me?
Yeah, you need a video on YouTube about
sorry about
sunsets
that.
or something. You know,
Sorry.
I I have my own camera, so I don't need to go to YouTube to watch sunset videos. Isn't that neat?
I'd prefer not to say that he's talking.
I can't post in side chat anymore, but the GIFs being posted is not how sunsets look, and I'm willing. If there's any YouTube video, just any at all, I'd concede immediately.
These all came from YouTube videos.
Yes, these are Discord GIFs.
Yeah, I have a whole folder of sunset videos. I can post them for you if you want to have a look.
Are they on YouTube?
Yeah, they're all on YouTube.
If you, I can't post inside chat, but if you would, I'll click it.
Yeah, so I saw the ones that you posted, and every single one that you posted is over somewhere that has like either mountains in the distance, right, or a cityscape in the distance, or elevated land in the distance. You want to try to find sunsets that don't have a local horizon blocking the actual horizon. Like if you can find sunsets looking out into the ocean on days where you don't have waves, and then you zoom right in on them, you'll see how sunsets actually work. The sun squishes, right? It compresses vertically into the vanishing zone. That's how sunsets work. All right, I'll post some examples in the side chat.
The sun doesn't get noticeably smaller. It's clearly traveling below the horizon.
Well, take it.
I'm not audible.
Yeah, you're good.
Sorry, below the horizon.
Yes, the sun is not shrinking from 100% size overhead to, say, 5%
the horizon being a physical geometric Earth curvature based on the observer's position.
Sure, I suppose the horizon that we see, yes.
Yeah, you're saying that the reason why you can't see the sun is because the curve of the Earth is in the way. As it goes down under the horizon, the curve of the Earth is blocking your ability to see the sun, right?
Yep.
Cool. You've been paying attention for the last hour and a half, right? You've been in the side chat. Have you been listening?
No.
What we've been demonstrating to the friend who just left is observations of the horizon. It's not geometric. It's based on optics. It changes with the camera that you use or
the words are
stuff
good.
like that.
But this video, that Goblin Patrol, can we like both look and talk about this?
Yeah, sorry, I do apologise. You can definitely talk about that, but it's not Earth curvature that's causing the sun to hide. You can speak to Goblin about what it actually is.
Yeah, go ahead. What's your question?
The sun looks massive here.
Yes. Sometimes the sun looks massive on the horizon. Depends on the weather conditions. Okay, the atmosphere can act like a lens. So if you have very humid conditions, for example, sometimes it can look like the sun's giant on the horizon.
I've been trying to tell him it's a camera we're using. He thinks that that's somebody's eye we're looking at through.
Can Lao Tzu post that GIF of the sun again? Because I don't have side chat permissions anymore. I thought it was a good GIF. It was the GIF of the sun going from like 100% size to like maybe 5%.
Yeah, so that happens when this is my opinion, okay? And if someone's using a wide-angle lens, the sun looks pretty small, right? It's very different than if you're zooming in with like a nice zoom lens at 50 millimeters or 100 millimeter lens or something like that. If you're looking at the sun from a distance through a lens that has a low focal length, it looks tiny in the sky. Okay, when the sun's up higher in the sky, it's extremely bright. So the brightness overloads the sensor in the camera. It makes it look really big. There's a particular term for it, which I forget. I'm just using the term glare for now, but there is a technical term for it. As the sun gets lower in the sky, you're looking through way more dense atmosphere. So then it acts kind of like a natural solar filter, and then it looks like it's shrinking. If you look at any sunset using a solar filter for the entire sunset, it doesn't do that. It doesn't get really, really big and then look like it's getting into a tiny little dot. That doesn't happen when you use a solar filter. It stays roughly the same size. It does shrink a little tiny bit. So those drastic ones, in my opinion, that's just the sun overloading the sensor on the camera and making it look like it's giant. looks like it shrinks into a tiny little dot and fades away.
And I won't discount that. I guess my question from here is, would I be able to see that with my own eyes?
Hey DJ, you're talking about
Sounds good. You don't do a time lapse with your own eyes.
Hey DJ,
through your
well, I could,
well, just quickly, your own eyes act more kind of like a 35 millimeter lens or something.
DJ, you're talking about atmospheric lensing. I think that's what you're looking for.
Well, not really. I'm talking about the effect when it overloads the camera sensor. If Yoda
on the camera? Oh, my bad. I thought you meant.
Yeah, it's like a glare effect, and it looks like the sun's giant, and it looks like it shrinks into a tiny little dot as it moves away.
I hear you saying.
So in other words, should your eyes be healthy enough, or if your eyes are deficient, then not.
Yeah, I mean, if you use a solar filter, you'll see that it doesn't look like it's giant and then shrink into a little dot ever through a solar filter.
It's just that with my own eyes, I've never seen the sun like reduce in size by.
It reduces only a tiny little bit. No, I agree with you. It only changes a tiny little bit in size.
So what's wrong with this GIF then? I mean, it seems like a faulty one.
Nothing wrong with the GIF just because you can't see. You're like a blind person saying, "Well, I've never seen colors, so what the hell are you people talking about colors?" You're probably obviously wrong.
Yeah, look, the GIF's fine. The GIF's showing the. Okay, so what the GIF's showing is a glared out sun. It's like it's giant because it's overloading the sensor in the camera, and then it's shrinking into a little dot because that's what the sun looks like when you use a low focal length lens to look through the sun. I used to notice that on my camcorder. I would be taking footage of the sun. And then I would look back at the footage. I'd be like, damn, it looks like a tiny little dot in the sky. Because it was like a 16 millimeter focal length. Right? That's not what it looks like through your eyes. Okay, I would look through my camcorder eyepiece, and it would look like a tiny little dot. And then I would look with my eyes, and it would look big. It was kind of annoying. But that's what happens.
Yeah, DJ, and I think what's false or misleading is when people claim that the sun does change size, and then they show you the sun reducing its glare in the camera as it sets. And what you're seeing is a change in luminosity. And like what you were saying a few times, it's the luminosity of the sun is bleeding over from the sensors that it's focused on into the sensors it's not. And that's what produces the glare.
What can I do to get side chat permissions back so I can at least make this argument?
I can give you the side permission.
Not posting the same dumb shit over and over like she told you to.
That's valid.
That video that Rayleigh just posted, that's a good one for you. Talking about the sun being a small point. He puts a filter, a sun filter, and you can see it through the lens.
Now, even with a really sharp filter, the sun does change its size, just not as much as you'd expect if it's an actual object subject to typical laws of perspective.
So with this sun filter, if we were, the sun was about to set, right? It's near the horizon from our perspective. If I put the sun filter over it, are we saying that it would be even smaller than that? Like,
yeah, it's like the size of the moon.
If you look on the side chat, this gentleman, he took a time lapse of the sun with the filter, and you can see that when it was overhead, see how large it is, and then when it was at sunset, it actually did decrease in size. It did get smaller because it's getting away from you. Obviously, it's not getting really, really small because it's still a huge object in the sky. But there is a change that is noticeable with the lens.
This GIF, I mean, that's saying that this is what's happening.
Look how glary. Look at how glared it is. Okay, it's that's like glare, making it look like it's giant.
Like what Lao Zoo just posted there. I mean, telephone lines clearly converge to the horizon. I'm not arguing that. I'm arguing that sunsets don't look like the GIF above it.
Right, because the sun isn't close to you like the telephone pole is. Okay, that's a completely different way of using the perspective argument. It's already a huge distance away from you.
Yeah, like what Rayleigh posted, Lao Tzu posted, like this makes sense.
Right, because they're close to you. One second, Gregory. Okay, look. Here's an example, right? Let's say you lay on the ground and you have a tennis ball in front of your eyes and you roll it away. Okay, it fills up a huge field of view in front of you. It looks huge, and then it gets smaller as it moves away. If you get up above that, okay, let's say we roll it away 2 meters, 3 meters, or whatever. Okay, now you change your perspective. Okay, you're going to move further away from the tennis ball. You're going to stand up on a stool or something, and you're going to roll that tennis ball away the same distance, just 3 meters away. Okay, so when you were laying on the floor, it looked like it reduced like a huge amount in angular size. But when you're looking at it, when it's already reduced in angular size, and you're still seeing it just go 3 meters away, it hardly changes at all. It changes a tiny little bit in angular size because it's already moved away from you. Yeah. So think about the sun, right? Imagine if the sun was right in front of your eyes, like it was physically right in front of your eyes. Then you're going to move it way, way up into the sky. Okay, it's already reduced in angular size. And you're just looking at it go down, appear to go down, just due to the perspective limitation. Okay, due to the way our eyes see in linear perspective, and it's going to converge into a vanishing point due to perspective, not because it's right in front of you close and it's moving away. It's already reduced in angular size. Okay, so you're just seeing it go down due to perspective, not actually the same type of thing as rolling the tennis ball away from when you're close to it, or the street lights or anything like that. It's a different scale. Is my mic cutting in and out?
No, it's not. You're completely clear. But I mean, if that were true, wouldn't we see the sun get smaller? I mean,
it does get a little bit smaller, but because it's already far away from you, okay, and you're just seeing it appear to go down just due to perspective, so it's not going to appear to reduce much. I do have an example here. I can show you what I mean.
You know, and also some of this presupposes what the sun is, and we start talking about what it should and shouldn't be doing.
Exactly. Like I would describe the sun as an apparent light in the sky. You're seeing it unique to your field of view. Everyone's going to see it unique to their own place that they're standing in, their own personal field of perspective. Right. For example, have a look at this in the side chat. So this guy, he's set up a string across his kitchen bench, just straight, horizontal across the kitchen bench. When he's up high, looking at the light move away, it looks like the light is just going straight. Okay, and then when he puts the camera down on the bench, which would to represent our perspective here on the Earth, looking at the sun, now all of a sudden it looks like it's going almost straight down. Okay, that's the same horizontal string that we're looking at there. Okay, now we have to take into account the atmosphere. Okay, you're seeing the sun in an apparent location in the sky due to the thickness of the atmosphere. You're seeing it due to perspective. That's what's making it look like it's going down. And then you've got a ton of atmosphere between you and the light that you're looking at. Okay, that can have all kinds of different effects. That's why when we look at time lapses of sunsets, we see all kinds of crazy variations of what happens when the sun sets. Now, if you're looking out over mountain ranges and watching the sun set behind mountain ranges or hills or something like that, or even in the ocean where you've got big ocean swells, it looks like it disappears cleanly from the bottom to the top. But when you remove that obstruction that's blocking the horizon, it doesn't do that. It vertically compresses into the horizon. It squishes into the horizon. If you go on YouTube and you type in sunset zoom footage, right, and don't look at the ones that have a physical obstruction of the horizon, like hills or cityscape or something like that. Just look at the ones that there's no waves and you're just watching the sunset over the ocean. Every single time you'll see the sun has some crazy miraging effects. It squishes into the horizon. Sometimes it looks like it fades off above the horizon. It never even looks like it sets at all. It just kind of fades off. I'm
trying to find this sunset zoo.
Yeah, you keep posting sunsets over land. That doesn't help you out at all.
Sorry, I was
Well, what's
reacting
happened so
to
far?
other people posting gifs of sunset over land.
So what's happened so far is that you've been shown what the sun does during this type of phenomenon that is sunset, and then your reply is, "That's not what we see," which obviously is just an invisibly ignorant denial of what has been seen and recorded.
So I don't disagree with you. I think that's correct. But I mean, when you look at what Globulin Patrol just said, I mean, has anyone ever seen a sunset like that ever?
Yeah, it was captured in film right there on digital video.
It's pretty funny.
I have never seen the sun increase in size over 100x. The sun got 100 times bigger
What kind of
here.
time-lapse camera do you have? What kind of time-lapse camera are you using?
My eyeballs. I've never seen the sun grow 100 times in the span of a day.
The time-lapse camera, not your eyeballs. Try using the
I've
time.
never seen the sun increase in size 20 times over a day.
We don't have to go through all this headache. All right, there's nothing to say to that except too bad. You haven't seen it. Okay.
I've never seen the sun increase 100x in size over the span of 24 hours.
Can I say something technical to back this up with? Yeah, all right, the sun's luminosity changes throughout the day from where it's visible above the horizon to where it's directly at its highest point called the zenith. You know how many multiple times it changes luminosity? It's not 5 times brighter compared to where it is on the horizon when it's overhead. It's not 10 times brighter. It's not 100 times brighter. No. It's not even 1,000 times brighter. It's 23,000 times brighter when it's directly above you overhead compared to where it's still visible on the horizon. Of course, you're going to start to see some change.
So
am I going
to see the sun increase that much in size?
Look.
It's not a linear relationship.
What you're doing, you're locking us in this silly circle where we show you what has been observed of the sun at the sunset, before, during, and after the sunset. And then your reply is, I haven't seen that. Okay? All right, that's too bad. Next. There's no need to keep hearing you repeat that sentence over and over again.
Yeah, I have a way to move the conversation forward. How about this logic? Prefer not to. Okay, if we can just measure over the surface of the water for curvature that would have to be there if the Earth's a globe, and we can never find it. Okay, we have all of the tests well documented showing that there isn't any curvature over these large distances where it would have to be there. Whatever's happening with the sun in the sky, right, it's happening above a flat surface. Do you disagree with that logic?
I'm just stuck on the size of the sun. I mean, I'll pass the torch. I'll let someone else talk, but I guess what are you
stuck on?
I'm gonna have to
what are you stuck on, though?
I think we'll let him.
I'm gonna have to take a picture of the sun.
I think I can explain what he's stuck on.
Yeah,
I think. Let me try real quick.
What I'll have to do is I'll have to take a picture of the sun, maybe like right now, and then wait till sunset, and then based on the video Goblin just posted, I should essentially see the sun decrease in size by like 50 orders of magnitude. Like I should see it.
What?
Maybe
I didn't post a video showing that.
Or 100x.
I did not post a video showing that.
Let me explain something to him real quick. I think I get where his disconnect is. If you look at the photo I posted at 11 minutes after the hour to my time, you go up to, if you scroll up a little, I one morning woke up, well, it wasn't morning time. I walked out and the sun looked super, super huge. Like it looked gigantic in the sky. Okay. And I snapped a photo of it. Okay. So what you're trying to say is I've never seen the sun be that big, but that's not the physical size of it. That's because of like what DJ's been saying, Goblin's been saying. It's a glare that happens in the sky because of the atmosphere, because of what's in the sky. It like makes it much brighter, and this obviously changes and isn't always like this. And some days, if the conditions are right, you can literally look up at the sun and it won't burn your eyes. Like let's say for whatever reason, let's say there's clouds or whatever. There's sometimes the sun looks like the exact same size as the moon because you're actually seeing it at its real size, and you're not having a glare. And you don't even need a filter. In other words, like the sky is being the filter for you, which allows you to stare right at it. And that's happened to me several times where you look up and you're like, oh, dude, I can see the sun. Oh, wow, it looks like the moon. Wait, is that the moon? No, is that the sun? No, that's the sun because the moon's over there. So you could like literally see like the size of the sun if the conditions are right. So what you're talking about is like, I've never seen this glaring sun so big and it reduced in size. No. He's trying to point out like if you were to look at it like with a filter the entire time, like a time lapse, then it would barely change size. It's the atmosphere, it's the sky that makes it much, much bigger or not. I think that's where you're not getting it.
Look, he's posted some screenshots.
No,
I want to hold on a second.
Fair.
I posted it. Let me just explain what's happening in that. Okay, the point of me posting that. Okay, when it's zoomed out, the aperture on the camera is much wider, open, so it's letting in a ton more light. Right? Because the sun is extremely bright, it's overloading the sensor, and then we get glare. And it's making it look like it's kind of half hidden behind the horizon. Even though it's not. And when he zooms in, what happens is that, because when you zoom in on a camera, the aperture gets smaller and smaller and smaller and smaller, and less light is able to come in. And that acts like a filter. So it's all of a sudden, you'll notice that when he zooms in, it's getting darker. That's because the aperture's closing as he zooms in. And it acts like a filter, so you don't have that glare effect anymore. And then you can see that the sun's not actually half hidden by the horizon. It's actually still up high in the sky. Okay? So that's the point of that. It's not showing that the sun changes in size or anything like that. It's just showing that the glare can make it look like it's doing something that it's not. Like the glare is making it look like it's half hidden behind the horizon, even when he zooms in and removes the glare, you can see the sun's still up higher in the sky. It's not even hidden by the horizon at all.
And that makes sense. I thought the argument was that the sun appears to reduce in size, like by 100x.
Nope.
Because if I saw something like this from that, I mean, I would think I was about to fucking die. I mean, that's if I saw it with my own eyes. I don't know about the cameras and all that. I just, if I witnessed the sun increasing in size by 100x within a day, I would think I was gonna fucking die.
Nobody said 100x. Quit fucking.
These videos show it 100x.
He said it was glare. He didn't say it was bigger.
I mean, it's not physically getting 100x. It's just the glare is making it like my photo that I posted. It's humongous, but it's not the physical size of the sun. It's the glare of the sun in the sky.
And I don't want any bad will.
All he's just saying is that it appears to be 100x. That's all he's saying.
Just the glare. Yeah. Camera's just overloaded. Anyway, can we move on? Can we move on?
Yeah.
Yeah.
I'm gonna take the back seat here.
Yeah. Look, go watch a bunch of sunset Zoom videos on YouTube. It's good fun.
Yo, Professor, prove your point. Prove your point right now. What's your point? How do you prove the Earth is flat?
It's measured
verbally.
Flat. Planar surveying.
Okay. So what's your proof?
Welcome to Flat Earth.
But there have been done like a lot of measurement systems, and a lot of times people measure the actual. Yes, but actually,
measured it to be a ball. Nobody's.
I'll challenge you to present just one example,
no one
dude.
has ever measured it to be a ball.
Can you present just one example, one measurement? Can you do it?
I did already. I spoke here like a lot of times tonight, and people just going along like.
Oh, well, then which one was it? Because I never heard you before, and I'm here all the time.
I mean, I did. I was talking to. I don't remember the guy's name, but it was also like an old guy that I spoke.
Yeah, which one was
it? Anyways, I don't remember. Like it was the mod of this channel. One of the mods. I don't know how many mods.
Yeah. What's the measurement?
Measurement for what exactly?
McFly.
The Earth curve. You said you have measurements for.
No need to be loud, buddy. I can hear you pretty good. Why are you so mad? Why you can't talk in a normal argument without being mad?
You couldn't hear him tell you all that.
Right. Well, did you know that actually around 240 before Christ, actually, how do you call him? Erroneous or whatever. I don't remember how they.
Eratosthenes, no.
Yeah. I don't remember how they
Here,
call
how
them. I
we
mean,
didn't provide any measurement.
but do you know that even they measured.
Jesus
No, but
walked around with sticks.
no, I'm just saying that's how we determine the time. But even they measured. Bro, I'm not talking about Jesus.
measure
Chill
the
out.
ball earth? Did Jesus measure the earth? Did you write that down that it's a ball?
Buddy, no, nobody's talking about Jesus now. I just said before
You did.
Christ.
You
That's
brought
how we
up
measured the
Jesus.
time, bro.
You said this guy lived when Jesus was around.
That's how we measure the time, buddy. What calendar?
No,
do
he
you use?
didn't. What the hell?
Say that.
He did not say that at all.
Oh my lord. Okay, so anyways, even them measured Earth's curvature using shadows in Alexandria and the Cyan. So he measured
Would
the
you like to
angle
hear
of
the
the sun.
rebuttal?
Well, I'm trying to talk. So even he measured the angle of the sun and used geometry to estimate Earth's circumference, right? So using the angle difference and the distance between the cities, he calculated Earth's circumference to be about 40,000 kilometers, which is extremely close to the modern value of
You have an angle
40,000.
on the surface of a ball, so
No,
you can throw that one out.
Okay, leave room for a reply.
you
Like, we
can't.
get it. Heard this appeal 1,000 times. Okay, so you're appealing to Eratosthenes' calculations, which is categorically
No, he just asked me. I'm not saying that I'm going along with it. I'm just saying he just asked me.
I heard what was said.
That was never done.
Reply.
Okay.
Okay, we get it. So you think that Eratosthenes' calculations is an instance of measuring the curvature of the Earth? That's a category error. Doing math in your head, right, is not a measurement. Okay, it's category error number one. Number two, this operation he did was not a measurement of the Earth directly. It's not a measurement. He's not measuring the curvature of the Earth doing this. He's measuring angles, right, of shadows relative to the thing that's casting them, with several presuppositions that indeed the Earth is a ball, and that the sunlight rays are parallel when they're obviously not, and the sun is at an infinite distance away from the Earth and or the observer, all of which are obviously just presumptions and not facts. And the Chinese did the same operation, and it comports exactly the same way to a horizontal surface. So it does not break the symmetry at all. It's an insufficient appeal.
All right. So as I said, I mean, he just asked me about one, and I was just like, oh, even before Christ, they've proven it. But they actually did prove it at some point because
Here we go. Christ again.
At the same time, bro, what's wrong? What's wrong with you and the Christ?
Why are you acting like these people existed?
Bro, it's how we measure the time. What's up with you, man?
No, it's not how you measure time, bro. That's not how you measure time. Time is measured by the sun moving across the sky.
Time is measured by bro. It's measured by it's called before Christ. Okay, you need to calm your
that
ball
is
down.
not how you measure time.
It is. You actually did you actually start attacking your professor like when she was explaining that too? Anyways, the one city had no shadow, the other had about 7 angles.
How is he in both places at the same time?
How is what now?
How is he in both places at the same time to see that?
Well, I did say he compared shadows in Alexandria and Cyan at the same time of the day. At the same time of the day. So it's he was.
You gotta do it on the same day at the same time. You can't do it any other time.
Why can't you do it at the same? Like be there
because
like
you have
one
to
day
go
and be there the second day.
2, 1. Take your reading just like that because the sun's always moving. That's why.
Okay. So hold on, the sun is moving in the same direction every day, right? So why can't you just do the
sun's
same
always
thing at the same-
moving, and you agree with me? It's always moving.
Exactly. So is it changing the distance?
Earth is not moving. Earth is not moving. The sun is moving. See how I got that out of you?
No. I'm not saying that. I'm just asking you. So if the sun is moving
you already
every day
said it. We already recorded you saying it.
Oh my God, you recorded me saying that. Okay, I have a question. So if sun is moving every day basis, is it changing the distance or is it moving in the same direction every day?
Changing what distance?
Changing directions of moving, or does it go like on one line every day? That's what I'm trying to ask you right now.
It goes from east to west.
Great. So why can't he just go to one day to another city and go to a different city on a different time of the day? If it's
because the sun moves. Sun moves.
Exactly, but it moves to the same direction, like you said.
No, it doesn't. Have you ever heard of seasons?
Yeah, but he did it in the timeline of 1 week.
Oh no, that doesn't work then. Yeah, that's totally out. You're totally off then.
But what's the point? Explain.
You're totally off then. You did it within a week, and you know it didn't happen like that. That's a made-up story. You just made up. You just made up that it was done within a week. You just made that up.
I mean, I'm just telling you how it is.
You made it up.
And why are you screaming again? Are you getting?
Because you're a liar. I love to scream at liars. I love to expose you people.
Well, but you can scream, but I can put you down. Like I can put your volume down.
Go ahead. Put me down.
I just did. Good. So I can still hear you, just not screaming for me, which is pretty comfortable for my ears now. Anyway, good. So are you gonna prove me that the flat Earth exists?
Yeah, Earth is measured flat.
Okay, proof.
Yeah, planar surveys.
Planar surveys. Explain. Yep. Give me one proof. Send it in the chat.
Planar surveyors. That's their job. That's their job.
Whose job?
Planar surveying. The surveyors. That's their job.
How do they prove it?
What the fuck?
Give me one example. Give me one example. I mean,
because they don't measure Earth curve.
They did actually. What about satellites?
No, they don't.
What about GPS? What about laser ranging?
No, you can't just go all over the place and ask me questions.
Because I just don't understand. Like, why are you going?
You don't understand anything. Now you don't understand GPS. You don't understand Christ. You don't understand sticks. You don't understand a bunch of shit, dude.
Damn, you're so mad. Jesus Christ! How can
I'm just pointing out how silly you sound. I'm just pointing out how silly you are.
But I don't. Wait, but it matters to how I feel myself, right?
Triangle. I do want to know what you're talking about when you say plain Earth surveyors, like.
Planar, P-L-A-N-A-R.
Okay, my bad. I didn't hear you right.
Planar.
Wait, Professor, you said what? Can you say that once again, just a little bit loud?
So what about?
We try this. Like settle down and turn down the volume. Can we do this?
Thank you, guys. Okay, so planar surveying. Triangle, can you give me more detail? Because this is the first time I'm hearing about this.
No,
this channel.
It just you're going to have to Google what is planar surveying and read all about it. Maybe take a class on.
Sure, just give me the short and simple because I'm in the I want to know.
You use a transit or a theodolite and you shoot straight lines, you make triangles. Once you make 180 degrees, you got a triangle. Then you move one of those points and you take it from there and you make another triangle. Now you got 2 triangles connected. Then you move it again another direction. Now you got 3 triangles. Then you move it another direction and you keep going on this straight line, and you can make a straight line by making triangles as long as you're always equaling 180 degrees. Because if you don't equal 180 degrees, you have something wrong and you have to shoot it again until you get 180 degrees.
Is someone able to give a good explanation?
Do you understand? Do you understand what he means by 180?
He doesn't understand what a triangle is. I don't think he understands what a triangle is.
Can someone lay it down like an actual explanation?
Do you know what a triangle is?
It makes sense. I think it makes sense to you guys, but someone who's never heard of this, like
so let me try.
Gave an actual.
So what he's saying is that when you set up the equipment and you establish let's say a measuring rod, and you're going to make sure that it's at a 90 degree, because when it's level and plumb, you're going to create that triangle that he's talking about. So when you take a shot, he's saying we're making a triangle that's back to back, because from that 90 degree position and then going to the next point, which is also going to be at a 90 degree position. That's what he means by that. Like when you're setting this up, the equipment, as we do out in the field, you're creating like these perpendicular positions to one another. That's how you're going to get the angle and the degrees that you're measuring. Mm-hmm. That's the only way you're doing it. So I was waiting for him to also say, because he loves saying this, that triangles don't have curved baselines, because in your paradigm,
I didn't get that far yet.
What was that?
I didn't get that far yet. He doesn't even understand what a triangle is.
All right. Yeah, you're right. Go ahead. Share that with him so that way he understands why it's not curved.
Do you know what a triangle is?
No, I'm just trying to
he said no.
Layman's explanation.
Us at all. See, he said he does not know what a triangle is. So it's hard to get these guys to even understand anything. When you tell them, hey, you can't make a triangle on the surface of a ball, and they're like, well, I don't know what a triangle is. And then, so it's like pointless at this point.
No, I'm not even disagreeing with you.
For an explanation, Rise. You're asking for an explanation.
Yeah,
I'll draw it for you.
I saw it. Thanks, Gregory. I appreciate you.
What's your observations?
Well, the thing is, I'm not even disagreeing with Triangle. I just want to know if he's an individual that's like able to regurgitate information, or if he's able to actually understand it and dumb it down for people. It seems as if he isn't able to dumb it down for people because he doesn't understand it. It seems like he's really good at regurgitating. Now, other people like
he's
OG,
good at just screaming at people, actually.
OG was actually getting a little bit better at processing it in his brain and trying to dumb it down. That means he's trying to understand it. He didn't do the great job, but he did a better job.
Do you know what a triangle is?
Wait, how do you know how well he did, but you don't understand the thing you want them to explain?
Right.
Yeah, because when someone dumbs something down to the point of someone else being able to understand it, that means they themselves understand that concept
Thank
so
you for your
well
evaluation.
that they can.
We're going to continue the conversation.
Congratulations. Thank you, Goblin.
But you're presuming to evaluate his explanation as though you understand what is the best and optimal way to explain. The only way you would know that is if you understand the thing that he's trying to explain. Yes, necessarily. You can't evaluate an explanation to be optimal or suboptimal if you don't understand what is trying to be explained. That doesn't make any sense.
Yeah, that's why explanations are a thing. That's why you try to explain it so that someone can understand it.
You don't understand what I just explained to you. Right? You're sitting up here acting as though you know how to evaluate their explanations, but you don't understand the thing that they're trying to explain. So you yourself are just as ignorant as them, at least in principle. So you can't know their explanation is optimal or suboptimal. You don't even understand what they're trying to explain.
Yeah. So what you're telling me is I don't know what I don't know. Yeah, exactly. That's why I want an explanation.
Right, but you can't know their explanation is insufficient or not because you don't understand what they're trying to explain. You don't know better than them in order to evaluate their explanation.
Yeah, I think we're talking past each other, Gregory.
Let's try it this way. How would you use a triangle in this example they're giving you? What did the triangle do?
Who's talking? I don't even see anyone talking.
It was the crit guy.
Crit guy. Okay. Yeah, how do I use a triangle?
Yeah, he demonstrated how to basically talked about how to use a triangle. How would you do that?
Yeah, from what OG said is that they set up equipment, they put a triangle, and then they put another triangle next to that triangle, and then they measure 180 degrees. Is what I got.
Look.
So then I was like, what the heck are we talking? Where are we putting the triangle?
Look at the side chat. Hold on. Look at the side chat. Okay, I drew this for you because I want you to clearly understand. Okay, when he's saying that there's a triangle to a triangle to. Okay, look. So these poles, if you will, they're at 90 degrees across the baseline. Okay, this is a flat horizontal. And if you notice that the baselines are going to be flat because that's the only way you're going to have a 90-degree position to your 90-degree position. That's how you're able to make these triangles. And then,
just for clarification here, that baseline that you drew right there, that's the horizon, right?
Correct.
We're seeing
that is
okay.
That's where we're establishing our level position. So we know, and I could even get more into it, difficult, and have topography. And I'm going to show you how when you set up a measuring rod and you take a shot from your point, the stick's reading 4 feet. What does that mean? That means over there, the ground where that thing's at level, that means it went up 2 feet. That's actually how we do measure the ground accordingly. So that way, when we're putting our material out, we know our elevations because it's off of this principle, planar surveying from the beginning. That's what he told you.
No, yeah, I get it. That's actually a much better explanation. I appreciate that. One more point of clarification. Are the triangles being made based off a shadow being given from the sun? Or no?
No, it's just do the scope of the equipment.
Okay, perfect. That's all the clarification I needed. Thank you. That's much better.
No, the sun moves. You can't use a shadow.
Right. Let's just jump back a bit with Lost Warriors because I think he was still a little bit confused about the Eratosthenes test. So even according to, we'll grant you that he existed, even though there's no evidence of that. Let's just say he did what he did. Right. It's flawed, and it doesn't actually determine whether the Earth is a globe or flat. In fact, he wasn't even trying to determine that. He already pre-assumed that the Earth was a globe, and he was just trying to work out the size of it based on that pre-assumption. Okay, so Yeah, it's only due to the pre-assumptions that he made, and he did those calculations based off the assumption that the sun is such a large distance away that the sun rays come in perfectly parallel, and that he's standing on a globe. Okay, and then he
So
measured a shadow.
let me ask you something. I'm sorry about cutting you off, Goblin.
Yeah.
I understand. I didn't use that so I can explain the whole thing, right? I was just like actually making fun of like what he asked me about like before Christ, right? But I just want to ask you one simple thing. Like I'm not trying to regurgitate like words like he did or whatever. I'm just gonna ask you like a simple, very simple thing, right? So when you fly out of Los Angeles to, let's say, Tokyo, what modern aviation plans flights along Great Circle routes, right? The shortest path on a sphere, right? So are you saying that they did it just so they can get more money out of people, or what's like flat earth, like what flat earthers think about that? That's my question.
No, you're
like,
just looking at a flight path that's plotted out on a particular map projection. Now, an actual great circle would mean that. So this is what a great circle is. Okay, a great circle would just be a straight line around a sphere. Okay, like following a line of longitude or something like that. That's not what they're talking about when they're talking about a great circle route. You're just talking about plotting out a flight path on a Mercator projection map, which is the big rectangular one. And when you plot out the flight path on that, it looks like it's taking an arced path. And they'll call that a great circle route. Okay, if you plot that same path out on a different map projection, like an AE projection, for example, it's not going to do that anymore. Now it's going to look like a straight path. But at the end of the day, they're just plotting out coordinates onto different map projections. It's not going to prove anything. It's not going to prove whether the Earth is flat or a globe. Okay, they're using a spherical coordinate system to navigate.
Correct. Okay. But I'm just asking about like it's a very simple question. Like when you fly out of like a very, very long distances, right? So why don't they take a short ride, right?
They take corridors. They take flight corridors, kind of like highways or shipping lanes, but for the sky. Okay, so it's based on efficiency, it's based on safety, it's based on avoiding dangerous places, all sorts of different things.
Right.
And not hitting other planes.
Because I remember when I was on a flight one time, I was flying from Japan to Washington one time, and I remember that kid asking the flight attendant, "Why don't we fly? Why do we have to fly a big round circle, right? Because it's going to take us longer time." So, what would you say? Why they don't give a straight, honest answer like you do? But they just explain it because the Earth is round.
Well, they've probably never really thought about it. Okay, they're used to looking at those little maps on the back of the seat. Okay, and this is what you'll see. So have a look at this in the side chat here, because this is the top one is the Mercator projection map. So that's what you'll see on your little screen on the back of the seat in a plane. Okay, if that was plotted out on the map projection right below it, that's the exact same path. Okay, now it looks like it's just going in a straight line. So it just depends on which map projection you're using. It just so happens that the most commonly used map projection's the Mercator, and that's what they plotted out on the little screen on the back. That doesn't mean that you're taking a big loop or something like that, though. Okay, it's just plotted out on that particular projection. All the projections have distortion.
Right. So if it's really simple to understand that Earth is flat and everything, like normal people made a conspiracy and they have all the answers and stuff, why do people still not talk about it? Why is it, even when you Google it, why is it saying proven theory? Like why is it not even to talk about? You know what I'm trying to ask you?
Yeah, well, it was actively censored back in 2016. Congress got together with the heads of these large companies like Google and YouTube, and they agreed that they're going to censor what they call dangerous misinformation. Because what happened was flat earthers were going out, making observations and saying, hey, I've got this amazing new camera, the Nikon P900, and I can see this island that's 50 kilometers. Shouldn't that be hidden completely behind the curvature of the Earth? I'm going to post this video on YouTube, and these videos started getting millions of views. It started to become the most popular search term on the internet back in 2015, 2016. Okay, and it caused panic. They're like, what are we going to do about this? Right? People are going against the mainstream education system, against the mainstream narrative, and they got together.
Can you post it in the chat? Because I'd like to look at it.
The video?
Yeah.
There's an actual video. I believe it's with YouTube, and Yeah, and she tells them that they're going to censor it, and they're going to, and they did. They did that exactly.
Yeah. If you actually have a look at the search results statistics, you can see this huge spike back in 2015, 2016, where Flat Earth, went up like crazy, and then all of a sudden, after this Congress meeting, they shadow banned it, and you can see that, the spike goes way down. And what would happen
is they shadow banned the video.
Yeah, all Flat Earth content. So they started demonetizing Flat Earth channels. They started hiding this.
Took the views away. People that had 1 million views now had 10,000. There was all kinds of chaos that went on.
Yeah, there's all kinds of shit.
You guys are trying to say that they're trying to hide something from us. I mean,
well, they did. This is what they did, right? So
if they didn't, we didn't say
so difficult. They suppressed the content. Very simple.
Right.
Yeah. So let me give you an example.
What would they have out of it? What would they have?
It doesn't matter.
Just let me finish my sentence.
Fuck.
Okay. This is what they did. Just to give him an example. Okay. So when you would go on and you would type in the exact name of a video, a Flat Earth video that you wanted to watch, it wouldn't come up. Okay. It would be hidden completely, shadow banned in the search results. And instead of they didn't only just shadow ban it, they actually replaced the search results with a playlist of propaganda. That's why most people think that Flat Earthers claim a flat disk floating in space and stuff like that, because that's what they pushed as the search results instead of the real Flat Earth videos, which is a pretty shady thing to do.
So just simply, because I heard your question, so just to conclude this, because it's not that difficult to answer. The same reason why any wicked person decides to lie. That's why.
But it doesn't really make sense, because why would it lie about just one simple thing that can
why
be
would they
proven by
confess
everyone,
the
right?
lie? Why would they confess the lie?
They didn't only lie about the Earth. They didn't only lie about this one single proposition.
Mm-hmm. So
thanks, Stark posted the video. In this.
I see it. So that's the video, right?
Yeah, watch that before you talk anymore.
Okay, big guy. Okay, I'm sorry. Jesus Christ. Why can't you guys not talk normally? What the hell is wrong with you? Like, this guy's Globlin. You guys should give this guy this channel. Jesus Christ. So, I have one question.
Watch the video. Watch the video. They're going to tell you why they did what they did. They're going to tell you why they lied about it.
1 minute. I watched it's 1 minute long. I already watched it.
I'm going to mute him. He's too busy yapping. He can't see.
Watch it.
I did. I just watched this 1 minute.
Oh, who was the speaker? Long. Okay, who was the speaker there?
I don't know. Some guy, Mr. Doach.
No, it's a woman. It was a woman. You failed again.
This guy is also speaking. I mean, it's not really a big claim. I watched the video.
What's the plan? She was going to do what?
I don't want to talk to you. I'm going to mute you. I want to talk with Globlin. I don't want to talk to you. You're pretty rude. I don't like talking to rude people. Thank you.
That's not going to work in your favor. He's a mod.
But I don't care. He's a mod. I mean, I don't want to talk to him. I can talk to whoever I want.
Then don't talk to me.
But you're talking to me, man.
Yeah, you don't want to talk to me. That's
because you're being excessively rude. Like, okay, I don't understand. You've heard how I talk to him, so I don't understand why do you want to talk to me like that.
Well, you don't understand. That's fine. The thing is, though, you don't understand and you don't want to talk, but you continue to talk. That's a showcase.
I was just asking questions because I don't understand. Right?
Your logic is really that bad.
I'm not saying nothing about my logic. I just asked questions.
Yeah, it is that bad. Because if I don't want to talk to somebody, I don't talk to them. Duh.
And this is a grown man behavior.
all right. Like, enough of that. Okay, so next. All right, so I answered your latest question. Why would they lie about this?
Okay.
The same reason any wicked person would lie about anything. But why they just lie about this? Well, they didn't only lie about this proposition.
How you can find out if something is a lie?
Anyways, so what about, like, if the Earth is flat? That means it has the end, or?
Well,
like if it's flat, right?
It's a metaphysical fact, right? So no material object that exists has an infinite shape. Infinite shape entails that it occupies no volume, and of course, if it occupies no volume, And of course, it doesn't even exist at all, right? So whatever, any material object, the Earth or anything else that exists, has a finite extent to its substance and its form. It's just a metaphysical fact.
So, bottom line is, it does have the end, or it doesn't. Like, I just didn't quite catch.
Of course.
Of course. Okay. So, why didn't nobody get there, or what's there? Like, I just want to understand you guys.
That's a loaded question. Like your question presumes as though no one has ever been there.
Crazy.
You don't know that.
Right, but if there's an end, right, it will be pretty close to any like a continent, right? Itself. There's some people.
Why is that so? Why has nobody been to the end of the universe in your model?
Because we can't even go to like another.
Hang on.
Really hard.
Right, so maybe the Earth is very large.
Wait, hang on. Like pretty close in your question. It's just your personal impression. That's all it is.
No, but I just trying to understand it, like, why didn't anyone physically proven there's the end? If it's this simple, because for me it's simple, right? Like anyone can fly out, just go.
My point is that it's not objective, right? And no, not anyone could just do something as granted as endeavor as that either. Right? That's not a thing. You have to have the sufficient means, and there are much more difficult and complex tasks than others. So no, it's not a thing. You just have these presumptuous impressions in your mind and not objective.
Gotcha. Okay. Well, I mean, it's the same thing as thinking that God exists or he doesn't. Like, some people would have a whole conspiracy about it, and even putting both a person that's out of faith and a person that's not out of faith in the same room, they would never come to an answer. Like, this guy would never go with him, and this guy would never go with the other one, right? So I think that, even if you get with the same person... I
understand what you're talking about, but you kind of like played in some categories.
Yeah, I mean...
Like, obviously, the believer is a proposition A.
Exactly.
Disagree with the disbeliever is a proposition A, and on and on and on. Like, that's just a truism.
Exactly. That's why I know there's people that are debating, right? Like, I know there's a lot of people in this VC that went through ChatGPT and asked them, hey, give me give me some stuff so they can learn, what the answer and stuff. So I know even if I say high altitude curvature observation, they would have an answer. They would have an answer in gyroscopes, effect, whatever, and stuff like that. So, even if you get with someone, they will all pull up with stuff that people already heard, right? Because if you are learning something, you would know at least those majority of stuff, right? Because those are majority of stuff. Those are going to be the stuff that people pull up every day, right? Am I wrong?
If I could just add this, they're saying that Globers are in a religion because they believe in something they can't prove.
Okay, so where are you going with this, Warriors?
No, I'm not going anywhere. I'm just saying this whole flat Earth thing is not going anywhere, right? Like, it's just going to be people debating.
It's not going anywhere.
Did you ever prove that flat Earth is flat to someone that doesn't think that?
Yeah, every day.
Every day. Somebody said that, you're right.
Here, all of us here, dude.
They proved it to me because before flat Earth, I thought the Earth was a globe, and then I discovered that there's no way.
God, man, the vast majority of so-called flat earthers, including myself, were all raised, baptized, immersed in the worldview that you're still ensnared in. The vast majority of them. That's what they are. You're hard pressed to find someone nowadays in our generation that was born and raised knowing the fact that the surface of the earth is horizontal.
I'm hard pressed to find evidence for the globe.
I also want to know.
Think about it. How is space a vacuum if we have atmosphere?
I also want to know a little bit, piggybacking off of what Warrior was saying there. What is the main goal, objective, purpose, whatever you want to call it, in spreading the belief that the Earth is spherical or flat? Like, what is the real goal there, other than just believing it?
Exactly. That's what I want to know.
The focus is not just the Earth, right? It's not just the shape of the Earth. It's a part of a whole worldview that is an entire delusion, which you people are ensnared in. Right? You believe that you live on this lopsided ball in the boondocks of a black void that unintentionally was farted out by a question mark with no value and no purpose. So And so then what is it's sucked into nihilism and hedonism and statism, and they're easily manipulated by fear and envy and all the whole host of sins that has been produced by the application of this worldview, which we conveniently call scientism.
So then are you also saying, and correct me if I'm wrong here, are you saying that if you subscribe to the idea that the earth is flat, you also then subscribe to more of a religious idea, giving you more lenience to a creator possibly, or is that completely off?
Not necessarily, even though the majority are, like the vast majority of humans throughout all history have been theists and flat earthers, as we were.
Gregory, right? That's your name?
Yeah.
So, did you believe that the Earth is flat before discovering this VC or whatever?
Yeah.
Right. Okay. So, how did you came to that conclusion, and when was that? Like, was it while you were younger, or was it recent? Or
I was slightly younger. I was I was pushing 20. So, but yeah. I mean, once it was proven that the horizon is not what the globe Earth doctrine entails, it was over. Right. That's what it comes down to.
What is that doing?
Not what the globe Earth doctrine entails.
So what exactly is it doing for you specifically? I know everyone here might have a completely different answer, but what does knowing that the earth is flat do for you specifically? Whether that be spiritually, materialistically, it doesn't matter. What is it doing for you?
I know more truth. I recognize lies and the whole implication of the two. It's furthermore corroboration of the truth that God has revealed. It's furthermore edification for me. It's furthermore it's all that.
Okay, so let's just give a hypothetical that you mentioned God, so I'm gonna assume here that you have some belief in a God, and you pass away, and you find out that the Earth was spherical. Is that gonna do anything for you? Do you think?
It'll have some impact on me in that possible world, but given the facts, that's just a heretical hypothetical, as it were.
Yeah, it's like you said, just hypothetical. To me, it just seems that currently the understanding that something is flat Earth is just giving way to belief in that everything that you've been told is a lie. And I think that someone in the camp of
I don't believe that.
Oh, interesting. Okay, why not?
I mean, that's
because
I have enough knowledge and self-discipline to not fall into just irrational, radical skepticism just because I find out one thing, even a very significant thing in my worldview, was false.
Okay, because that's sort of what I got from you earlier when you said that, like, you don't subscribe to the lies that that we've been giving as a spherical society. So I see that what you're saying is that you're more able to capture those lies and call them out because you have defined one of them as being a lie.
Yeah, it's just the word for it is discernment. A lot of people don't have the self-discipline to exercise discernment.
Do you think that someone that believes that the Earth is round can have that same discernment, or no?
No.
Well, it's possible. They just have failed to apply it on the issue of geodesy so far.
Explain that to me.
Like you say, can they do it? It's possible. The given person may or may not have the ability, and they may eventually or may not discern this doctrine is false and realize the truth.
The truth of what exactly?
The geodesic issue.
Okay.
Why they need a government to shut it down? Because they even the government would say so. These people cannot think for themselves.
Yeah, so we need 2 weeks off work. Everybody needs to stay home for 2 weeks so we can straighten this all out. Remember? And then that lasted for 2 years. That's because we don't know how to control ourselves. We will die if somebody doesn't help us. If the government doesn't tell us what to do, we're never going to survive, guys.
I do want to answer Lao Tzu here. He says, how does believing you're on a suspended rotating ball in a vacuum just because you're told to serve you? Just because you're told serve you. I don't think it does anything for me specifically. Believing that the earth is round or flat does nothing for me at all. What Gregory was saying earlier's discernment is very important, and I agree with him 100%. But I believe that you can have discernment whether you believe that the earth is round or flat. It has nothing to do with my specific religious belief of believing that Jesus Christ is king.
No, actually, that's wrong in a way, because once you know the earth is flat, you can pick out all the lies that you see on TV all day long. All the lies when they tell you to stand 6 feet apart, you know that's a lie. All those lies are easy to spot now.
One of the things I actually said earlier. Hang on. What I actually said earlier was that you're right. What I actually said earlier, I said what the given person believing the earth is a ball can have the ability. Then I added another nuance. They may or may not have the ability. But I added another nuance. They may eventually or may not, right, discern this lie to be just that, and then acknowledge the truth. That's what I said.
Yeah, and I agree with you, definitely.
It just comes down to, it's just about finding the truth. And then when you know the truth, then you just want to share it. Like, for instance, take like grade school, kindergarten, everyone believes in Santa. Eventually, though, they learn, you were lied to, your parents lied to you. And you're like, what? Oh my gosh, your world's shattered. But you move on. But at least now you just know the truth. So like the earth shape and stuff, you're saying, what is it going to do for you? Well, it doesn't do anything for you other than you want to share the truth because you can still see the lie being pushed and you still see people believing the lie. That's all it is.
Yeah, I get where you're coming from, and I can definitely like agree with it, just because at least in my belief system I'm a Christian. So, me finding the truth in Christ, I go, well, now I want to share it with everybody. But the difference here is that the truth in Christ gives you something in form of like salvation and eternity, right? Versus something as trivial as this gives people nothing. Like you said, it doesn't do anything.
Wait. The facts about the God's creation is trivial?
Well, that's a good way to put it. No, not exactly. But then we have to define, well, what is exactly the fact here? Because if we're going to biblical scripture, just because we see the firmament in scripture and some portrayal of flatness doesn't mean that the earth is flat.
Do you know any religion who is saying...
leaping to some other argument that you're trying to anticipate, but...
Oh, then tell me what your argument was. I didn't want to jump around there.
So, number one, right? You think this issue is just insignificant. I mean, it's not insignificant, obviously, right?
Well, according to OG, it was.
Some people are not as good as articulating what they really mean.
Okay,
but he and I agree, just as he and I and many others agree, that this is significant. This is a very significant or a very important aspect of people's worldview. It's very obvious, right? There's no reason to deny this, right? On both sides of the issue, it's obviously an important thing, right? It's so important that even the movers and shakers of the world, so to speak, go out of their way to suppress the content that is trying to be published via the internet that contradicts the orthodox scientism, as it were. So it's obviously a significant subject, a very significant subject. And people have entire paradigm shifts of their worldview concerning acknowledging the truth about the subject and forsaking the previous lies. It's not insignificant at all.
So then to answer the question that I asked you earlier, then, the importance of believing this is a complete shift of worldview, then? That would be your answer.
Not a complete. It would be a radical shift. It'd be a lot of things would change. Many people, there's only Lord knows how many hundreds, if not thousands, of testimonies by now, especially since a decade is coming up since 2016, of people coming to the true gospel. And it was strongly catalyzed by realizing the truth about the cosmos, because it's not just the shape of the earth. Once you start questioning the shape of the earth, you inevitably, if you're trying to be consistent, right, you inevitably expose the the whole false cosmological lore that scientism has inundated everyone with.
If you, in my opinion, if you want to look at it from a spiritual side, I would say that heliocentrism is a doctrine of demons, and they've taken away from the Creator and His creation, and they've given you an entire scientific religion to believe in. It's an alternative to this, but that's my opinion. I think heliocentrism is a doctrine of demons, and there's a whole lot of stuff behind that, but I don't want to talk about it right now.
Okay.
Hey, Rise, have you heard of biblical cosmology?
I have, yes.
Okay. How do you reconcile the heliocentric explanation of what Earth is versus what God says Earth is?
Okay, sorry. Let me clarify there. I have heard of it. I just don't know it in detail. So can you explain to me what you mean by the biblical idea? And then
like the world shall be established, it shall never be moved.
Okay.
For instance, that's one issue.
Wait, that was it? That was it?
Well, there's a bunch. There's a lot of things in the cosmology.
More. You just
of
give
it
you
all.
one thing at a time.
Okay.
Let me share something just real quick. So, like one of my favorite things to make mention, and I jokingly say that I feel like Job was one of the first pushers of a heliocentric model without even realizing it. Because if you remember, in chapter 28, he's talking to his friends, and he's telling them that upon nothing, and he's giving them a cosmology. But then later down, when God steps in and backhands him, and he says, "Oh, if you're so smart, where were you when I laid down the foundations of the earth and I placed it upon it?" So, in other words, Job was speaking out the side of his neck. He didn't know how the earth was made, but he did make mention of this certain cosmology. That's the way I see it. That's the way I look at it. That's the way I read it. So to me, I'm like, Job is the first person that ever got flat smacked by God himself, correcting him. And then Job just sat there in silence. He had nothing to say about it. So that's just one thing.
We're talking about Job.
Where I tagged you, Rise.
Who just mentioned that? Who talked?
I did. Apocryphon.
That was Apocryphon, and then it was me, Gregory. See where I tagged you in the open chat.
I see Job 22:14. God, heavens of heaven of heavens.
Now, this image that I showed you is made by Logos, the scholars of Logos Bible Software.
Mm-hmm.
These scholars don't believe, they believe the scientism, false cosmology that we refute. But they themselves acknowledge that the content that describes the cosmos to be this, contrary to the scientism cosmological lore that they still clutch on to. So as it were, this is enemy, not to be too dramatic, but enemy testimony or hostile witness, where even the people who don't believe the cosmological lore in the Bible, scholars who understand the original languages, acknowledge that the cosmology that's described here in the maker of the Bible is contrary to the cosmology of scientism, which they themselves believe.
Interesting. I'm gonna go in there and look at each one individually. Obviously, not right now, not right here.
Yeah.
But this is interesting. What I do see in the Bible is, like he mentioned earlier in Job 26. I don't think it's 28, where the earth is suspended.
It's 26.
On nothing.
Yeah, it's 26. And then in 38. Sorry, I got that wrong. And then in 38, that's when. Here, I'll post it for you.
No, I have it right here. Don't worry. I got it in front of me.
Well, here's for the audience. Here's the two different ones. So in 26, he's saying this, he stretched it out in empty place and hanging upon nothing. And then God later is like, oh, hold on. Where were you when I laid the foundation of the earth? Declare if you have understanding. Right? He laid the measures thereof. And or who has stretched the line upon it. See, stuff like that, I feel like God flat smacked him right there and shut him up. Said, you don't know what you're talking about. But then later on, in the world of all these people saying, oh yeah, the earth is a ball and this is a universe, and they're just being that whatever demonic entity that told Job this information, made him say it, I feel like that just came back. And then here we are, just trying to flat smack people again, telling them the truth. Just as God told Job the truth in chapter 38.
Okay, I'm gonna go back and read Job. A little while since I've read that entire one, but I don't
consider this also. Oh, go ahead, finish it.
Yeah, I just don't think that verse 26 correlates to chapter 38. But obviously, I could be wrong there. But yeah, anyway, Gregory, go ahead.
Well, it correlates insowise as being as concerning cosmology and cosmogony. That's the point.
Yeah.
Okay.
It's him talking about as if he knows anything about it, and he says, and it was hangeth upon nothing. Well, if you think about it, well, that's kind of the heliocentric model, right? They say that the Earth is just floating in this vacuum environment, and it hangs on nothing. It's just rotating around the sun. But then God's like, "Where were you when I laid the foundation and placed it upon its pillars?" Like,
that to me
what I was fixing to say was.
Go ahead.
Yeah, what I was fixing to say is this: consider this. So, contrary to the common distortion and abuse of verse 7 in chapter 26, when you be strictly consistent, right, with scientism cosmology, the Earth does hang upon something that hangs upon, as it were, the gravitational pull of the sun. So that's contradicting what the passage says in Job 26.
I think that's just pulling on semantics.
The Earth is. Well, we have to do historical, grammatical exegesis of the text because the God says what he means in straightforward language and or figurative language. So when you read the passage, it's even in the archaic English of the KJV, he stretches out the earth, he stretches out the north over the empty place, and hangeth the earth upon nothing. So the earth is not hanging upon anything. Well, when you acknowledge the fact that the earth is standing still and not hanging upon anything, then there you have it. But the scientism cosmology pretty much asserts that the Earth is hanging upon the gravitational pull of the sun.
Yeah, I think you can definitely make that argument. I just think it falls flat just because it is pulling on semantics. You can feel free to make that argument, but
wait. What does it mean to pull on semantics if not speak meaningfully? That's what semantics is, the study of meaning.
Yeah, but in this situation, saying the earth is suspended on nothing and the understanding there that, or the lack thereof.
Hangeth the earth upon nothing. Not suspended.
Exactly. And the lack of understanding of gravity would make sense that, well, there's nothing there. But then the understanding and the further research tells us, oh, gravity is there, so now we can see and we could understand a little bit deeper. Sure.
Hang on. Why would you say that? That this is God-breathed scripture, where God is stating facts about the creation. There's no baked-in ignorance here. There's no ignorant assertion here.
No, I think our interpretation can be ignorant.
Well, hang on. When you do it's historical, grammatical exegesis of the passage, he stretches out the earth over the empty place. Okay, he's formed the earth to be in the form that it is, right? And he hangeth the earth upon nothing. The earth does not hang upon anything. These are facts. There's no ignorance in here, right?
That's why God corrects them.
So then what we do, right? What we don't have the prerogative to do is then superimpose some foreign metaphysical doctrine that is such as gravitation into the passage, so that we can seem more credible in the eyes of unbelievers who hate the light and love darkness.
No, not necessarily. What I'm saying is that just because we have a understanding of gravity doesn't negate the understanding of Job 26 verse 7, where he says the earth is standing upon or hanging upon nothing. Yeah, the understanding at the time was that the earth is standing on nothing or hanging on nothing. Because they don't know, because God can't go, hey, by the way, it's sitting on gravity. And they go, what the heck is gravity? We've never heard of this before.
They didn't believe the cosmology you believe. You're anachronistically, by implication, giving them a cosmology they did not believe at all. They did not believe the earth is flailing around in a cosmic black void like you do. and
I
just
think they
didn't
did.
understand gravity. No,
I think they did. It's just a lack of deeper understanding of certain specific concepts.
No, they didn't. They didn't. Even during the classical antiquity age, right, where Pythagoras became the prominent promulgator of this doctrine, right? Before him, even in his day, he was a quack minority that had little to no followers. Right, the vast majority of people did not believe that, especially as it matters. The Hebrews, the Ivrim, they did not believe that. There's no content anywhere inside or outside the Bible that conveys that they believe the cosmology you believe today.
But what did they believe then?
Right, they believe the illustration that I showed you earlier.
That the Earth is hanging upon nothing.
No, that it's on foundations.
Well, yeah, that it hangs upon nothing. It's not hanging upon anything. It stands up on a foundation.
Yeah, it's sitting on something. It's not hanging from anything. That's pretty obvious.
Okay. I see. I
Flat
misunderstood
Earth
you.
is a money scheme. That's why everyone here is muted. It's all a money scheme for you.
I understand what you're saying now, Gregory. So I misunderstood
There you go.
I misunderstood you. So it isn't that it's not hanging on anything. There is a foundation on which it stands upon. Okay.
Yeah, because my mouse is standing upon the table. It's not hanging upon anything. It hangeth upon nothing because it's standing on my table.
Okay. Yeah. Okay. Yeah. Definitely misunderstood you. Okay. So what you're saying here is that there's a physical foundation that we should see holding up the Earth.
I don't know about should, but I guess would. Should we have be in the right situation to be privy to that observation? Yeah.
Interesting. Okay. Well, we would agree to disagree there, but cool.
Yeah. Many people have work to do to reassess their worldview, to actually be epistemologically self-conscious, which is a $5 word just for saying you actually examine your worldview and become conscious of how you know what you know and why you believe what you believe.
Yeah, I think it's extremely. I think it's extremely necessary. I just don't think that something such as this is necessary for salvation in any sense. But like you mentioned earlier, it could be necessary for
that.
Yeah, I know. You mentioned that it could be necessary for maybe turning someone to the truth of Christ.
You've never heard
for the edification.
You've never heard
necessary for the edification of whomever. No, I'm gonna let you go after I finish this comment. It's necessary for the edification of anyone and everyone. You tell them the truth, they learn more truth, they benefit from it, and you refute the lies, they forsake the lies, and they recognize who the liars are, who the deluded are, who the wicked are. Then they can make the wise decisions to interact with them in the best way beneficial, at least for themselves and whoever else is precious to them, to the glory of the Lord.
Bitch niggas.
There you go. Okay. I could agree with you there. I'm obviously, like I said, I don't agree with the Earth being flat, but for me in this situation, I know Christ. I know the truth of Him. So this for me provides no further edification. Maybe there's something I'm missing, but I don't think it does.
I love Jesus. Do you believe His word?
As a child,
yeah, definitely I believe His word. But I said earlier, I agree to disagree with Gregory because we have different understandings of what that means.
Well, hold on. His word explicitly describes the earth as a flat stationary plane.
No, it doesn't.
So if you believe His word, it doesn't. Okay, so how does it describe it then?
Oh, please tell me what you're referring to because you have the scripture because you brought it up.
Yeah, I mean, just Genesis 1.
Genesis 1. Okay, where exactly in Genesis 1?
Right in the beginning. In the beginning, God created the heavens and the earth was out without form and void, and the Spirit of God hovered over the face of the deep. That word "over" is a horizontal vertical relationship. The waters are flat.
What the hell?
It's not.
No, it's not.
No, it's not.
Yes, this.
Oh, so can you have over anything except for horizontal? That's a horizontal vertical relationship.
In the same way that I can hover over a ball and I can hover over the top of the surface of the ball, and I would still.
What would be the orientation?
Horizontal.
The form of the surface of the wall.
Thank you.
Yeah, that doesn't negate the fact that I'm hovering over a spherical ball.
Okay, but if you're over the face of the deep,
Is that correct?
The face of the deep, that face. Yeah, just think about it for a minute.
Yes, you're saying that I am hovering horizontally over the surface of something, right? And your understanding here is that because I'm hovering horizontally over it, therefore that object must be flat.
The face of the waters, right? So the face of the deep, the face of the waters. Are there any waters that you can show me with curvature?
No, because I don't know exactly what you mean by that.
Well, number one, if you're saying he's hovering over a ball, which is not being described there, he's hovering over the face of the deep. What side of a ball is the face?
Pick a side. There's many points on a ball, so whatever.
No, I'm asking you. I'm asking you to tell me which side of the ball is the face.
Whichever one you decide, which is what I just said. Pick a point.
I'm asking you. I don't believe in a ball. Right. No, see, it's interesting how you've instantly become triggered and now you make this combative. I'm asking you to tell me where is the face on a ball?
Okay. Maybe you think I'm being combative. Let me lower my voice. A ball.
Lowering your voice doesn't prove you're non-combative. It just proves you're passive-aggressive.
Congratulations. So,
excellent.
Say who?
So which side's the face? And there was also a qualifier added in by yourself.
Hammer, I appreciate your input. Can I answer him?
Yeah, thanks. We'll do it.
Thank you. Who, if you have a basketball, and if we understand math, we know that that basketball has many points.
No, it has one surface. It has one surface, not many surfaces. A ball has one surface, not many.
Correct, made up of multiple points. That is what math teaches.
It has one surface.
Yes, I agree with you. That is made up of multiple points.
No.
Okay.
Does it say the guy hovered over the point of the deep, or did it say the face?
The face. So whatever point
Thank you.
we select,
So which
that would be
face?
the face.
No, you don't pick a point. He said face, not point.
Then
you're going to change the word of God on the fly, and this is why I know you don't believe the Bible.
No, this is why I told Gregory earlier we agree to disagree, because we have two completely different understandings of what that means.
You're disagreeing with God's word.
No, I'm disagreeing with you.
No, you're disagreeing with the wrong thing, dude.
Imagine if it said it hovered over a point on the face of a ball.
Okay, sure.
Yeah,
but I'll do you one better.
It says over the face.
So you want to say exactly what you wanted to say.
It doesn't say hovered around the face of a ball either.
It doesn't.
I'll do you one better, man.
That object can be a sphere.
I'll do you one better. It doesn't even say object. It says the face of the water. So you tell me, is there any curved water on the surface of the earth consistent with a ball?
We'll completely disagree with this.
No, it's not a matter of disagreement. It's actually about geometry. There's no disagree or agree here. This is just geometry. Yes. So, is there any water on the surface of the earth that curves consistent with a sphere?
The oceans of the world.
Okay. Show me how they curve. Give me the measurements.
I don't have the measurements on me. I appeal to
Who does? Okay, well, what authority has them?
Yeah, does without form mean in the shape of a ball? Like, come on, dude.
Does without form mean a flat surface?
Yeah, no, flat is not formed.
You're not saying that there's a shape.
There you go. So you can't say it's flat.
Listen, it doesn't even apply. There's an embedding space for it. Like,
we're
getting lost in trying to like.
No, you're trying to objectify something that's without form and void, and I think it's silly.
Hey,
order in the room, guys.
I think
Come
so
on.
too.
Just real quick, let me jump in. So there's also something that I think is being missed here, because if you look at the original language, right, and the way it was written, that there is a difference between chug and hug, or dur. And so, for instance, they had a word for a ball.
Sorry, OG, can you churg, durg? Which word are we referring to exactly?
Yeah,
he means hug and dur.
Yeah. So there's a word that they know in their language. They very distinctively what a circle, like a flat circle, like a disc, right? As opposed to a ball. Like there's two different things. And in the scriptures, when he talks about he took a compass and he drew it on the face of the deep, that word used in there is hug. And that is a flat thing. That's not a round thing. And later on in the scriptures, they do use that word dur, which is a ball, because he says you'll be tossed to and fro like a ball. So if it was a ball, he would have said he put that he would have put it like a dug, like a ball. But he doesn't say that. He said it says like a hug or chug, however you pronounce it. But that's a reference of flat.
Okay. I can give you that. Now, where do you find this? What language are we talking about?
In Proverbs, that would be in Hebrew. In Proverbs, and also in Isaiah. I think it's Isaiah 40 something.
Okay. Whenever you get the time, if you could just send it in the side chat, I would really appreciate it, because I will go in there and look at this stuff.
Yeah. Okay.
Lexical summary. Shug inscribed a circle. Okay. Thank you, A&G. I appreciate that.
Here, I'll post the references for you.
Mm-hmm.
So, says who brought up measurements earlier, and maybe you haven't looked into it, but we've been looking into this for the last 10 years or more. Okay, we've got hundreds, if not thousands, of tests that have been done now, where we go out and we determine how much curvature there should be over a certain distance, and then we test for it over and over and over again, and every single time, there's zero curvature measured over these distances. Now, when you go digging into the evidence for the globe side, you're not going to find any empirical tests that validate any curvature whatsoever.
That's actually very interesting that you bring that up. I watched once a flat earther do his test on the pinhole test with a laser, and he was out there ready to say in fact that the earth was flat. And as I was watching him do that, he puts the laser and he goes, if the earth is flat, then the laser should hit an X spot in this other point over here. If it is round, it should point lower. And he was a flat earther. And it's really funny. It's caught on camera. The guy looks through the pinhole and the point is lower. And he goes, this can't be true. Oh, this can't be happening. Oh, maybe my devices are all faulty and messed up. And the flat earther proved himself.
That's not what happened. So
it's really interesting.
You butchered it. Okay, so firstly, that's just a Netflix hit piece against Flat Earth.
Yeah, maybe it was. Maybe it wasn't. But it was very funny to watch.
And secondly, they got all the math wrong. The guy in it named Jaron, he's a moron. Okay, he's just some dumb stoner. They tricked into going on a mockumentary. Well, this is the thing. No, this is the interesting part. Okay, you saw 52 seconds worth of footage out of that. Okay, it didn't show you the test. Okay, it didn't show you the distance. It didn't show you the setup. You don't know anything about it. You just saw some TV show that was a Netflix film.
Very
tell
true.
You that a debunker, tell you that a flat earther debunked himself. What we're talking
very
about
true. I'll give that
professional tests that have been done. We got teams of field engineers going out with $30,000 lasers and things like that. We got PhDs going out doing long distance observations, seeing things that should be hidden by 5-story buildings that are clearly visible. Okay, over and over and over again, not some small amount of footage off some Netflix hit piece. Okay,
and you're totally right.
That's what I'm talking
I will give you that 100% because that is exactly what happened. Out of ignorance, I watched a small piece, and that is exactly what happened. So I will give that to you. But what I won't give to you is the fact that I have seen other people, and I have looked through other data of other individuals who have gone out and go, well, yes, this portion, and obviously I don't have it on hand, unfortunately. This isn't my field of study. So these individuals have gone out and said, yes, there's curvature here, and then have also gone out to other places and said, well, there's no curvature here. There's a flat piece of land in this area. So I wish I had everything on hand, but this is not my main, debate topic that I do.
So you might be able to find some sections of land that have flat spots. Okay, so you wouldn't want to do a test over the land. You would want to do it over a level surface, like a body of water, for example. Because any body of water, let's say we have a 10-mile body of water and the Earth's a globe. Okay, that has to be curving by about 66 feet over that distance. Anywhere on the Earth, any 10-mile body of water, anywhere, any altitude, ocean, lake, because of gravity. Okay, it dictates that it would have to be about 20 meters or 66 foot of curvature over that distance. And if we can go and test it over and over and over again and show that there's zero curvature over this distance, and then you could go and repeat these tests yourself, right? That that is a big problem for the globe. And we're more than happy if you can find any test that you think where someone has actually validated Earth curvature. We're probably aware of it. It's probably been debunked, and we're happy to go over it in good faith and explain it step by step, not just say nah or anything.
Oh no, yeah, I'm sure that some of you are 100%. I don't negate that there's people here with very good faith arguments. It's just, there's obviously people who aren't. Would you think, or would you say that if you did the test yourselves, and this is only a hypothetical, and you came to the fact that the Earth is round, and you performed these studies multiple times, and the Earth is round, would you then maybe engage in conversation and realize that the people on the other side, they just don't want to agree, no matter what evidence you provide to them? So therefore, you just go, well, all of their arguments are dumb. I'm just going to start talking to them.
Exactly, dude. I did that exact thing. Okay, so I heard about this back in 2017. Okay, I thought, the guy that was telling me about it, even though I knew he was a smart guy, I'm like, damn, this guy's lost his mind. And I saw a bunch of these tests, and I thought, that's crazy. I need to confirm this for myself. I went and bought, it was about $700 at the time. I bought a really nice camera, zoom camera, and I lived on a giant lake called Lake Macquarie in Australia, and we had a huge section across the lake that was about 15 kilometers across, a little bit more than that. And I went out on my boat. I must have done at least a dozen observations over a couple of months period, and I was able to set the camera up just above the surface of the water and zoom in all the way across to the other side of the lake, and I could see the white sand shoreline on the other side consistently. I tried it different weather conditions, daytime, nighttime. I could consistently see all the way across. Now, if you do the math on that, there should be a huge amount of Earth curvature over that distance, well over 50 foot, I think about 80, 90 foot of curvature over that distance. So if basically the shoreline on the other side of the lake would have to have about a 7-story building or more. Okay, and then I would just see the tip of the building sticking out from behind the horizon. But I could see the shoreline to shoreline consistently. So I've seen so many tests that have been done now. I can't see any curvature being detected, and I've been looking for it. So,
and this for me would have to be obviously me looking more in depth to it. I remember, I think I was 14 at the time. We went out to the beach. I used to live in Los Angeles back in the time, and my dad and I went out with like a really big binocular that he used to have, and just thinking back to that memory, I looked through the binoculars and I just saw the tip top of a boat. So like at the time, I didn't really care if the Earth was flat or round. It doesn't really matter to me, right? But I just remember seeing the tip top of the boat, which then to me is like, okay, well, if the Earth is round, then I should be only able to see the tip top of the boat. So I'm sitting here thinking, well, that to me is evidence that the Earth is round. But I will give it to you. I haven't performed any tests. I haven't really looked into this because this doesn't matter to me. It's not a really big contention of my salvation within Jesus Christ or not. But it's just, I like having conversations with people, so.
Hey, Globlin and Gregory, I'm sorry, guys. I'm at my work and I had to leave. So I just want to, if you guys allow me to, I just have like a few questions because I said I'm not trying to debate like for now, but I just want to understand, let's say. What do you guys say about Willie Post, the guy that flew around the Earth in 1940s or something like that, I believe? He flew for 7 days. And he actually came to Berlin, where he started from. So, what do you guys say about that? I mean, I just want to understand.
Oh, Globlin said he had to mute right now, Warriors, because there's
okay. I
noise.
mean, is
the guy flew a plane from airport to airport and then came back. There you go.
You said the guy what now?
Flew a plane from airport to airport and went around and came back.
No, but like he did like straight line.
No, he didn't do a straight line. You can't do straight lines like that.
But
you can't fly an airplane in a straight line, dude. No.
There's like
you have to get fuel. You have to stop to get fuel and all that stuff. That's why it took him a week.
I mean, he can stop, get fuel, and then get back to the same line where he was flying from. That's why he was having the same map with him.
There wasn't airports in a straight line all the way around a ball.
Of course not, but like he would follow the path where he was flying from, and then continue flying the same line.
Let's look in a side chat of what he really did. Let's look. Let's take a look at what he really did.
Any way to tell if he was nosing down the entire way?
Sorry?
So if we smash a globe,
Nosing down the entire way.
So if we smash a globe down flat and we put a compass on top, we can go around the North Pole, right? Look at the side chat.
Mm-hmm.
How's that going around the ball?
Fair enough, but I
Couple
mean,
questions.
why did he? I can't post into the chat because I don't have permissions to post pictures. But there was a thing that I saw on the post, right, in the magazines and stuff that was posted in 1940s and ABC News and whatever. They posted his map, so he was doing like he was like following the path where he was flying from, and there's like the map, and it shows us like straight line, like straight line. He was not flying like around. It was just flying straight line from Berlin.
Didn't somebody show you what straight lines and curved lines look like on maps for flights, or was that not you?
No, that was not me. That was not me. But I'm just asking about this specific term. Like, what do flat earthers think about this guy Willie Post or Willie?
First, they need to be
Miley?
claiming he went in a ring, like in a circle.
He went the way I showed you with that compass. That's the way he went.
Correct. But why did they send the like the straight line thing that he was following on his map?
Well, he's following a compass. You can't follow a straight line. You can only follow a compass.
Yeah, but I mean that was in 1940s. I mean people knew how to use maps.
Compasses in 1940. Right? Yeah, they had compasses.
Yeah. Yeah. So if he like there was a map that he posted, as I said, and it was showing a straight line. So let's say that he was flying from one
you were looking at charts. Yeah, it looks like you were looking at charts, and those maps are flat too. By the way, did you know that?
Is he thinking about a Pac-Man Earth, this guy?
Yeah, I think so.
What was the name of the guy? Lost Warriors? I'll look up the path. Willie something?
In the meantime, I would like to direct Rise's, at least his attention to where I tagged him in the open chat. I'm gonna do it again because I've developed these screenshots here about another passage in Scripture that explicitly teaches the Earth surface is flat / horizontal. So the passage is in 2 Samuel 11. The screenshot that I'm going to show you is of verse 6 through 11 in chapter 11 in the 1537 Matthew Bible. And then I just gathered some facts about this. So let me tag him again. Rise, and there he is, and there you go. Press send. So there it is again. So the passage in the Old English says flat Earth, right? Referring to the territory that this Ammonite army was moving through. Was it Ammonites? Hang on. Let me look at the proper screenshot. Was it Ammonites? Yeah. Not the Ammonite army, but the given army in its context was moving through. Okay. So you look through these screenshots that I have here. So let me make this clear. 1537 Matthew Bible in that screenshot with all those passages that talk about all the various aspects of the cosmos, not just the shape of the earth, right? But it includes passages about the form of the surface, which is not a convex, it's flat horizontal. So this passage in 2 Samuel 11:11, containing the phrase flat earth, right, is referring to these open fields where this given army was encamped. All right. So this plain is in Rabbah, an ancient city named Rabbah, which is now modern day Amman, Jordan. Okay, in Jordan. It was the capital of the Ammonites at the time. Okay. So you get some little geometric facts about Rabbah at the time. What's the diameter of Rabbah in kilometers? In kilometers, it's 0.9 kilometers, 900 meters. In miles, it's 0.56 miles. Okay. The whole fortification perimeter was 1 mile, 1.06 miles. But the whole radius that they were moving through was 12.5 miles. And the Bible calls Well, the Lord is describing at least 12.5 miles of territory flat about this area. That's not consistent with the doctrine that the earth is a ball, because there would be plenty of curvature. Remember, 8 inches per mile squared.
Now repeat that all back.
So, Gregory.
He is deafened, so I guess he didn't hear that. Go ahead.
So what would you say about the guy that quoting flew around the Earth in 1950, the Willie Post?
The liar. They just told you.
The thing about that he flew all in circles.
Of course.
What did Triangle just say to you?
Right, but so you would go with the same thing that he said, like you would agree. That's what you're saying.
If you go follow a compass, you will go in a circle.
Mm-hmm.
Yeah, you just have a geometric conception in your head, but out of habit because you're inundated with this doctrine. Just because you take a airplane, take an aerospace vehicle, and you fly around in a circle, doesn't necessarily entail you flew around a ball. You can fly in a circle above a horizontal surface.
Yeah, you go around your house. Doesn't mean you're on a ball. You just went around in a circle.
So if you,
it's as simple as that. That's all there is to it.
Would you agree that if you can't look to the horizon for evidence, you can look up?
What kind of, that's a malformed question. Why can't I look to the horizon?
I mean, I'm just asking. Like, do you agree to that astronomical proof from stars?
Astronomical proof of stars? We see stars all the time. Oh, from stars.
Yeah.
Okay, so what you're trying to do? Okay, let me just.
No, I'm just asking. Like, what do you think?
I get the question. I get the question. Okay, what you're trying to do is you're trying to make these appeals to the celestial phenomena. Okay, all that is a weak inductive appeal.
No. I was just talking about stars.
I get it. Yeah, it's celestial phenomena. That's the stars.
Yeah. Okay.
That's what you're talking about. Okay.
Yeah, the stars.
So so that type of appeal, all the particular arguments you can make in that category, right? It's just weak induction at best, or affirming the consequent. That's the only types of arguments you can make from all those appeals. Either it's just a weak induction, which ignores the strongest possible induction to actually empirically verify the proposition the earth is a ball. And the best way to form them, even the most strictest syllogism, is going to be affirming the consequent. So it's not logically sufficient.
Right. But like, of what I'm thinking, what I was, thought during my lifespan so far. Correct me if I'm wrong. I'd love to be corrected. Different stars are visible from different parts of the Earth in two distinct ways, right? Like first, there's the division between the northern and southern hemisphere. If you're in the northern hemisphere, you can see Polaris, the stars, that star is nearly direct above Earth's north geographic pole. But as you travel
I'm
south,
familiar with all this.
right, Polaris sinks slower toward the horizon until it disappears entirely. So at the same time, new how do you call them? Constellations. They appear, right? Ones that would be completely obscured by Earth's curve if you stayed up north. So that effect is impossible on flat Earth. Like that's
Okay.
what gets me.
You said
gets
the word
me not-
impossible.
Yeah.
Okay.
Yeah.
I really don't believe you understand just how powerful that word is in this context. So you have to prove to say it's impossible means that the proposition entails a contradiction. So you're conveying to me the proposition we can see that phenomena, that type of phenomena, upon a horizontal surface of the earth entails a contradiction. So what's the contradiction that's entailed by that proposition?
I mean, what I told you about the constellations, they appear, right? Like at the same time, the new one appears.
So once they'll be
that's not
completely
you telling
obscured.
me a contradiction. That's a table.
The contradiction is that they will be completely obscured by Earth's curve if you stayed up north. That's the contradiction that I have.
You're still not telling me the contradiction. Let me help you. You don't understand how to do this. To tell me what the contradiction is, you have to state the P and not P that's entailed by the proposition. For instance, the cat is black. The cat is not black. Okay. So what contradiction is entailed by the proposition we can and or do see this type of celestial phenomena upon a horizontal surface of the earth?
I just told you that would be completely obscured by Earth's curve if you stayed up north.
That's not
the
a P and not P. That's categorically not the answer you should be saying.
Okay, but either way, can you explain that phenomena to me? Like, let's just go with that. Oh, Professor, can you shut up? Gregory, can you explain me that phenomena? I just need the explanation how it works.
Impossible.
I'm not trying to debate you. I'm just trying to understand. So, Professor, you can shut up. I'm not trying to debate him. Don't be a dumbass, bro. Let me talk to him. Gregory, can you explain to me how would you explain to me that phenomena? Because you what from my view and from my learning.
Before you segue to what you think I want to affirm, I'm still not done with refuting your assertion. Because your refutation was this is impossible, right? This impossibility is an a priori concern. I'm virtually certain you don't recognize a lot of these terms, but you don't understand that, which just proves you don't understand what you're talking about. You said it's impossible. That's what you said. That's the word you used. Right? That all that entails that you understand, or that you seem to be conveying you understand, that you're making an a priori knowledge claim, and that you understand the limits of logical cogency and possibility. Okay, to say something is impossible is to say that it ain't. In fact, you didn't even specify what mode of possibility that's impossible. Okay, so before I even get ahead of myself, actually, in what mode is it impossible?
In what mode?
Yes.
What is a mode in the life? Okay. That's astronomical proof that I've given you, and I'm just asking how would you explain?
Let me help you. So you don't understand that term either. So there's a concept that is modes of possibility, right? Possibility isn't only said in one sense, or impossibility isn't only said in one sense. For instance, if I tell you the Bachelor is married, right? That's logically impossible, just given the very meanings of the terms, because the Bachelor is not a married person. So the person who is not married cannot simultaneously be married, right? That's logically impossible. Another example is me simultaneously existing in two positions simultaneously, right? I'm in position A, I occupy volume A and occupy volume B that's entirely separate from the volume that I'm occupying already. That's metaphysically impossible, right? Given the nature of matter, the nature of space and time, the nature of all these things, right? That's not metaphysically possible, okay? Or epistemological impossibility or possibility. All right, I can go on with all these other examples.
Gotcha. Okay, so let me just ask you this, right? On a flat Earth, how can some stars be completely invisible from one location but fully visible?
Well, again, we're not done yet.
A few thousand miles
We're not
south?
done with the refutation for you. We're not done yet.
Okay, but I just need that answer. Like you just want me to
hang on. Like we're not done. Wait, no, we're not done with the refutation to you. You're trying to skip past my refutation. We're not done with that. Okay, this is all relevant to what you said, and you have no idea about all these things that are immediately relevant, categorically relevant to what you said. But it's all this really just exposes you don't know what you're talking about. You have no idea what it really means to say that something is impossible, especially in this context about this particular proposition. Okay, but that's why I'm trying to help you so that you can build the best possible argument. Because I can help my opponent build the best possible argument and still refute it. Because I know what I'm talking about. So you said it's impossible. So let me give you a screenshot so you can decide which mode of possibility you want to try to argue. It's very simple. Give me like 30 seconds. Possibility. Yeah, there we go. That's what I need. Okay, right there, bottom of the open chat.
Okay, so you want me to like base on this or what?
Yeah. So which mode of possibility? You said this is not possible. Which mode of impossibility?
Let me see the picture. Okay. So it's a table that ranks what kind of possibility is strongest or most necessary. So I don't understand. Like which mode of possibility is the thing that I just told you, or
Yeah. Which mode of possibility or impossibility are you asserting?
that would probably be physical mode. Yeah, physical
Okay.
one.
So what identify by name to cut to the chase and get down to it already. Specify by name the physical law, the law of nature that is contradicted by the proposition. We see this celestial phenomenon, the one you just talked about, on a horizontal Earth surface. Specify which law is violated.
Wait, are you asking me about like complete like of what we were talking about, or just anything in general?
You said. Let's talk about what you said. You said to us that this whole phenomena of excuse me, this whole phenomena of seeing the given star for convenience, you chose Polaris, which is fine. All right, it's entirely fine. Nothing wrong with that. Okay. Polaris ascends or descends as you move to and fro from the North Pole in your worldview. All right, that's what the epicenter of latitude and longitude.
I suppose it's explained by the line of sight principle on a curved surface, like spherical geometry. So stars disappear below the horizon because the Earth curves and light travels in straight lines.
Yeah, I get your worldview. All right, I'm tracking all that. All right, so you said that this celestial observation, this type of celestial observation, is not possible, impossible, quote unquote. You said the word impossible.
Yeah, I said impossible. Yeah,
on a horizontal Earth surface. So which physical law, because you chose physics, laws of nature, specify by name the physical law, that proposition, right, contradicts.
The proposition for about the stars, or
yeah, that phenomenon being observed from a horizontal Earth surface. Which physical law does that proposition contradict?
I mean, I don't think there is a single law of physics, but I mean that says Polaris disappears when you move south. But I mean, there are a few ones that like it falls from the law of. I actually don't know. There's a few ones. There's not a one that's a single law of physics, right? There's like I don't
sound
think
like
you can
have at
ask
least one in mind, so just specify by name what that law is.
spherical geometry of Earth. As I said, that's the one that I have in mind. The Earth is round.
Okay, look.
So you move
let me
when
give
you
you a
move
pass
south.
with this.
I mean,
let me give you a pass with this. Spherical geometry is not a law of physics. Okay, that's a mathematical concept. So you just committed a category error with that. Secondly, actually, there really is nothing else to say about that. You didn't actually identify a physical law. You identified a concept in math.
I mean, how about
Just look-
law of
Hold on a
propagation
second,
of
Lost
light?
Warriors. Look, you made the mistake at the start by assuming that it would be impossible on a flat Earth, rather than just asking, how would it work? And then that's what's led down this path of Gregory
No,
going.
but
over the
I
logic
said
behind it.
that's how I was
The
learning,
Globlin
right? That's how I
is-
learned.
Is tired of seeing you bleeding on the ground. That's why he interjected like that.
Correct, but I was not just popping up and say, "Oh, this is impossible." I just said, "This is how I was thought during my." That's exactly what I quoted, right? I said, "This is how I thought during my lifespan," right? That's what I said, Gregory.
So then you don't know this. So you don't know. So just be
This
clear.
is what I know.
You just said.
This is what I know, right? That's what I
No, hang on.
was
This is
taught,
what you
right?
believe, not what you know. Hang on. Just
Correct. I
we
mean,
get what you're saying.
yeah. You can say that. Yeah.
Just let me summarize. Let me reply. We get what you're saying. You're saying this is what you have been taught. This is what you believe. You've proven that you don't know
You can
this.
say that.
Right? Believing and knowing are not the same thing. Being taught and knowing are not the same thing. So you don't know this, but you've been taught and you believe this. It would just expose that you had no idea what it really means to say that this is impossible. I had to teach you what that means. All right. And then and then when I gave you all the information to make the best possible choice, you categorically identify something that's not a physical law. Okay, so you don't know this, obviously.
Right. So I mean, as I'm saying, of the like, there's law of, and this is what I just found, right? So there's a law called law of rectilinear propagation of light, a named law in optics that says light travels in straight lines in a uniform medium.
Okay.
It doesn't
So do you
look that.
believe?
Do you mind if I jump in for just a second, man?
Go ahead.
We can just move quickly past this. Lost Warriors, yeah. It does, the atmosphere is not a uniform medium. So anyway.
Okay, so you're saying
look, there's some
atmosphere
things
is not uniform
you're
medium.
going to be able to explain just fine if you assume a globe, and you're also going to be able to explain certain things on a flat Earth as well. Okay, some things fall into both baskets. Now, the way our perspective works, let's say you're standing on the street and there's a street light above your head. Okay, and you start backing away from the street light. As you get further and further away from that street light, okay, let's say when you're standing under it, you're pointing your finger right up at it. Okay, keep your finger pointing at it and you're going to back away. As you keep backing away, it's going to go down and down and down. And then eventually it's going to converge with the horizon. Okay, that's just a product of perspective. So picture it the same way with the star. Think of Polaris like that streetlight, and as you move further and further away from it, it's going to appear lower and lower in the sky. Okay, by the time you get to a certain distance, it's going to be so close to the horizon that you're looking through all of this atmosphere that's semi-transparent. Okay, you can't see forever through it, and you're not going to be able to see it anymore. You're going to see different lights when you look up at the section, just like you would see different streetlights if you were doing the streetlight example that I gave you. Now have a look at what Apocryphon posted in the side chat. These are some giant warehouses, and let's say one of these warehouses was thousands of miles long. Okay, you're going to look up, you're going to see different lights up on the ceiling at one part of the warehouse. If you go all the way over to the other part of the warehouse, you're going to see different lights up on the ceiling. Okay, that doesn't require the warehouse to be a globe or anything like that. Okay, you have a limited field of view, depending on where you're standing. Okay, so you're able to explain it just fine on a flat surface. Does that make sense?
Yeah, it does. I mean, the atmosphere bends light slightly, but that only changes positions a tiny bit near the horizon. The fact
right,
that
this is just perspective. This is just it's just about
everything is
perspective. Don't worry,
right?
You could just assume the light's traveling in straight paths for the thought experiment, but it's just to do with your perspective. Just like the streetlight example that I gave you, it's got nothing to do with whether here, I'll post a picture in the side chat. Have a look at this one. So once you wrap your head around it, it will make sense. So let's say you were standing at the distant part of the street where it looks like the street lights are converging with the ground. Obviously they're not. Okay, they're all the same height. But if you were down that end of the street, you could point up and you're going to have those street lights that look like they're at the horizon directly above your head. Okay, and then you back to this point where the picture's taken, and now it looks like they're converging with the horizon. Now imagine if this street was way longer, thousands of kilometers long. You're not going to be able to see all of the street lights. You're going to have implications due to the way our perspective works and due to the density of the atmosphere.
Okay, well, you can say it's a perspective. I mean, as everything.
Well, we all agree that perspective exists. I mean, if you look down a hallway,
of course,
everything converges into a vanishing point. It looks like the ceiling is going down. It looks like the ground is going up. It looks like the walls are going in, and it turns into a little point in the distance called a vanishing point. And that's the same thing happens with airplanes and clouds and stars, streetlights.
Yo, free Palestine.
So there's that fact Globlin told you. So there are several factors upon visibility, both intrinsic and extrinsic, or internal and external. Okay, so the argument that you just tried to suppose basically ignores the reality. You don't thoroughly appreciate and understand the consequences or the effects of all the factors of visibility, internal and external. Right? Your eyes only see so much. Right? If the thing is too small, you can't see it. If the thing is too dark, you can't see it. If the thing is too bright, you can't see it. If there's too much in between you and the given object, you can't see it, etc., etc. Right? That's not necessarily some solid body or liquid body. If the air is too dense between you and the given object, you can't see it. Furthermore, you have a presumption about the nature of light, because you've been inundated with another metaphysical notion that light is a bunch of little specks, particles, quote unquote, that zip through the volume of the world, through the black void at incomprehensible speeds, at incomprehensible distances, right? When there's been no verification of that, all that lore at all, right? What we actually observe is that even the greatest light source that we've ever seen, the sun, has a limit to the extent of its light rays, just as every other light source that is far less powerful than it.
Thank you.
The second most powerful light source we've ever seen is the moon. And everything else is a bunch of artificial lights, and they don't even stretch for a mile, let alone across half of the face of the earth. Light does not stretch infinitely upon billions and millions of miles. It does not do that. We've never seen it do that. It's just a bunch of metaphysical lore we've been inundated with. No, he's not here, so, but anyways. Whoever heard that heard that.
Did he leave?
All right. He's not here for whatever reason. I'm not going to presume anything. But yeah, that's another, and that's one of their points of metaphysical lore that they're really mostly not self-conscious of. They just absorbed it involuntarily, and it's just like a given that they never really scrutinized. When they actually examine every instance of light from any given light source they've ever seen, they've never seen light stretch infinitely, not even trillions, not even billions, not even freaking hundreds of miles, especially an incoherent light source. It's not a thing. But yet they still believe in the back of their mind, to some level of consciousness, subconscious, or conscious, that light is these little particles that zip at incomprehensible speeds at these unfathomable distances across the black void. Never actually seen any of that.
So who actually believes the Earth is flat?
What did you say, mate?
So who actually believes it? Wait, sorry, first question. Why is there so many people muted here?
Because we were listening.
Everybody to talk at the same time.
What did you say?
Why do you think?
See how what it sounds like when everybody talks at the same time and we don't mute up?
Would you like us all to just unmute at the same time and talk over each other? We can do that. We can just make a bunch of chaos if you need that.
Out of the way. Now we've got
it's just like there's about 30 people AFK here.
Oh God, dude, what's your
we're listening. Sometimes we engage in conversation. Sometimes we just listen.
Right? Yeah, massive channel. There's so many people. Yeah. So does anyone actually believe the Earth is flat?
Yes.
All right.
Was there another follow-up question after that?
Well, I didn't think anyone actually did, but just interesting. Just don't really get how it is.
You would be surprised to learn, like a basic historical fact, like the vast majority of humans throughout history.
I'll speak at once today, I guess.
But isn't there a lot of maths and science based on? So if the Earth was flat, then a lot of like calculations and formulas that have been used to create.
Through this guy, can we at least let him get it out? sorry, my friend, but you got people talking through, and I can't bloody
So,
hear you. So, all right. So start again for us.
I'm pretty sure you know there's scientific calculations, formulas that prove like it's how things are made, how things are developed. They use crazy formulas like gravity and all this mathematics. I'm pretty sure if the Earth was flat,
that's you, bro. There you go. That's you, bro.
Yeah, so I'm pretty sure if the Earth was flat, a lot of those calculations wouldn't make any sense.
Okay, specifically which?
Well, wait, are you saying gravity doesn't exist?
Okay, explain gravity to me.
No, like, you're saying that there. Well, obviously there's mass behind it. You know, like 9.82 and whatnot.
Okay. So that's the rate of things accelerating towards the floor in a vacuum. Okay.
Right.
Okay, good.
And what about
where you're trying to get to, dude?
Well, is there a magnetic field of the Earth? But what about the magnetic field of the Earth? How's that explained then?
We don't need to explain please, we don't need to explain this phenomenon, but what me and you need to do is stay on one line of questioning to reach a logical conclusion before you bring something else up.
I'm just riffing, trying to figure out, because this is a fresh topic in my head. I haven't thought about it in ages. But what about the magnetic field of the Earth?
Don't need to explain it, dude. Can't tell you anyway.
Wait, what?
I don't know the answer to that question. What causes the magnetic field of the Earth?
Go on.
That's it. That's the answer. I don't know.
Oh, but
even the globe side's quite confused. Even the globe side, the mainstream scientists are quite confused about the magnetic field. I was listening to a NOAA scientist the other day, and he said we have absolutely no idea how it really works, and we can't even predict what it's going to be doing, even just 12 months from now. We have no idea.
Oh yeah,
it's an
I know they can't predict.
So.
They can't predict like when it's going to swap polarities, but it does exist. Like so there is magnetic field, like when you go to like when you go to Australia, things act differently.
Dude, compasses follow the field lines. Awesome.
Yeah, so stuff like that. So if you're to say the Earth's flat, then you're basically changing science. But
we still have the observed phenomena of compasses following magnetic field lines, but they do this on a measured flat surface.
So how is there a magnetic field on a flat plane?
Dude, I don't need to explain the cause of the phenomena. We just witnessed the phenomena.
So that isn't that just saying that you don't know and you can't explain it?
I said that right at the beginning. Thanks for catching up. Yep, don't know. But we have the phenomena. Just because we can't explain the cause of the phenomena doesn't mean that we're going to deny. Why are you going to talk for me, though, dude? I want you to understand. That's why I'm talking to you.
Magnetic fields. I'm just. So you're saying the globe Earthers can't explain it? That's what I'm confused about.
Yes. Tell me what produces the magnetic field of the Earth.
Produces magnetic field.
You can Google it, dude. Come on.
Oh my gosh. Well, I'm just doing some research. I mean, I don't know.
On the fly.
It says it's produced by geodynamo process in its outer core. Churning molten iron and nickel generate powerful electrical currents.
So I appreciate
so they do know.
Temperature of the core of the Earth, please.
Temperature of core of Earth. It says 6,000 degrees Celsius. 10,000 Fahrenheit.
And what's it made of?
What's Earth? Oh, it already says solid iron nickel.
Okay, so solid iron and nickel that's molten because it's at an extreme temperature.
Yeah.
What happens to metal at extreme temperatures with regards to magnetic fields?
So hot.
Let's say you've got a piece of steel that you've magnetized and it's at room temperature, right? And things keep sticking to it.
Magnetized,
now, say put it in a furnace and you increase the temperature to say 2,000 degrees.
Mm-hmm.
Are you still going to be able to stick things to it?
I don't know.
No.
I haven't thought about that.
Above a certain temperature, magnetism is lost with metal. For example, like iron or nickel. When iron or nickel reach what's called the Curie temperature, they lose the ability to have a magnetic field because they're not coherent anymore.
Does the Earth's core have a magnetic?
My friend, please at least look. Like, come on. When you Google that the center of the Earth is molten liquid metal of iron and nickel and whatever, producing a magnetic field, you have to understand that's contradictory.
Well, yeah, I get what you're getting at. No, I'm just is that what they're saying? Are they saying the core is magnetic, and it's saying the Earth's core is magnetic?
They're saying that the core is magnetic. We're trying to explain what produces the magnetic field. I asked you what did that, and already we're in the center of the Earth.
Geodynamo.
Apparently, according to the model, the guy's going to talk for me. That's what causes it.
It says the geodynamo causes it, which is not the core. The core doesn't cause a magnetism.
So not the center of the Earth.
No, apparently it's so whatever geodynamo is, it's driven by the turbulent convective motion of iron in the outer core. So it's saying how the core is moving around, which creates a magnetic field, converting the kinetic energy of conducting fluid into magnetic energy.
Damn.
But that's the thing, like, how do you disprove this? I just don't know. It's like, I mean, we've got all these models.
Think about it on the flip side, how do you prove it in the first place? Considering we've not dug any further down than 7.8 miles, so anything beyond that is pure speculation.
Is it? Right. So we've only dug down 7 miles.
Yeah.
So we can't figure out. So what are you saying? Are you asking, like, how do we know what's down there?
Yeah.
So has anyone searched this up? Because I feel like that's a claim. Like, I feel like to make a claim, you have to kind of at least search it up and see what
you have to back the claim up with evidence, and that's why the question is.
So how do they know what's in the Earth's core? Oh yeah. It says analyzing seismic waves from earthquakes. Jesus. How does that even... Seismology. They study the P waves that can pass through liquids, and S waves cannot pass through liquids. Researchers determined the outer core is liquid and the inner core is solid. Oh, I suppose that's based on how the waves... So if you have like an earthquake in one country, and the other side of the world, you'll be able to see the you'll be able to see the seismic waves. But if you go directly over the center of the Earth, you won't. Meaning that they think it's solid in the middle. I think that's what it's
waves
saying.
Pass through different structure differently. So a wave will pass through a rock differently than it will pass through a liquid differently. So although they've got actually no way of actually knowing, what they can do is suggest because of, let's say, the echo that they receive.
Yeah.
But they've got actually no way of knowing because they can't verify.
So, but if that's all the evidence we have, then how can you make the claim otherwise? Do you know what I'm saying?
Our claim otherwise is we don't know, and our claim otherwise is the surface of the Earth is measured to be horizontal. So when you bring up core of the Earth, that would be begging the question that the Earth is a sphere. We would measure the curvature on the surface. We don't. We have to approach this from what we empirically measure.
So did they just make all this stuff up?
Measure a horizontal plane, so there's no core.
So they just made all this stuff up? You think this, like, because these guys obviously measured seismic waves and whatnot. So you're saying they just made it all up?
They just have a model that they apply it to.
Right, but how can you have a flat plane, but then detect a seismic wave only? Do you get what I'm saying?
Reflection.
How do you know that they're actually doing it on a sphere?
Well, because if you're
going through the center of the Earth,
that's what they said. They can't detect.
They didn't. They didn't
because it's solid in the middle.
Seismic waves going through the center of the Earth.
Well, they didn't
detect them coming from about 5 miles down or something like that.
No, they would detect them.
The epicenter
slightly to the side of the center. So.
No, they never measured seismic waves coming
America
from
and Russia.
like thousands of miles beneath the surface. That's bullshit.
Beneath the surface? No, I mean like the other side.
The other side of what?
The Earth. So like you could measure
the Earth.
No, so I mean like if you were in America, you could measure an earthquake in Mexico, or like if you're in America, you could probably measure a seismic wave in Africa. Or in Africa, yeah. Well, yeah. What about Africa? Can you? How about this? Yeah, go on.
Tom, check it out. Does the ability to measure vibrations necessitate a ball? In other words, does it have to be a ball in order to measure vibrations? No, it doesn't. And I'll tell you why. You've seen the movie.
I'll tell you why.
yeah, I'll tell you why. I said it first. Hold on. You've seen the movie Jurassic Park, where at the start they set the shock off to test vibrations. None of that necessitates a ball, mate. You set off a pulse and you measure the vibrations.
Some places you don't get seismic waves.
Nowhere necessitates there's a ball or a curved surface required to do that test. Do you need the requirement of a curved surface to do the test? Yes or no?
Do you need? Does it need to be curved to detect seismic wave? Of course not.
No. Well, there you go. So here's you telling us it's a necessity, you've just answered the question yourself.
There's a curveball. And that's some places they don't detect
You've answered the question yourself. There's no necessity for a ball.
No, I'm throwing a curveball here. I'm throwing a curveball. It's not a curveball.
Oh, okay, never mind. Reflections on the flat surface also.
Oh, so you're saying you can, and he's saying you can't. So you guys have a disagreement here.
What we're pointing out, it's not exclusive.
So seismic waves, some places you can't detect them going through the earth, some places you can. Wouldn't that mean that there's something blocking it?
Means it's an invalid test to use that for anything. How do you like that?
An invalid, I don't know what that means, but all right.
Like I said right at the beginning, it all depends what model you attribute your measurements to. This isn't exclusive to a sphere. The measurements of PNS waves. Right?
Oh yeah, I mean, this is complicated.
PNS waves. That's awesome. But at the end of the day, if you want to figure out if the Earth is a planet or not, you measure the surface to see if it has curvature.
Sure. Well, okay, let's go from seismic waves because I think we're all out of our depth. Yeah, I'm definitely out of my depth. I don't even understand it.
That'll actually prove if it's a sphere or not.
So what about like the more obvious stuff? How you're on like a cruise ship, stuff disappear. Like what's that about? How it like if you look at seeing mountains in the distance, you just start to see it sinking. So how would that be explained?
Perspective.
Well, what's the radius of the Earth first?
What'd you say, sorry?
What's the radius of the Earth?
I don't know.
Okay, well, you need to know that because if you don't, what you're going to do is you're going to take your height and then you're going to find the distance to the horizon and then you'll use that to help you in your calculations to identify the radius. Thank you for burping.
All right. Well, yeah, I know that's how you calculate. Well,
okay.
You're not flat earth, are you? That sounds like a globe earth thing to say.
No. Well, yeah, it would be.
Are you a glober?
That's how you're going to measure the Earth to be a sphere, right? You can't dig the diameter of the Earth, so you can't identify the radius value that way.
So what causes
on that circumference so that you can actually get a radius value because you can't dig the diameter. We just
okay. So what causes the visual effect of seeing stuff in the distance disappearing from bottom up when you're on a cruise ship?
Why are you going to visual effects instead of focusing on, hey, what's the radius value? Which is what you need anyway.
Why are you talking about the radius? I don't know why you're talking about maths. Like, what causes it? I don't get it.
The math, because that's what specifically is required for the Earth to be a sphere. They're claiming a radius value. They're claiming something has to be this way, and the entire model is built upon it. Right? Okay. So you need to identify the radius value.
What? I'm not talking. What the fuck are you talking about, bro? Did you even hear what I said? What? Like, can you not just apply it to what I said?
Of the ball, dude. Come on, dude.
Yeah, I don't. That's not what I was talking about. I don't get why you're saying this.
Okay, because we've got a bunch of observations that we can show you, and based on the height and the distance to the horizon, we'll give you a bunch of different radius values. Right? Like a 7-inch observer. Yeah, if a person is 7 inches above the water and they see the horizon at 9 miles away, That makes the radius value 366,000 miles, right? If you're at 1 foot observation height and the horizon's 10 miles away from you, that makes the radius 260,000 miles in radius. If you're at 3.5 feet,
He doesn't even know what a radius is, and you're just going to keep yelling radiuses at him.
Well, I know what radius is. I just don't know. I haven't seen the maths. Like, I can't really calculate this in my head. But like, I don't get what you're saying. Like, how does that mean that it looks like things are sinking? Like, you've been on a cruise ship, like a boat. Have you been on a boat? Has anyone here been on a boat? So you've seen the effect, right? You know what I'm talking about.
You know what I'm trying to get?
No, I sat in a casino. I didn't watch boats sail away.
Okay, but does anyone like? Does anyone? Because are you saying that I didn't see what I see? I don't get it.
Tom,
yeah, you didn't see what you saw.
I didn't see what I saw. All right. Does anyone agree? Does anyone think I'm lying? Like, are you saying that I didn't see what I saw? Like, I'm sure there's videos.
Probably not.
I think you're red herring away from the point.
There isn't. You haven't said a point. You just keep saying maths. You're saying stuff like if you're 200,000 miles away and you're 7 foot.
I posted
you're just
a boat
saying
for you to look at. I posted a boat for you.
So Jimmy's talking about elimination of a potential reason.
Well, yeah. Well, what are you showing? Well, yeah, it's sinking.
Here, do you mind if I give?
So how do you? Yes, exactly. So how do you explain that?
Tom. So
hello.
Remember the question you asked earlier? You said, "What else would be the cause of bottom-up obstruction?" Remember that?
Right. Yeah, that's what I was asking.
So, if we're able to show you that there's bottom-up obstruction that's able to happen over a known horizontal surface, a known level surface, where you can have bottom-up obstruction, even for something that's only 100 feet away.
Okay.
Then you could say that bottom-up obstruction is not exclusively caused by curvature, by Earth.
So what else can it be caused by? That's kind of what I'm asking.
Well, if it's an optical effect.
Optical effect.
Yeah.
But so at what point? So how many miles away then?
Okay, Tom. Let's go through this step by step. Your eyes have an optical limit. You can only see so far.
Like a render distance in Minecraft.
Exactly. That's exactly what it is.
Right.
Okay.
So what causes that?
The angle, so we're going to go through it. When you're looking at an object, for example, your ship at sea, you have 3 lines of vision. Number 1, where the ship connects to the water. Number 2, your horizontal eye line. And number 3, the top of the ship.
Yeah.
Each one of those segments creates 2 triangles. Now, from your eye line to the water line, where the ship touches the water, creates a very small angle. From your eye line to the top of the ship, creates a larger angle. Now, as the ship sails away, due to perspective, it appears to get smaller. And those angles get smaller and smaller and smaller. Now, once that angle gets to 0.02 or less, you cannot resolve or render the image.
Hold on a second.
Right, but on a flat plane, the angle would still be straight. It doesn't matter how far away you are.
Okay,
still looking straight forwards.
I want you to do a basic experiment at home. Grab an item and look how big it is. Hold it in front of you and go,
it's massive.
It's massive. So the angle is big. Now go and put it far away. The angle is small.
Right, dead in the center. Or whatever.
The angle from the top of the item to the bottom of the item. Use a tennis ball or a basketball.
So if you walk away from a tennis ball, it just shrinks, right? It gets smaller and smaller.
Due to perspective. So
right.
Due to perspective,
but it doesn't get
the angle
go down.
From due to perspective, the angle gets smaller. So the problem you've got, Tom, is from your eye line to the water line being a smaller angle than the eye line to the top of the ship. Will disappear first. So if it disappears first, what do you think the ship looks like it's doing?
Oh, are you saying, so as you're getting further away...
Or the ship gets further away?
But the angle's the same, because if we're talking about a flat plane...
If you get further away, the angle will decrease.
Why?
Yeah.
Because you're further away from it.
That's how it works, bro. Like, look.
You're saying the angle decreases, so it starts going down. Doesn't that just mean it goes around a curve?
Okay.
What are you saying?
Your eye line is the center line of everything.
Sure.
Anything above your eye line will converge downwards due to perspective. Anything below your eye line will converge upwards. Anything on the left-hand side will converge towards the right, and on the right towards the left.
I'm not really sure what you're saying there.
Here, I got you. Tom.
Anything below would converge up? The fuck?
Just think about it this simply. It's very simple, okay? If I have an angle from my knees to the ground versus my eyes to the ground, okay? Which angle is bigger? What has more of an...
Right, but we're talking about straight ahead. We're not talking about angles.
No, I'm just saying if you have an angle from someone's eyesight, right? From their eyes to the object, okay? Now, do you think that that angle is going to be smaller or bigger?
There's no angle because we're talking about straight ahead. There's no angle.
Oh, there are
I get what you're saying.
There's
but
an angle.
No, because I'm talking. What if there's one that's straight ahead?
Tom, you're hearing, but you're not listening, bro. Look in the side chat. I just posted. Yeah, no. You asked me for the description. Look in the side chat. The word perspective. See how it appears to get smaller?
Oh,
yeah, above that.
Right.
See how it gets smaller as it appears to get further as it gets further away? That's exactly
walls,
what your ship is doing.
Those walls are angled. That's not an eye line. That wall's above the perspective.
Sorry, dude.
What?
That wall is taller than the
ceiling.
eye.
The ceiling that's above the eye line. Now you'll notice that the ceiling with distance appears to get closer to the floor. It's not actually getting closer to the floor, is it?
I'm going to draw something because I wanted to show my screen, but I can't.
This is why I don't interrupt, because I'm trying to explain something to you and you just don't give a shit.
Well, you
Are you
guys
here to listen and learn, bro? Or are you just going to keep talking through every answer?
He's a troll. You can hear what he's doing.
I'm literally not trolling. I'm just
You
confused.
actually are trolling.
All right, mate. So I want to send something. So imagine this can be whatever distance, right? So how does this... Let me send this. Why won't it copy? Fuck. So we're talking about a straight plane, no angles. So oh my god, wait, can I not send images? I can't send images, fuck's sake. Right, so we have a straight line. So we have a straight line being the Earth. So are we in agreement so that the Earth is flat? Straight.
Yes.
Straight, perfectly straight.
Yes.
So can you have things that are straight? If you were to hold a straight ruler out and it would touch the other side of the world? Is that possible? Can you just make something really straight from one end of the world to the other?
In a hypothetical situation, all parallel lines will be parallel to the plane of the Earth. Sorry, all horizontal lines will be parallel to the plane of the Earth. Yeah, okay.
Yeah, so... What the fuck is that? So we got a straight line.
Mm-hmm.
And it doesn't change angle, which we're agreeing that's possible, right? You can have a straight line.
A straight line doesn't change angle. Yeah, you observe a straight line by standing on it.
No, it's not about observation. I mean, it's physically straight, right?
Yes. What? When we're looking at the physically straight line, is that the surface of the Earth?
Can you see the other end? Can you see the other end of the Earth?
No.
But it's a straight line.
Yes.
There's no angle.
There's nothing in the way. Right. This is why we keep trying to point out to you perspective, because things get smaller the further they get away, don't they?
You can do this on a game. You can prove there's no angle.
It's like I say something. I need you to respond what has been said to you.
I don't really know what you said. What did you even say?
Yeah, okay. You know things appear to get smaller with distance, like that mountain is actually big.
Yeah, it's smaller, but they don't go down.
Right, dude. When it looks smaller, that's because the top of it has apparently gone downwards. The angular size has reduced. The top of it looks like it's going down. Doesn't mean it's actually going down. That's due to perspective. We've been trying to spin around this for fucking
all you're saying. So all you're saying is it's
trying to talk through me.
You're just saying it's perspective. That's what you're saying, right? So you're just saying perspective.
Well, at the moment, my friend,
am I wrong or right?
We're talking about observation. So we better understand how the human eye works.
Right, so
it's like, fuck
perspective,
me, dude.
Well, just give me the facts. What causes it? Is it perspective? It's perspective, right?
What? What
So it's
causes
observation
what? The object to appear to go downwards? Yeah, like the ceiling appear to get closer to the floor.
So you're saying it's perspective. That's if you could summarize in one word, it's perspective.
Yeah.
Right. So which one makes more sense? Perspective or object shape? Or just like the direction, it's like it's going down. Doesn't that make more sense? Yeah, like
no,
the
dude,
Earth.
at the moment, if
being a
you're making an observation, you must think about the observation first, like the eye, before you start talking about the surface it's going to be able to perceive or not. Now, if you're talking about horizontal, shut up, dude. If you're talking about a horizontal plane, we don't care about the distance. Let's say it's thousands of miles. Due to the limitation of the human eye, you, if you're 6 foot above that surface, are only going to be able to perceive about 3 miles in front of you of that surface. The reason why is because with distance, the angles of that surface become too small for you to see. Imagine you're standing on a giant chessboard. You understand the reasons why the squares in the distance you can't resolve is because the angles are too small. The black and the white squares appear to converge. So much so that with distance, the angle is too small for you to resolve the surface. That's what's going to cause your optical horizon, the limitation of your view across that surface based on the optical resolution of the human eye. If you want to get a camera out, a high-powered zoom camera, you could probably resolve more of that surface. It's definitely going to be optical.
Can we slow this down? Because I can't follow all these facts at once. I think we need to take it one at a time. So was the one that you said at the end, just before you said about the camera? You were saying... Can you remember what you said just before the camera bit? Because I was going to respond. I was thinking a response, and then you said cameras, and I just started thinking about cameras.
Hey Jedi, I think this guy's more of a visual learner. It seems. Are you a visual learner, Tom?
I think most. I think most people are, to be honest.
Okay,
but
I tagged you in the video. I just want you to take this into consideration so you understand the things that we're explaining to you. Okay, so just so you can actually see it. I'm posting it in the side chat.
Yeah, okay. RC Battleship sails into Horizon.
Right. So it's basically a scaled down experiment, right? Not even experiment, just scaled down observation, right? So she's on a body of water, a lake. We know it to be level, okay?
It's getting further away and sinking.
And it's the same effect we would see if we were looking at boats into the horizon.
I think that can be well, we can't really see. Wait,
do you understand?
Like before?
Do you understand the point of this though? Is that bottom up obstruction is not exclusively caused by the surface.
So I'm just trying to watch the video. I'm just trying to see where she's putting the camera, what the angle is, and all that.
Oh, it's tiny.
Is it in the water? Because I'm just thinking, if the angle's above, would it appear to sink? Or the angle would have to be below, wouldn't it? The angle of the camera. What is going on here? Is it hiding behind the waves? Does the ripples compound? And if so, and if this is true, then why does it happen at long distances? So why does it? So what? So why is it happening at short? Why is it happening at a short distance?
That's a good question. Maybe because bottom-up obstruction is not caused by Earth curve exclusively.
But it's caused by, in this case, what's it caused by?
The limitation of the optic.
Yeah, it's an optical
The limitation
effect,
of the optic.
Every single optical device, your eye, a camera, a telescope, binoculars, all have an optical limit. It's to do with the size of the lens versus the distance you're trying to look. Yeah, resolution limit. And it's to do with that same angle. So it doesn't matter how big that lens is. Once you get down to 0.02, that particular optic cannot resolve the image.
So if we took that same camera, would this happen only with the RC boat? Like, do you see what I'm saying? How if you're saying this camera has an optical limit of how was this 0.2 miles? So if this has an optical limit of 0.2 miles, you're saying if you got like a blade of grass or a tennis ball or something and move it away 0.2 miles away on this specific camera, it will start to sink around 0.2 miles. Because that's what we're seeing with this boat.
Camera. Why are you ignoring?
But that's what he said. It's about the optical.
It's to do with the size of the objects. You've got a larger object now, so a larger viewing angle.
So it is about. It will get
further away. So because your tennis ball is bigger than that toy ship, it will get further away before it becomes unresolvable.
So we'll just agree on that for the sake of it. So let's say there is an optical limitation. So
if you agree to that, then where is the
what causes
curvature?
Well, okay, let's just agree to optical limitations. So what causes the optical limitation? Does anyone know?
The optical limitation is the
optical
answer.
limitation. Yeah, the optical limitation causes it, idiot. Fuck nut.
Wait, sorry, what?
The size of the object, the distance to the object, and the angle that is received at distance. Now, we could talk about really, really big things, but if we're going to be talking about long distance observation, you better start taking the air that we breathe into account.
Yeah. There's things called air turbulence, right? There's a bunch of air.
Air turbulence, I've heard that before. That's what I was expecting, because that makes sense. Well, that would be understandable.
Hold on. Check it out. There's a lot of stuff in between you, the observer, and your target that you're looking at, okay? How come when Globers say, oh, well, that's because of Earth curvature, they never actually differentiate between the limits of our eyes or the optical device that they're using versus what the ground is actually doing. So how can we make an exclusive claim like they have about what the ground is doing without actually substantiating it? That's the point.
Right.
Not just
well, I can't believe this guy actually.
Refraction.
So I'm just sorry. I got distracted by these guys just saying I'm a troll. It's crazy.
Well, I mean, it's not about.
Like, how am I trolling?
Maybe you're not trolling. Maybe you're really trying to understand.
I'm literally not trolling.
Maybe you're really stupid. Maybe you're really stupid then.
Well, yeah, maybe I am. Stupid. But that's different to trolling.
Really, really stupid. So this is too advanced for you then.
Well, maybe it is, but I'm not trolling.
You are trolling, and you're trying to get out of it.
Can we mute this guy? Because he's just shouting.
One other thing.
No, Tom, let T-Dub talk to you.
Regarding your question. Tom,
yeah, go on.
There's one other thing that needs to be pointed out regarding your question about bottom-up obstruction with distance.
Sorry, you're a bit quiet. I got you at 200%.
Yeah, so there's one other important factor involved in what you're talking about, right, with bottom-up obstruction. Your own side gives an alternative to that doesn't involve physical obstruction of view.
Your own side.
And it's called sinking refraction. So even though the eye has a direct line of sight to every part of the object in the distance, it appears like it's below the horizon. And it's called sinking refraction.
Sinking refraction.
Yeah. And can you please stop burping in your mic?
Sorry, mate. I'm going to search sinking refraction.
Told ya. It's not that. I mean, I hear it the whole time. You guys are somehow don't hear that he's just trolling you guys.
So sinking is an atmospheric refraction phenomenon where objects such as ships appear lower than their actual position due to light rays bending upwards.
I've seen
it occurs when air density decreases the height at lower than normal rate.
I've seen some of the biggest trolls, though.
So shut up. So sinking refraction is an actual thing. That's what I think that's what it's saying. It's not a flat Earth thing.
It doesn't have to be.
It's based on what we observe.
Right. So sinking refraction is a real thing.
It's not exclusive to any shape of surface. Okay.
Yeah. Right. So it doesn't seem to say. It's not saying that causes a flat Earth. Like this isn't a flat Earth thing.
No, we're not looking for cause of flat Earth here, dude.
Right.
We're just trying to explain why on a flat Earth things appear to disappear from the bottom up.
So you're saying it's all sinking refraction?
Within this description of sinking refraction, there is a direct line of sight between the observer and the object. Right? There is nothing in the way, no Earth curvature. It looks like it's sinking. Right? You can't see the bottom of the boat. It looks like it's sinking into the horizon. This is caused by the path of light being deviated by the air conditions. So it's right in front of you, but the air is deviating the light, making it look in a certain way. Now, conversely, if the weather conditions are different, it would look different. For example, it might appear to be looming. The top part might appear to be stretched. Do you understand?
The top part might be stretched, yeah.
Yeah, the opposite of sinking would be looming.
Yeah.
Correct.
We might have some kind of mirage, right? A mirroring effect underneath the boat. we might have what appears to be an optical horizon, but not a true horizon, because the surface of the water is really, really reflective. So a boat at distance might look like it's flying in the sky. If you were to change the resolution of the camera, you'll see that there is a surface underneath it. The boat is clearly on the water.
Does it make it look like it's sinking as well? Because I can't seem to find that. I only see ones that make it higher up.
Well, that's looming. That's looming refraction.
Oh, so that's looming, right?
Sinking refraction is the bottom-up obstruction.
I see.
And we haven't discussed like the potential for swirls or waves at distance that you can't perceive against the background of the rest of the water.
It's surprisingly more of a complicated topic than people think, because you go into it just thinking, oh yeah, these people are all just stupid, but really, I mean, this is like a lot of stuff to learn. It's like a whole fucking subject, like fucking hell. I'm just looking at it all like, oh my, I can't even compute half of this stuff.
Dude, I've been in this topic for 5 years. I've learned more from debating this topic than I have in any of the years that I went to school. So, just so you know.
So, have you ever spoken to someone who's keyed up, but like the other way?
Yeah, absolutely. And they all make. There's not been one globe evidence, not one globe proof that doesn't affirm the consequence. Not one.
Right.
They have built-in presumptions in any of their claims, like all of their claims. Yeah. Yeah. The first one, the biggest one, being the radius value. How have they established the radius value? And the only thing that you can go back to is Eratosthenes. And then if you go to Eratosthenes, it's not even been established. It was two presumptions that Eratosthenes made, which was one, that light rays coming from the sun parallel to Earth, and two, that that basically because there was an angle observed from one part of the world versus another part of the world that was 500 miles away, he basically made a calculative assumption that, okay, well, this angle is 7.2 degrees deviated from the zenith, right? Not to say how the hell he established that in the first place, but let's just grant him that for a second, okay? Then that's just that's basically just the mathematical entailments of a circle, right? 360 degrees in a circle, and he basically assumed that, okay, 7.2 degrees of the circle, you times that by 500 miles, and then that's how you got the circumference, 24,901, et cetera, et cetera.
Right.
And this is the story we're all told. It's just a story.
Well, can you read? So I'm trying to find one. So what about this? This is what ChatGPT is giving me. Forgive me for using ChatGPT, but like, it's saying about satellite orbits.
What about it?
So the calculation for satellite orbits is saying it uses the balance between gravity and centripetal force, and the calculation is, I mean, you can't even type it. It's complicated.
You see an R value in there?
And it's saying an R value, what, the distance from Earth center?
Do you see anything? Do you see an
value
in there?
Yeah, there is a rate. Well, the R is distance from Earth center.
Right. So if we disprove the R value, then that means nothing.
Let me see what it says to that. So what if the R value is disproven? If the R value is disproved, the predictions would stop matching reality. If R were wrong, the calculated orbital speed would be wrong. Satellites would either fall back to Earth.
No. If the R value is proven wrong, then everything matches reality.
Right, but it's saying if it was wrong, then satellites wouldn't work.
Because you use the public version of ChatGPT. You use the special person version. Yeah, they just give you the unpaid commercial version that everybody can use.
So you're saying that they're lying? So is that what you have to resort to? Because if that's what we have to resort to, we can say that.
Anybody that tells you that the Earth is a ball is lying to you. Yep.
So we have to resort to that. Is that if that's the final conclusion?
No.
Can anyone else speak against that? Yeah.
No, that's not the final. The Earth is measured to be flat. Therefore, they have to be lying, or in some way that can't be true. Because
Right,
the
so-
empirical evidence suggests that the surface of the Earth is measured flat.
So they have to be lying.
Or just repeating information that they got told and they believe, like your teacher, right?
Right.
Repeating a lie. Same thing as lying.
So we're resorting to not believing. So essentially, this stems from distrust in the authorities in the government.
No,
and,
you don't believe in anything, dude. You don't
Because
believe.
I can get behind that. Like I understand how we only know what we get told. Like I understand that. We only know what we get told, right?
It's like I'm trying to help you because you keep wandering off. No, it's based on empirical evidence. The surface of the Earth is measured flat. It doesn't come from distrust. It shows that we shouldn't trust because of the empirical information.
The
surface of the Earth is measured to be flat. Now, let's put it like into say like a crime scene, for example. We discover a dead body. The body is definitely dead, but we can't understand the motive. Just because we can't understand the motive isn't going to change the body from being dead. Now, we measured the surface of the Earth to be flat. Anything other than this, satellites, eclipses, all of this stuff, isn't going to change the Earth being measured flat.
Mate, I'm pretty sure this comes from a distrust because...
No, it's not possible because the people who distrust government is like 98%. They just did a poll like last week. They say the only...
I spoke to you before. You said that ages ago. It was just you in the call. I remember you actually.
Yeah. So
that's very funny.
Supposition there that this could only come from a distrust of government
not only
match the data.
Also, I think from a lot of echo chambers.
Only distrust of government, you would have a large population of flat earthers. Large.
I think this is
when did you hear us talk about distrusting the government anyway?
Yeah,
because you said the final result was that they were lying about satellites
they are lying.
Falling.
What does that have to do with distrusting the government?
Well, because they're the ones that are telling you it. NASA.
NASA told you that.
That's what I said. NASA, government, is the same thing.
What's the step before we got to the distrust? What did we do before
we were talking about satellite calculations and scientists using calculations.
Before that.
So if the R value was false, then satellites would fall to the Earth, and you're saying that's not true. So I don't really know what to say there.
Calculations and the Google response.
Dude,
what we're saying to you is...
Well, no, this is not a Google response. This is what scientists says. This is what scientists, like people who have made satellites, right? Like people who make rockets.
No, dude.
No?
Stop it.
It's hard to converse with you when all you do is talk.
Yeah, you got to shut the fuck up, dude.
Well, how about we just
take turns? Just shut the fuck up when other people are talking. How about that?
Well, I've listened a massive portion. I don't think that's fair to say that.
He said.
Right, so now you guys are just being tribal, so that's nice.
You just relax.
Yeah, you're all. There's a few people getting mad here.
Just want to explain this.
It
doesn't come. Flat Earth doesn't come from a distrusting government or science or whatever authority you want to come from.
It doesn't.
Our position comes from the measurement of the surface of the Earth. We understand that there are consequences to this position, that we say that when we measure the surface of the Earth, it measures to be flat, which is contradictory to the narrative. But it's not our position to start speaking about people's motives, why they would lie, how they've lied, blah, blah, blah. It's not going to change the murder taking place. The Earth is measured flat.
The Earth is measured flat. Okay, so you keep saying this. Can you? What are you talking about? The Earth is measured flat.
Okay, so for example, you understand what surveying is? You are surveying, right?
Surveying.
Yeah, you understand what that is. Measuring the Earth. For example, we do this before we build houses. Yeah.
Right. So for example, you build houses.
So we're talking about surveying the land with tools.
Surveying the land.
Right, so for example, theodolites, lasers, line of sight, these types of things. So when we measure on the surface of the Earth flat over distances that should have curvature if the ball was at the radius value that we're given. we physically measure with tools the surface of the Earth to be flat. Yeah.
Are you saying someone's done that? Is that what you're saying?
We all. Okay, so we all do that. You even
we
do
all
that.
do that. I do that.
Have you ever put shelves up?
No, because that can be explained by global Earth as well, right?
Okay,
that doesn't mean global Earth can't be true.
So the basic principle of level is, like you said, is to be perpendicular down or parallel with the plane of the horizon. You know that we use water as a leveling tool, right? Have done for centuries, millennia. It's a leveling tool. Levels a straight line from left to right.
Yeah.
Right? Cool. So to be level with the world when your shelves are level, you're going to be using a measuring standard. It might even be like a level with a bubble in it.
Right.
Now, this is what I mean about we all do this. We all work upon this principle of perpendicular to vertical, horizontal. Now, we can expand this out to what surveyors do, what we do practically on the surface of the Earth when building bridges, dams, blah, blah, blah.
Right.
When we survey over distances with tools, we measure the surface of the Earth to be horizontal. That's where we get level from. To be level with the world means to be parallel with the plane of the horizon. The horizon is where the surface of the Earth, water, appears to meet the sky. So water's flat.
This seems like an incredibly long explanation just to say that perpendicular it's perpendicular, so it's flat. Like that's what you're saying. You're literally just saying it's flat because it's
perpendicular, because we measure it with.
Right. Well, that's not really an explanation, is it?
No, it's a description of what we measure.
That's just circular. That's just, isn't it? What's the thing when you define a word with the word itself?
I'm pointing out the methodology of how we measure over distances.
Right, but so okay, well this isn't getting anywhere. You just said it's flat because it's perpendicular. Like what the fuck?
No,
yeah, we measure stuff perpendicularly with a bubble.
Over distance, perpendicular is at a point on the Earth, like to vertical 90 degrees. Right, I'm talking about over the distance, 10, 20, 30 miles, you have a direct line of sight to a target with a laser leveling device, for example.
Yeah,
so
what about
the surface
lasers?
of the water will be parallel to the laser.
Yeah. So I meant to say parallel instead of perpendicular. So it's parallel because it's flat, and the bubble sight glasses, you can wobble it, and it's flat and parallel. And water levels, they're all flat.
Right,
I
so
get
that's
that.
a smaller.
That can be explained like. Yeah, go on.
That's a small example. Do you remember I expanded it out to 30 kilometers?
Sorry, you cut out.
I expanded it out to 30 kilometers.
30 kilometers, sure.
Yeah. We were talking about surveyors with tools, theodolites, lasers. You know the English Channel?
Sure, yeah.
Yeah, you know the Channel Tunnel?
Yeah.
You know we surveyed from coast to coast using lasers, electromagnetic, so on, standing on the coast of England and the coast of France, down in Folkestone and in France, surveying across the water to buoys and ships on that water. Yeah, so we surveyed the water. We do this all of the time. What I'm pointing out to you is when we do this, even if it's us flat earthers, or let's say the military of their laser targeting devices, we all measure the surface of the Earth to be horizontal.
So you're cutting out.
Right, if somebody else wants to take over, please do.
Yeah. Okay, so how about some
I'm
empirical
not really sure what you're saying, Yeah, that's what I'm looking for, yeah.
I got you right here. All right, so check this out. Have you ever heard of Lake Pontchartrain?
I have not.
Okay, so Lake Pontchartrain Bridge is something that Globers like to use all the time as like proof of curvature. They show this 27-mile long bridge, and they show that it basically looks like it's conforming to a ball. Well, one of our mutual friends, Taylor, she actually called up the state to get the as-built general bridge plans. I'm about to post them to you right here. Okay, 27-mile long bridge, right? And it's not using the WGS 84 because it wasn't there yet. It's not using anything like that. Okay, it's using mean low water level. Period.
Okay, this looks like a small bridge, right?
27-mile long bridge.
So, and what's the proposed circumference of the Earth? Oh, sorry, I know you went off by heart. I don't know either. And miles. So 27-mile long bridge. So it's 24,000 miles. What's 20?
He's not even listening to the information, is he?
It's saying. Oh, sorry. What the fuck? I'm shit at maths, bro. I just got a random number. So what? 27.
Ask yourself how many.
27 divided by 25,000.
No.
So that's 0.001% of the circumference.
Listen.
So how would? Why can't you use mean water level? No. I'm just responding to your point. So you're saying about mean water level, right?
I didn't even finish.
You're saying it was all on mean water level, and that means.
The point is, if you have 27 miles between the first end of the bridge versus the last end of the bridge, the entire bridge, how much curvature should you expect, right? What should be the bulge between each side of the bridge? Because there would have to be curvature if we're on a ball.
Well, yeah, but I don't know what the how many miles. I don't think that's far enough. I'm pretty sure it's.
There would be a vertical drop of 486 feet.
Whoa, really?
How come you're not asking ChatGPT for the answer,
Mate,
dumbass?
Can you chill out? We're just having a conversation here. So, wait, there's actually 400 feet after two. Wait, because that is very interesting.
Miles, almost 500
27-mile elevation drop. Curvature, because that is very interesting.
Here,
if that's
type
true.
in ChatGPT. Type this.
Well, I got on Google AI. It's 480 feet.
Yeah.
Fucking hell! Wait, so if that's true, then
there's none. There's no.
So we'll have to take this. I'll have to properly read this then, because if that's.
Or you can
that's a pretty interesting claim.
You can kind of keep looking.
Was this not an error?
No, it's not.
So can we see the bridge? Is the bridge been built?
I gave you the plans. Yes.
Yeah, and I'm looking at it now. Has the bridge been built?
Yes.
It has been built. What did you say it was called?
Lake Pontchartrain. I'll spell it for you.
Lake. Yeah, that's pretty. It came up.
Pontchartrain. Yeah.
Oh yeah, it's a fucking massive bridge.
Yeah.
What's the size of it? It is. Yeah, 25 miles long. Fucking hell.
Oh, 25. I apologize.
No, that's long, mate. That's a long bridge. How the fuck do they make that?
By treating the Earth as flat.
So, it measures about 40. Oh wait.
They made it.
Oh fuck! Wait, what? Holy fuck! 40 miles long?
No. That's just talking
about 40.
Lake.
It says. Oh. No, I'm a fucking retard. Yeah, 24 miles long. The world's longest bridge.
You know what I've heard? As a response to the actual as-built plans, specifically from an anti-flat earther named Jesse Path of Light. He said he moved the goalposts. Then he told me, he goes, well, mean willow water level, that means, you haven't proved that level isn't curved.
Yeah, I don't even know what that means. Yes, some people just say shit but I'm seeing that. I mean, that's pretty. That's the best evidence I've seen. But I'm gonna see if I can find what the counter argument is.
Just check this out. This is the entailment of Glober of someone that has to believe that they're on a ball after being presented this amount of evidence. There's way more.
This is the first interesting piece.
I
go
have
on.
way more, but this is what they say. They say everything is locally measured to be flat everywhere. That's number one. It's locally flat everywhere. You can look that up. Earth is locally flat. It's locally flat everywhere. Number two, level.
That's not
actually
true.
Means curved.
Okay, so what was the thing with this bridge then?
Bro.
All right. So they're saying with a. So were they saying? So the bridge would actually have to be curved then, right? Right? It'd have to be curved. But then how would you curve a bridge? Wait, is
exactly.
Curved?
An inertia navigation system itself for long distances, like 200 plus nautical miles, proves that it isn't measured on a flat surface.
Yeah, it says it does actually. It says while it appears straight to the eye, it follows the curvature of the Earth.
200 miles in a straight line.
Like when looking at aircraft avionics, especially like I said, INS, it's measured on a curvature.
Hold on. Wing.
No, it's not actually, Wing.
Hold on, just
Sorry,
wait.
can we
Hold
go
on
back to
one
the
second.
bridge? Yeah.
Let's go back to
This
the
bridge thing is
Tom,
interesting.
I want you to understand this. So what did
Right.
you just read? What did they say?
So it's saying that it does curve.
It's ridiculous, Tom.
All right. Anyway, yeah, get to the other guy. This guy over here is just fucking with you, and you guys keep
Oh
playing
my god,
into it.
bro! Can you
You're gonna
actually shut the
waste
fuck, Professor Triangle, bro? You actually
all night with this one.
Professor Triangle, shut the fuck up! Like you're actually being a dick, mate. I'm not even trolling. You're just a dick.
I think he's being sincere right now, dude. I don't know.
He's not being sincere right now. Why don't you hear that?
Triangle questions is a good way to find out about triangles.
That's right.
Oh, he's muted. Okay. Well, either way, Tom, just take into consideration what they define as level now. I'll even post this book.
All right, they'll mute me. I don't know why I'm supposed to be. Brilliant. Very mature, innit? Fucking hell. Whoever's got the mods, mate.
Just check it out, bro. I'm gonna post another thing for you.
Right. So we were midway through that, and it was getting interesting. So you said right. So we got there, and I said that the bridge is curved. Are you saying that it's not? And you just laughed. I don't get where you're going with that.
No, I thought you were understanding it with me.
That's
That
just
they say
Dipsy
it's
Dixit,
curving.
Tom.
Sorry,
That's just
Tito,
Dipsy
hold on.
Dixit, Tom. That's just Dipsy Dixit.
I don't know that.
That's just a bare declaration. That's just
right.
You saying no. The sky's green.
Wait, so you're saying it's not curved? Is that what you're saying? Is that what you're proposing?
Dude, your main problem is for you to be correct, it'd have to be curved at the same rate that the Earth is.
Sure.
And then be undetectable. Because if you and I can't detect that level of curvature, it would match straight and level.
That is a good point, because it should look curved. Well, should it look curved? Because obviously if it's following the same line as the shouldn't you should be able to see the end of it, right? If it's curved. You know what I'm saying?
Listen.
Like this is on your argument here.
Listen,
like
Lake
that would mean it's flat.
The reason why this is so significant in this debate is because it's been used to say, look at it following the curvature of Earth as in optically. Like you'll see people posting GIFs about it. Like if you type in Lake Pontchartrain on GIFs.
It says you can't see the end.
Hold on.
Not even from the middle.
This guy is hello, shut up. This guy is sea lining us. He's like the
I've been telling you that. Finally,
sea lining?
you're
Oh my
here.
Or he's the lowest IQ glober ever.
Okay, so can you tell me why? Can you tell me why?
He's just a troll.
No,
I'm not a glober. I'm not bro. I'm just here to learn because I don't even know.
You are a glober and you're a troll. I told you.
How am I trolling? Okay, in what sense am I trolling? Go ahead.
You're pretending to be dumb, right?
I'm pretending to be dumb, right? How am I being dumb? Tell me how I'm being dumb.
Scenario. Worst case scenario, you are actually dumb.
Okay, so tell me how I'm being dumb.
You're asking stupid questions. So the bridge
what stupid question?
Curving. It is actually curving.
Is the bridge actually curving? Right, so how's that a stupid question? So you're saying bridges can't be curved, and that makes me a troll.
I've waffle on for over an hour. I'm just a listener. I'm going to sit back, but I'm telling everybody else on the call, this guy is either...
Did you just say everyone's a troll? I know what it is. You're surprised because I'm not calling you guys idiots. I'm not throwing insults. I'm just being reasonable. And because of that, you guys think I'm trolling. You see, most people just come in and they think everyone's idiots. I'm actually here trying to understand people because I'm a rational person. And I like to understand different sides. But because of that, you're seeing you're like, what the fuck is going on here? This guy's being normal. He's actually like speaking to us. But you think,
bridge.
Do you get what I'm saying? Like, how does that make me a troll? I'm just being rational.
Last thing I want to show you, and then we can move on. All right. Last thing I want to show you. Okay. This is from a surveying book of engineers. All right. This is how they define level versus horizontal, and it's hilarious. All right, I'm going to read it real quick. So a level line or surface is defined as a line along which all points are of the same height. And then it says, because the Earth is curved, level lines are also curved. Consequently, when using an optical or digital level to determine height differences, measurements should be taken from curved level lines. Do you hear the wordplay in this? It's insane.
Yeah, so because the Earth is curved, level lines are also curved.
Yeah, then it says
as seen in figure 2.1.
Then it says, however, for most survey work, the difference between a horizontal line and a level line, called curvature, is small enough to be ignored, and it can be assumed that level and horizontal lines are the same.
Yeah, I mean, this makes sense.
All of that rigmarole just to keep the fact that the Earth is curved in their mind.
So Tom, basically, what's that's saying about your Pontchartrain Bridge is that, well, yes, level is a curved line, but we practically built it according to horizontal.
Yeah,
exactly.
Right, so there's no curvature taken into account.
At all.
Yeah, that is weird.
We got this far out with the bridge, and now we have to make this adjustment because the Earth's curving.
I think I can understand how that works.
So they didn't do that.
No, I think I can understand how that works. So imagine. Sorry, I'm starting with imagine. This doesn't sound convincing. But this build isn't built like one massive block at a time. It's built slowly. Do you get what I'm saying?
Okay,
so little bits and little bits. Yeah, so it'll start curving.
240 feet. There's supposed to be. So from one end. So if you got you on one end of the bridge and someone on the other end of the bridge,
you can't see them.
That bridge, there's a 240 hump of bridge between you and your friend.
That's a lot. Yeah, that is a lot.
But there isn't.
But there isn't.
No, there isn't.
Because water's level, bro.
Well, you see why I'm confused here, because you're not really saying. You're just saying that you're just denying it.
Hey Tom,
I think you might be the lowest IQ person I've ever met. Or you're trolling us. Which is it?
I'm looking for evidence. I'm not looking for denial.
Hey Tom, let me jump in real quick. Let me jump in real quick, okay? Because I'm an iron worker, a union iron worker, retired.
Oh, nice.
And we build bridges, right? We're the ones that do build bridges.
Oh shit!
So the longest one the longest one we built is 2.25 miles that I've been on. The project I've been on, no curvature accounted for. It's just horizontal. It's
that is what it says in the thing. That it says they don't account for curvature.
No, you don't. You build plumb level, and it's called plumb level square. So when we're building the beams and we're placing from column to column, we're making sure that they're staying at the same angle. So and that angle would be level, right, to where it's just flat. Right? So from just like Professor Triangle always tells people, you go triangle to triangle to triangle to triangle all the way down. And that means they're all now perpendicular. There's no curve involved with that because the baselines of triangles, they do not curve. You cannot curve a triangle. Then it's no longer a triangle.
So why are we speaking about triangles? I don't get it.
That's how surveying works. That's how surveying works.
Because that's how it works.
That's how you build shit so it doesn't fall down.
So when you have a 90-degree position, right, to one of the columns, we plumb it up, right? It's now sticking straight up vertically. We call that plumb. That creates a right side triangle, right? It's 90 degrees to one side and 90 degrees to the other. And then the next column down, it's also 9 degrees. And then you could connect a beam between it, and that will be level. Because now you build a square, a box. It's called box and fill. When we build shit, you just box and fill. And the point of that is, for 2.25 miles, no curvature was accounted for, and it was level from one side to the other, all the way down.
Yeah, I agree. That's what they did.
If you agree, then you're a flat earther.
How do you agree when you don't even know what we're talking about yet?
What you said is what they did. You just said they built it as if it was level, and that's what they did. They built it as if it was level.
What's level mean?
So, in horizontal to level is level. We all know what level is. Parallel to the earth. This guy, he's loving it.
Right. Yeah, parallel. You can't be parallel to a ball, so you're right. Parallel to the earth.
You can be parallel.
No, you cannot be parallel to a curve.
Right, but if you zoom in, if you
can
look
only
down,
be in an offset from a curve.
Yeah,
right, but you're forgetting how. So this is a key thing here. You're forgetting how big this ball is we're talking about and how small we are.
No, I'm not forgetting anything. You already said everything you said so far. You said the Earth is flat.
Right, it's so big you don't have to take curve into account.
Right. I got a question from like an aviation perspective. If I can jump in.
Wait, sorry. So you.
Tom, take a moment to digest all this.
Yeah, no, I'm just so. I'm saying we can be parallel, and you're saying you can't be parallel.
You're up, Wing.
Yeah, let's go, Wing. From aviation
here we
perspective.
So in the Air Force, and again, I'm going to say this real quick. I'm still neutral, of course, on things. I'm open. So don't attack me. So in the Air Force, we learn a lot about inertial navigation system, right? And our GPS fixes. And when we fly sorties or missions that are hitting a target, a nautical miles from where the aircraft first did its INS alignment, you are naturally going to get some drift in there. And I'm talking maybe 5, 10, 15, 20 feet, where a GPS fix may need to be redone closer to the target area to get the aircraft back exactly on coordinates, if that makes sense. Yeah. Now, the reason why we were taught that we have to do that is because the INS system is getting degraded due to the Earth being spherical. If it was on a flat,
you broke up.
You see your lat longs across the globe having some distortion there from the curvature. How do you guys explain that? And again, I'm neutral right now with this. I just want to hear your guys' feedback.
Let me say this. There's what you're doing is they're using a measurement, and then they're comparing it to this framework of a sphere. So all they're doing is just mathematically matching a model. But in reality, that we like come back to Earth, and then you know that the Earth isn't curving away from you. But that doesn't mean, because I could agree with you on that, but this is just a mathematical construct that's now being presented onto a framework of sphericity. That's all that is. It's just math.
I understand. I understand air data, inertial resonance, and INS systems. If you want to talk to me, you can.
That's how GPS works, yes, but INS is not just on.
Yeah, let Amish tell you. Let Amish tell you, because he understands it really good.
Okay, yeah, I'm familiar with commercial systems like the Boeing 777's Ataru and its strap down, gyroscopes and accelerometers. I'm also somewhat familiar with the information flow from initial alignment all the way through taking readings from the aircraft and pumping them through algorithms, in different ellipsoid and geoid references, and then calibrating it to latitude and longitude. So I'm familiar with some of this stuff, right?
Yeah.
So the INS has one job to do, and that's to communicate what your plane is doing such that it can put it somewhere on GPS system. And this helps with interoperability with other aircraft, with communications, with towers, and so on and so
I'm going to stop right there, though, because INS was built before GPS. The whole point of INS was prior to GPS systems. To keep that in mind.
It's all integrated, though. It's now all integrated.
Nowadays, but the military originally used INS because we had no GPS back in the 70s and 80s when I flew.
Okay.
We were dropping precision before GPS through INS with F-16.
Right, so that's why I bring this
up. That's more to our point.
Yeah, nothing to do with the ball, that's for sure.
Exactly.
But you guys were saying it's all math in the INS lining up with a made-up model. But the INS, prior to GPS, how did it know without gravitational forces on the gyroscopes?
Gravity.
Yeah, fly INS
so question for you is did the gyroscope ever drift?
INS over before GPS? If you fly INS over a pole, like the North Pole, for example, it gets all jacked up. I've seen that in person. So if it's just on this model, you guys are talking about,
not gravity, then got it.
I need to talk to people who are going to be good faith about this instead of just.
No, you said if you fly over the North Pole, then the gravity affects it, and that doesn't make sense to us.
Okay, that's fine then.
So we're using a mechanical INS then?
Correct, yeah. So back in the 70s, our Air Force aircraft, even like nowadays, B-52, for example, it has an old school INS system. Like they didn't update this shit so it's ECM proof. And I'm talking prior to GPS fixes. I understand what you're saying. Nowadays, commercial airliners, they can GPS fix off that. But prior to GPS, the whole INS system was developed, they still have some sort of precision flight plan for long flights. And I'm just asking you guys why you have that INS degradation over 200 plus nautical miles. And honestly, I always remember seeing this and question myself. It seemed like it would get degraded between 200 and like 10 to like 270 nautical miles every single time it would start degrading around that point. And I remember asking a navigator at one time why that is. It's always on the mark around that mileage, and he made it very clear it's because of the spherical Earth, the latitude and degradation.
So how did you account for that versus other issues like all the steaming issues that are done? You've got like drift, right? So you could have like right. So you've got drift heading from different wind directions, pushing and pulling and doing all kinds of things. You've also got some steaming errors, which can happen if you pull a maneuver, right? It's going to send the gyroscope spinning around.
No,
so these things used to have pendulous vanes and things like that.
Fly on a flat
little
plane,
weights, right? Connected to. All right, go ahead.
If you fly on a ferry flight, this is where I would experience this. You're not pulling maneuvers. You're just hitting the tanker every, couple hours. And it would always be degraded on the mark around 210, 215 nautical miles. Can you explain that?
Well, degrading relative to what?
I was about to say, yeah.
Usually around, it would degrade maybe a couple nautical miles relative to all sorts of references. I mean, we had bullseyes, we had AWACS give an updated fix, all sorts of ways that you can actually get an accurate coordinate when you're out in the Pacific.
So you're basically saying the Sagnac effect?
No,
I don't think he was using. No, he's using mechanical.
It's a mechanical issue, and if you look up how these old school INS systems were made, it's not just
mechanical
math.
drift.
It's not just a math issue. There's like an actual mechanical gyroscope.
These things always had to be recalibrated, constantly recalibrated for all kinds of.
And that's about the right distance too.
That's right. So, like these things at one point used to have pendulous vanes, which are basically like pendulums, little strings with weights on them that would pull downwards. Right.
Exactly.
Yeah. So these things weren't perfect, right? And and there's like the urban myth that that like a gyro compass, right, would align itself with the north if you left it alone and gave enough time to seek it. But this has never been able to be demonstrated, and it's always oscillating left and right and people like to nudge it and nudge it and nudge it because they already know which way north is until they kind of find north. But in modern systems, electronically, you have to actually punch in your latitude, which is funny because if these things automatically sought north, then you wouldn't have to do that in the first instance.
Exactly. You could derive your latitude from it automatically calibrating if that would be the case. But
yeah, every jet I jumped into, I just was curious about why is it always on the mark around that 210 nautical mile where it starts degrading from.
They all use similar gear.
Yeah, maybe it is just a manufacturer issue with the INS itself.
Well, it is.
Why would it be the same?
All use
critical
similar
question.
Principle gear.
Critical question. Why blame it on curvature of the Earth instead of Coriolis?
This is just how I was taught when I would question, because I used to question these guys all the time about this stuff, and that's how they answered it. Is the spherical model, and that's what causes degradation on target, basically.
Why isn't
it so there's going to be one correction that's done for the curvature of the Earth, which is called the transport rate. And this is your rate of rotation around like a spherical coordinate reference system like WGS-84. The rotation is such that the belly of the aircraft is always facing down towards the Earth on a globe, and not pointing gradually out into outer space as the airplane flies. So you have to have a transport rate that is calculated and is going to be in sync with your velocity, so your heading and speed. There's also going to be, in addition to that, a Coriolis correction. The Coriolis factor is way more egregious, especially as you get down towards the equatorial regions. And this is the claim, right? And the claim is that these modern systems compensate for all this, which we can't actually find any raw data evidence of.
But this is interesting because it's it's apparently before those systems existed. So
right. I'm talking back in the 70s before we get GPS.
Why not sooner? Why at that distance? Why not sooner?
Yes, and that right there is exactly what made me question more into this, because if it was a manufacturer problem, you would start seeing degradation at random times, at random mileage, And this was a big deal because, like, for mission planning, if we were hitting targets that were over 250 plus nautical miles, it was like a criteria every single mission for those targets to make sure we did a INS fix alignment prior to the IP and attacking a target for those missions.
Right, but you understand how much curvature there is over that distance, right?
Yes, I understand that.
like a hell of a lot.
And I mean, this even goes into our new stuff too, like our targeting pods. When you laze something across the horizon, the laze itself reveals that there might be curvature. Again, I'm open to the idea it's flat, but the laze itself, even shooting a laser across 30 nautical miles from like a sniper pod, it reveals that there's curvature.
That is?
Wait, what? Let's go there. Let's go there. Let's go to
this is what we're talking about.
I don't want to talk about that stuff today. I really don't. I'm just curious about.
We got an F-16 Wizzo who was able to I don't know how to phrase it. He was able to use his targeting pod and get a fix on the peak of the K2 mountain, which was directly in front of him. And he was like 80 miles away from it. And he did the calculation. He's like, there's no way I should even be seeing it, let alone from this distance actually be able to hit it.
Yeah, see, I've had experiences opposite of that, where it's like you don't see something that you're supposed to be lasing on a specific pre-plane coordinate until you are within a certain mileage due to the curvature.
Right, so. because an object that's straight ahead of you and a sufficient distance out would be like at 120,000 feet.
Sorry, due to the curvature.
I'm talking like smaller compounds or buildings. I was in the Middle East a lot, so that's what I'm. But like you have a pre-planned steer point, right, on a target. That's your target from IP. Even if you're like 300 miles away, you can select that steer point, and you can adjust and slew your TGP, right, precision onto that steer point. And if it is behind the curvature of the Earth, so to speak, and you're flying lower, you will not be able to get a good laze on that target on the horizon until a certain mileage.
So that would be your physical horizon then, right?
Yeah, and I mean, I'm talking across desert and stuff. There could be ravines, valleys, whatever else.
Or whatever, right? So embedded within that claim is a physical geometric horizon. You can't see over the curvature of the Earth with your equipment, right?
Yeah, that's what I'm experiencing at least.
Yeah, I would suggest, just very quickly, that the horizon is just optical. No wonder you can't see the object. It's out of your perception to see it. And there might be a limitation in the technology, let's say some kind of scattering when you're close to the surface, for example. Now, when we've taken out these devices, right, laser targeting systems, and done them over sections of water that should show curvature, we have direct lines of sight and able to target things at distance we shouldn't be able to target if the surface was curved. So that horizon thing that you're like talking about, I appreciate what you're saying, and I love the conversation. But within that claim, that's a geometric horizon, the curvature of the Earth, something that we don't observe and we don't measure with the same type of equipment that you might be using, just on a lower value scale.
Yeah, that's fair. I've always kind of talked up maybe like the oasis effect, across a very hot desert. Through a lens, it's going to look very distorted from the heat and stuff.
Do you use much infrared, or have you used much infrared, like sighting?
I'm just talking about. I've used the lightning pod and the sniper pod. There's targeting pods that are on pylons.
So real quick, I just got a question. So is your question more towards why it's occurring at the same amount of distance, or occurring in general?
Yeah, same amount of distance, because that leads me to believe it's not necessarily a random manufacturer issue. It is a scientific issue, I guess.
Well, let's see. If you, 2 nautical miles per hour drift, for example, and then you times that by however long you're going across from point A to point B, I mean, we're talking about purely mechanical, right? The early ones, right?
Yes.
And it's distance related, not necessarily a variable with time, right?
Correct. Distance, but there is the other variables some gentlemen mentioned where if you pull maneuvers, you'll find some degradation and drift naturally from that. But my only times I can really say clearly that this wasn't from maneuvers was during ferry flights where we're transporting equipment across the ocean.
You're just going back and forth. Right.
Is it possible it was geared for curvature and it's flat in reality? I mean,
I mean, who knows? Like I said, I'm still open to this idea. I really am, but it's just an interesting thought. I'm sure you guys haven't heard much about yet in here.
No,
so we have a guy from the aviation industry who has a channel, Jay Tolan, and he brings very high-end infrared super zoom optical gear up on airplane flights. And he zooms in on the horizon and identifies points of interest that are well beyond the curvature of the Earth.
Yep.
Yeah. We're talking mountain ranges at 700 miles from 35,000 feet, where the curvature of the Earth should be about 260 miles. And those mountains should be 180,000 feet below the curvature of the Earth, but you can see them.
Yeah, it's crazy.
And you can see the terrain leading up. I mean, that's just one example. He's got so many examples like this where it's not just that he can see twice as far as the globe. It's that it's flat the entire way, because at the distance, it's now becoming an angular resolution and contrast issue with infrared, and not a limitation of any curvature.
Yeah.
Wait, hold on. He was looking at that distance for IR.
For infrared, you use an infrared filter, right? And infrared has the least amount of
930 nanometers, which is like super deep. I mean, in the near infrared, like.
Oh wow! Do you guys know which product that was he's using? I've never heard of IR going that far.
Yeah, he was using a filter. He was using a Panasonic Night Shot camcorder with 30x zoom, and in the instance I'm recalling, and a 930 nanometer filter. You can get those for like $200.
Oh, okay, I gotcha. Yeah, like the TGPs I was talking about earlier, we're talking like 30 plus nautical miles for visual.
Here's all the specs of what he was using. I'll post it here.
He's also used like a Sony Alpha 3 or something, or Sony Alpha 7. It was just like $3,000 or $6,000 as a base.
Nice.
Right, and then crazy lenses.
Yeah, IR 950. Yeah, you're right.
It was 950 even. Okay.
Yeah. So here's what it. I mean, let me pause it on like where he could see actually, which is nuts. Here's a little screenshot. I'll post another one once I get the other one.
No, and for reference, he's a military contractor who specializes in radio frequency engineering.
Yeah, it was interesting when I've brought this up with navigators that do this for a living, so to speak, at least in the Air Force. People get very defensive very quickly.
Yeah, they do.
It's almost like they actually do know something else is out there. They're, and they're not supposed to talk about it or something.
Yeah,
the map is not the terrain.
Dude, I've taught. Okay, so like I wouldn't say cornered, but I was on my way to go to Maryland to go to this Renaissance fair or whatever, my friends, and I happened to run into two pilots, right? Like one was kind of like a younger kid, and the other one was more like a senior. And I was just like, "Hey guys, can I ask you something?" I'm like, "What do you think about the flat Earth? Like, do you guys think it's flat out there or what?" And the guy, the senior, was basically chewing gum, didn't look at me, looked directly at the kid, as if it like, "All right, you're up. This is, like it's your turn to talk." And the kid said, "Yeah, it's very interesting. I've seen this theory online, but I can't say one way or the other." And then they just moved on. They were just like, "Oh, I have to go." It was so weird. Yeah, it was so weird, dude.
Well, like I said, like as things have advanced with flight planning, especially even on the civilian side, like technology is starting to reveal itself, right, with this stuff. Like it's getting to that point where a lot of people are starting to ask questions, behind the curtains.
Yeah, not to get too involved in that topic about the occult, but like, dude, Freemasonry, square and compass. Like, come on.
Yeah.
That's why the government wants to
go beyond just asking questions. We actually know how the globe is constructed out of the math and the measurements.
Yeah,
the only thing I know for sure is from my time with flight is you can fly from the U.S. across the North Pole to Russia. So there is at least a North Pole you can fly across. Now the South Pole, who knows what the heck's going on down there?
So wait, you've actually made northern flights?
There's a 33 plus hour B-52 mission. This isn't secret or anything. You can look it up. And they do it every year. And it's like a show of force deterrence mission where they literally fly across the North Pole. And I can't say exactly
that I posted where they fly.
Yeah.
Yeah, sorry.
And this dates back from the SAC days, the Strategic Air Command days, where we had buffs flying all across the globe. But they still do it every year.
Is this directly over 90 degrees north?
Like, what was your actual lat?
Don't they veer off of it? I thought they don't go directly over it.
That's a good point. Yeah.
No, they don't go directly over it.
They don't go directly over it, but the INS has a ton of problems. Like I said, the B-52 has a old school INS because they keep it that way due to a doomsday aircraft.
Yeah, it's called a very big mountain.
All right, yeah. I just want to be specific, dude. All right. So this flight every year, the show of force goes over the North Pole. Is it directly over the North Pole, or is it close to the North Pole?
I don't know if I could say much more, but it is very close.
Okay, cool. Very close is fine. If it was directly over the North Pole, would you be able to say or not?
Probably not. I think I've already said a little too much about the INS, even.
The only thing is directly over the North Pole. So if an airplane was flying directly over my house, I'd understand that. If it flew over the house next to me, then that's not directly over my house. That's close to my house, right? You understand what I'm laying down?
Yeah. I get what you're saying.
Okay, thank you.
It's funny because we have no actual evidence that anybody's been at exactly 90 degrees north.
Yep.
Not in any aviation or nautical history.
Since you're
claims of it.
Did you say that your equipment started acting weird as well?
Yeah. The INS,
yeah, we've heard that too from people.
Yeah, there's certain areas in the globe. It's not even just the North Pole. There's other areas too where if you have an old school INS without GPS fix or backup on board, the old school INS goes wonky. And there's also
nodal points, by the way.
Which is strange because it's flywheel based. It's got conservation of energy and momentum, and it shouldn't be doing that.
Wow.
It's a very strange phenomenon. That's usually what
the question is everything acting normally? It's the map that people are using is distorted.
Well, dude, like even the attitude indicator will just start going sideways and stuff. It's crazy. Like
pretty crazy.
People don't really understand it yet, from my understanding.
Yeah. Okay. All right. I got something to ask you though, real quick, just because you actually have experience. So in the heliocentric model about Earth's rotation, right, 15 degrees per hour, that equivocates to 1,000 miles per hour at the equator. And then as you go up in latitude or down in latitude, right, you have a lower speed, essentially, of the rotation, right? Like 900 to 800 to 700 to 600 to 5, all the way down to 0 to the flattening of the poles, right, in the globe paradigm. You with me so far?
Yeah.
Okay. Now, have you ever taken, let's say, a north to south flight or vice versa, like and had to adjust for that change in angular momentum?
Yes.
You have?
Yes, and you also have to adjust your fuel constraints and your timing when going west to east or east to west.
Well, west to east and east to west is one thing, and I don't want to get into that quite yet because that has to do with certain things. But I'm talking about north to south or south to north.
Yes, you do. There is a difference with those as well for fuel.
So you've actually had to make a Coriolis adjustment.
Yep.
Interesting.
So
is it called something specifically that I could look into?
No, it's oh man, I wish I could share the documentation.
You're good.
Don't worry, Yoder will share it.
Just know that there is fuel requirements and objectives and constraints for flight planning going from north to south, south to north, and then west to east, east to west. There's differences there that have to that all go into the calculation, and
No,
each
that makes total sense.
direction has a completely different calculation. So it's interesting in that regard.
Well, that's logistics.
It makes sense. You have to invert it. Beasticles. The reason why he's doing this is because he needs to put his airplane somewhere on a spherical coordinate grid.
Yeah.
Right.
That's what it's all about. You're constantly trying to be on a spherical coordinate, right? Whether that's true or not, we don't know.
Yeah.
But
And the Coriolis is just timing correction for the sidereal effect of the stars,
right,
which affects their longitude. So, I mean, it's still a flat and stationary Earth. He needs to introduce all these corrections so that he can maintain his coordinates using WGS 84 along with everybody else in the world.
now I have another one for you guys to think about here. I can't go much into detail, but again, it's in Google. The B-52 has, in case your INS goes out on you.
Before you go there, just on that last point, can you put a pin on that, what you were saying? Just 1 sec. Was there ever an instance going north, south, south, north that you didn't have to?
No, every single time I've done a flight, there was that same calculation that gets put into play, I guess, with a flight plan going south to north, north to south.
Okay.
So
we're going to say about the B-50. Yeah, go ahead. Sorry.
Yeah, so since we don't have a GPS on the B-52, if you find yourself with an INS degraded so badly you can't recover with a fix in flight, and you're over the ocean, the backup system to that, it's called the sextant. I'm sure you guys have heard about that for naval stuff. So there's a port in the top of the fuselage. You can literally put a sextant out the top of the aircraft and read the stars for navigation.
They use the same device with the SR-72 apparently as well.
Yeah, so my question to you guys is, because we were trained, there's training on that depending on where you are in the globe and blah, blah, blah. If we were on a flat Earth, right, they would always teach you the same points of references when you look for that sextant, but that's not what they teach.
Wait, what do you mean?
Okay, what does the sextant? Sorry, what's the sextant measure?
It reads the stars. You basically navigate off the celestial references.
So how the things appear to you in the sky when you're measuring the angle of the thing in the sky. This star is 90 degrees above my head. That one is 45 degrees above the horizon, for example, right? You're asking how this works on a flat Earth.
Yeah, exactly. I'm just curious what you guys.
It's an angle measurement taken from a flat plane. Yeah. So your aircraft will have a horizontal. Right, that horizontal would be parallel to the plane of the Earth. You will be measuring an angle from that horizontal baseline upwards. You can use things like the horizon if you're using a sextant, right? Now, you might want to make, if you're at high altitude, make a dip angle correction. I'm not sure, depending on your altitude, but ultimately that's just an angle measurement. Two straight lines meeting at you, the observer. One straight line is either your level in the aircraft parallel to the ground, or when you use the sextant on the floor, the ground.
Yeah,
that's fair.
It's my understanding that they use bubble sextants in aircrafts.
Yeah,
they don't have to do a dip correction because they're flying in a horizontal plane, and you're just pointing your GP is that spot in front of your plane, not on the ground.
Yeah. So that's all that a sextant does, is measure angles, right? And it is, if we're looking at this, let's say a dome in the sky. I'm not saying the sky's a dome, it's just based on how you perceive the world. You want to locate yourself based on how the sky seems to you at this time of year based on your location. You can measure the angles of the stars. Using this method, you can find out your location if you know the time, day and time of year. Just for example, right? Now it's measured off a horizontal plane. This is, I'm sure, as Amish and everybody else wants to jump in, is how we start creating the Earth to be a sphere, by taking measurements from a horizontal plane to what appears to us to be a dome, an arch in the sky. You know what a protractor is, don't you? An angle measuring device made out of plastic.
Yep.
Yeah, so it's basically like that. You're in the middle where the circle is on the horizontal line. You've got 90 degrees above your head. This is basically what we're doing when we're measuring angles to things in the sky. The sky arching from one horizon up to over your head down towards the other horizon. This is how you measure angles to stars, from the horizontal line, angles upwards. Elevation angles, right?
Yep, that makes sense.
Yeah, cool.
Plus, you can't take angles from the surface of a ball anyway.
This is primarily where the longitude and latitude system comes from. You must understand this, right? You seem to have been taught about it. You can measure angles to things in the sky. You'll probably be able to find your latitude if you can figure out where Polaris is, for example, or the celestial equator, these types of things. The sun will give you your longitude position.
Yeah, there's I guess the only other thing I got for you guys, I got to get going, but there's parts of the globe that basically different theaters, I guess, if you can call them that, where coordinates get a little bit more spread out from the latitude, longitude, where there's times where they intersect almost due to, again, what was explained to me, the curvature of the Earth, as opposed to if we were on a flat plane, they would not intersect so close together between coordinates.
What do you mean get closer together if you've got a center of radius?
So
obviously, if you've got a center of radius, like circles of equal altitude, which would give us latitude around a point in the north, right? Now, obviously, your longitude lines are going to get closer and closer together. It's like explaining why did the spokes in my bike wheel get closer together the closer they get to the center of radius? Obviously.
Yeah. I mean, that's probably the way to explain it, I guess, is if on a flat Earth model, right? You know, the closer you are to the center of the radius, that's why it does that. That makes complete sense.
It just, the distance coordinate relationship still has to meet out.
Right.
Hey, before you go, Wing.
Just to be clear,
for you. Oh, sorry.
Just to be clear one more time, the flat Earth model that you mentioned there is. If you're talking about an azimuthal equidistant projection, that's not a flat Earth model. That would be a globe model.
I'm thinking about it in my mind.
Longitude does taper in the south, wherever that is.
Yes, I'm thinking about in my mind the flat Earth model where, say, maybe the North Pole is the middle reference of an entire circle, I guess, and then Antarctica is the outer border of that circle.
Yeah, that there is a straw man Bush League. That's just a map. I mean, some flat earthers use that as some kind of model. Believe me, nobody here believes in any of that nonsense.
Oh, okay,
That's a squished globe. That's a squished globe.
Yeah, that's just a projection, bro, of the same coordinate system that's been used. But, yo, Wing, I actually tagged you in something. I want you to grab that before you go. I just found it. And it's actually a correction table for the effect of Coriolis acceleration on bubble sextant altitudes, right? And then there's a little footnote I just found on the bottom. It says, if a visible sea or cloud horizon is used, there is no correction of this sort.
That's very revealing right there.
That's what you always have, though.
Exactly.
Right? You always have a cloud or a sea horizon from a plane.
Exactly.
What else do you have?
So literally, there is no bubble sextant corrections that, like Jedi, we were thinking like, oh, maybe they have to do a diff correction or things.
They just lie right to you guys, right in the books.
Right there, dude. But yeah, take that PDF.
That's very interesting. Yeah, I appreciate the share with that.
Yeah, no problem. Got tons more of information if you want to. If you're neutral and you want to learn more about it, bro, like, any question, just bring it up. I guarantee you someone in this VC has either heard of it or has access to documents to substantiate their position on it.
Oh, yeah, for sure. I'm sure you guys have heard all sorts of stuff in here.
Yep.
Wing, could I ask you one question? And it's just about your personal experience. So when you're flying, because I imagine that you have flown quite a bit, were you flying level? Did it feel like you were flying level? Did you see any curve?
So all I had for you is autopilot or between, like, let's say 20,000 to 28,000, because we got to stay relatively the same altitude as our tankers. And when you look off to the horizon, for example, if we're flying to Guam or something, I would not see Guam until a certain mileage off on the horizon. So that's all I can really tell you. Now, when you look off the horizon at 20,000, 30,000 feet, it does make a little bit of sense where there could be a spherical horizon, but that's all I got for it.
All right. I'm more asking about, like, you're in your cockpit or wherever you're at in the plane, and you are in the plane, because I've been on commercial flights, right? I'm just a civilian for all intents and purposes, but I feel like I'm in a metal tube that is flying flat, level, right? Was that your experience as well? Unless you were maneuvering or banking or whatever you were doing.
It doesn't feel like you're negotiating curve when you're just holding altitude.
Yeah, you're not gonna feel any of that curve, so to speak, until you're above like 40,000. I feel like
you feel.
You think you feel more
if you're looking across the horizon. You're not going to really.
No, I'm just talking about the feeling that in the plane. I'm talking, let's not talk about the horizon. In the plane, are you flying level?
It feels like you're flying level, I guess.
Okay.
He pushes down on the joystick.
Well, you can put a glass of water down and it isn't going to spill over. I could guarantee you that.
So what's hard is nowadays our, like the other gentleman said, our gyroscopes and like the way that our FLCS, our flight control system is, it takes into consideration that that nuance there that I think you're trying to explain, where there could be like 3 or 4 degrees that you would have to be pushing the stick if you were flying across a sphere. So it's hard to tell. It really is. Unless we're flying like a World War II plane or something, it's really hard to make that determination if it really is a flat plane or not. Because you got to remember, again, there is an actual calculation there in the FLCS, like between radar altimeters and all sorts of other things that determines, how to keep you at the same altitude for autopilot.
That has nothing to do with the ball earth.
Yeah, I know. I'm just trying to explain. Someone was saying if you push this, you should have to push the stick a little bit to stay.
You should have to go down around the ball.
Right. But then in that regard too, there still is gravity at play, right, with the aerodynamics of the aircraft itself.
No, planes use air pressure to fly, not gravity.
Yeah, I mean, I see that there is still some gravity force there, and otherwise the aircraft's going to fall out of the sky.
Chance.
What? So it's still flat, whether you like it or not. Gravity, whether you like it or not, exists or not, it doesn't matter. Earth is still measured flat. So if it's measured flat, your plane is flying in a plane over a plane. Get it? All 3 are planes. The object is a plane, the path you're in is a plane, and you're flying over the surface, which is a plane. That's why it's called a plane.
Yeah, I get you. When it comes to the spherical degradation there that you are saying that we should be able to experience while flying, we're talking like a much larger distance, though.
Why do you only see it forward and back and not left and right when you look out the side? Or how come you don't see it left and right when you look out the cockpit window? You only see the Guam coming up to you from the center of the window. How come you only see that, but you don't see it around the ball like ISS?
I never said that. Across the plane of the Horizon 360, you can potentially see a spherical horizon above 30,000+ feet. Okay. That wasn't my experience. That wasn't my experience, but again, I'm open to the idea. I really am.
I know it wasn't your experience because I'm telling you that doesn't happen. That's why you never experienced that.
Okay.
A spherical horizon at 30,000 feet.
Potentially.
Yeah.
Okay. So is that just like looking out one window?
No, our aircraft, it's not just one window. I mean, I'm talking about looking out of a canopy. And
okay, cool. So you can see 360 degrees around you?
Oh, out of a curved window? Shit.
Well, let's just understand, right, that if you're saying that the horizons...
Have you guys ever sat in...
If the horizon starts to curve, you're saying that one part is higher or lower than the rest of it? Like the part in front of you seems to be higher than the part left and right. That seems to be lower curvature, right? Is that what you're saying?
All I'm saying is at a certain altitude, when you look around you from a 360 view, you can potentially see across the horizon at all ends.
What does that even mean?
Yeah, exactly. be equidistant
because I'm open to it just being an optical illusion, like I was saying earlier. Like there's different oasis effects on the horizon, blah blah blah.
Yeah,
but
at the moment,
but what I'm saying is,
what happens when you
if you sit in a canopy aircraft at 30,000+ feet and look around, it looks like on the horizon there is, from all angles, there is some curvature there.
Oh, that's a tiny Earth.
So now he sees it
way on the horizon. I'm not talking about like
you could almost plot that around the ball. If you looked out the window and you saw that curve and you draw a big circle with your finger, you just kept going around in the air like you could move your arm, you could draw that whole ball in front of you. You know that, if you can see any radius at all.
I mean, if you're flying into a coastline of a country, you can kind of see it better.
Okay, so it's created by looking through the canopy.
Sure, maybe the canopy's causing that.
Exactly.
Well, you said it is. You said you were looking through a round canopy at everything. Of course, that's what's causing
it. He sees it. It wasn't his experience. You can potentially see it. You see it, and it's caused by the canopy.
That's fair. Yes, maybe that is the case. I'm open to that.
Wing, your curved retinas. Well, hold on. Wing, you know that there's no, like, even in the globe paradigm, they say that you're not high enough to see the curvature of the Earth.
Yes, I understand that, but there is a point where you start kind of seeing it, in my experience, unless the canopy is distorting you a little bit.
How could it not?
Yeah, it's probably
I agree.
Yeah. But
I agree. It probably is the canopy that.
Can I ask you something else to think about? Like, in terms of your like pressure readings, right? When you're flying hundreds of miles, right? About what is the deviation in terms of your pressure? If you're staying at let's say you're staying at like a constant height, constant altitude, do you notice any deviations in pressure that are significant?
I mean, yeah, the pitot tube is going to read completely different at different altitudes.
No. I'm saying you're at a constant altitude. You're just at a level.
Oh, I got you. Okay. Yes, that will also fluctuate.
I'm saying, how big are the fluctuations?
Not very big. I mean, the FLCS takes that into consideration, so I'm not really sure precisely what the amounts are, but that like you'll feel like literally the jet kind of like going up and down, and almost it feels almost like an elevator motion, and it's not turbulence due to those deviations because it's trying to fight itself for the same altitude numeric set at in autopilot.
Okay, that's interesting. Yeah, I mean, so you've obviously, how long you been into this topic, this conversation, or you've been curious about it? About a month or so, or maybe a week?
No, I've always been curious about this since I began flying, really. And when I started asking oh, sorry, go ahead.
I was gonna say, you ever heard of the gas pressure argument?
No, I have not.
Okay. So how do we being Earth, like, how is there an entire, like, a stable environment, right? 14.7 psi near the ground surface, and then, there's a gradient as you go higher and higher. Now, how do you have a pressurized system, right, next to the vacuum of space without a container?
Good question. I guess whatever the layer is of the atmosphere.
Yeah, but how is it? It has to be contained, right? If you're ever a high pressure and low pressure system next to each other, they're going to try and equalize. But that's not what they say. You know what the answer is?
What's that?
Gravity.
Well, that makes no dang sense.
Yeah,
Earth is flat. I don't know why you think it's a globe. I don't know why you think space travel's real.
So, like when we have different weather pressures, right? It's interesting how that all stays within our atmosphere and doesn't just dissipate off into space.
Yeah, exactly. Especially with all the motions. Like, we're supposed to be spinning at 1,000 miles per hour at the equator, going around the sun at 67,000 miles per hour, and then also simultaneously rocketing towards the center of the Milky Way at like 500,000 miles per hour plus.
Yeah.
Yet we have a relatively stable atmos that seems like it's being contained. Now, you compare it to any other pressurized container, like, let's say, a tank of propane, for example, right? Sure, you've had a barbecue, you've had a tank of propane, right? You have a pressure gradient in there, right? You have liquid on the bottom, you have air on the top in the tank, right? Because it's contained, and then it equalizes. Well, just apply that to Earth. What do you have? Something has to be containing it.
Yeah, it's very fascinating, honestly.
Dude, that one got me when I first was going into this, and I was like, "Well, yeah, that doesn't make sense."
That's the thing too. Like, out of all the pressures and gases and crap over thousands of years at this point, how is that all still contained? You know?
Yeah, and it's a cyclical. It's a cycle. You have the nitrogen cycle. You have the water cycle. Like, goes up.
What do you mean?
How's
How's it all contained? It has to be contained in order to recycle itself. It has to do that. Not where did it all? Why isn't it all flying everywhere? It's can't fly anywhere, or else we would die.
Yeah.
That's the thing, bro.
I'm right there with you guys. No, seriously. I mean, it makes total sense. It really does.
Now, if you have that, what's the implication, right? If there is a container or containment, that means we never went to the moon, bro.
I don't believe in the moon. I don't believe in the moon landing at all, to be honest.
There you go.
So what were you going to do when NASA goes next, or they just canceled it? But what are you going to do when they go to Artemis? Take that to the moon. What are you going to do then?
No comment. Honestly, they're probably hiding so much crap from us at this point, anyways.
Oh, well, anyway, that's been canceled because I predicted, but many people predicted that would never happen. I even won a bet on Kalshi already on that one. And I got more coming, meteors that are supposed to hit in 2027. I said no, people are betting yes on it. So I'm going to win that one because space is fake, dude.
Yeah, I mean, what do they actually mean when they say we're going to go to Mars? This is my theory. I don't know if anyone else subscribes to it, but I think they have coded language, just like the military does, right? You have coded language. There's certain things that mean other things, right? Comparatively to, you say something in civilian world, right? It means something totally different in military world, etc. Well, I think they have a similar type of system. So when Elon Musk and someone like a public figure that's at the front head, again, this is just my opinion, says that we're going to Mars, right? And it's around the exact same time that the DIA, right, the Defense Intelligence Agency says, hey, we are about to deploy this system called Mars, which is like machine. Here, I'll find the actual article because I'm spitballing, but essentially it's literally acronym. Like Mars is an acronym, essentially. And this is what I'll show you here. Let me see here.
I got about 2 more minutes. I got to start cooking for the fam.
Hey, Wing.
Yeah.
Hey, Wing. Are you privy to information that you can't share with us?
No, I'm not. I'm not privy to any information.
There you go. Smart answer. There, if you've seen the side chat before you go, it's called the Mars Project. And it was released around the same time that Elon Musk was saying we're going to go to Mars. It's a machine-assisted analytic rapid repository system.
What's the source on this, or where did you get it from?
Hey, and what does this mean?
I'm just saying, like, in terms of these public-facing announcements, like we're going to go to Mars, we're going to go back to the moon, create a space force, etc. If it's not actually what it means,
most of it is to keep everybody's attention focused on that dumb shit. 99% of everything you hear is just to keep you focused on pretend. Just imagination. Keep you busy work. So you're not focused on anything else. Don't even think about flat Earth.
It's a good point, but if you relate it to, like, for example, like the Joe Biden versus Trump debate in like 2021, where Joe Biden's cooked, like he's not actually, like he's just reading a teleprompter, but in the teleprompter he says something like, "We're about to go into a dark winter," right? Like, what the hell does that mean? But if you look, there's a thing called Operation Dark Winter from 2001 that happened around, the same time right before 9/11, and it was basically a 20-year plan that involved accelerating vaccine manufacturing. So I mean, there is coded language in the media that people say, but I don't know. That's just me. Anyway, Wing, thank you for stopping by.
Yeah, it was a good talk, gents. I'm sure I'll be back. Appreciate it.
Again, that was all my opinion. That's just my opinion, you guys. Whatever.
I'm trying to jump in there. I didn't want to be rude.
Oh, what's up, Elijah?
So, it was like such a golden opportunity missed because while he was talking about their things that they use with the GPS, one of the things I was talking about is DME. Obviously, like what's happening as flat.
Yo, your mic is so bad, dude. I can't hear you.
Oh, all right. Next time.
You said something about GPS, Elijah. You wanted to get him to talk about what? I'll try and remember it in case he comes in. Dang, lost him. Chat. Oh yeah, that would have been a good point. Dang it, I wish I saw that. The ground speed, the ground distance versus the altitude, and how he's able to keep him to know what that fix is. Yeah, that's straight up just an angle.
He was saying that, like you don't start seeing discrepancies or, whatever until like 200 and something miles or something, was it? And he's like wondering why that is. And he asked, he's like superior or whatever. And, they said, oh, it's due to the curvature of the earth, right? It's like, well, that's a lot of curvature over that range. So why wouldn't there have been degradation in his systems prior to that?
I don't know. I think he was more focused on like why it happened with the mechanical INS or whatever consistently around that mileage. But I was looking at the INS inaccuracies and stuff like that, like what could cause it, and it straight up says that the bearings, especially with the older ones, like the bearings and where was it? It's like bearings. Yeah, gimbals and bearings have wear and tear over time, and because of the friction, it causes the output to drift over time. So, especially if it's an old system, you can only maintain it so much, I guess. So an input to an INS, it's initial position, GPS position, barometric altitude, and true airspeed. And then it says inertial outputs, pitch and roll, true and magnetic heading, true airspeed and ground speed, latitude, longitude, and inertial altitude, wind speed and direction and drift angle, pitch, roll, and yaw, and vertical speed and rate. So, Dang, that would have been a pertinent point to bring up, Elijah. My bad, dude. I wish I saw it. But if he's getting ground speed from his INS, then he's basically taking an angle. That's just a
Yeah,
right
from
triangle.
what distance? From what distance is it?
He said it was around 200 nautical miles.
Who did?
Wing?
No, I'm sure I've heard Elijah say it was further than that, like 300 miles.
No. Oh, I don't know. I don't know what Elijah. I don't know what he said about that.
So they calculate. Yeah, it's like from 300 miles away. Yeah, they start calculating that angle. That don't they? Is that it, Elijah?
You might be imposed at the moment.
Yeah. I'm sure I've heard when these guys talking about it, like at distances of like 300 miles from the runway. I don't know.
Check this out. There's a section for required, what's it called? Reduced vertical separation minima, RSVM or RVSM. And this is the type of errors that need to be recorded that are caused by malfunction of equipment. So, like, let's just say something goes wrong with it. They have to have, it says a total vertical error of plus or minus 90 meters. It says an altimetry system error of plus or minus 75 meters and an assigned altitude deviation of 90 meters. So they have a vertical error that's within 300 feet. They have to report on it at all times. I'm trying to find like this manual though that actually shows that.
funny is the guy that was in here earlier, the B-52 pilot or crew member, whatever the case was. He was saying that every so often that his flight would be off of the coordinates that he thought that he would be at, and he'd have to constantly correct for that. That he was told it's because Earth is a globe and his mechanical INS was unable to keep up with the curvature. What I find funny is we get people coming in all day, every day, telling us that the way to measure Earth a globe is to fly, to take airplanes. And he comes in, he's like, oh, my airplane can't do it. And that also proves that Earth is a globe. Or might suggest it to the people he's talked to. So, I mean, which is it?
Right.
You know, and this is also interesting because if they're using airplanes to measure out the globe and to plot coordinates, then how come this airplane was incapable of accurately keeping up with and matching the coordinates? So is it possible to say this, that the airplane was keeping track of its flight and the pilot keeping track of his flight, his heading, his velocity and everything else, and was that accurate? And the globe coordinates were not accurate. You know, people say that the globe is what's correct and all the measurements that are taken in reality are wrong. But what if the measurements are right and it's the globe that's wrong? So, I mean, that's why I was asking him and why you thought too to ask, you know, he says that he's off course or off heading, but relative to what? Relative to an ideal globe? Well, then how did they measure the globe that accurately to begin with?
Exactly.
I mean, really, I think they're both inaccurate. Those mechanical gyro compasses are known for having errors. You can go like Google gyro compass errors and you'll get like a list of 13 of them. These airplanes usually have several of them, you know, for fallback.
Yeah, it's interesting that he's open to it. At least he didn't believe in the moon landing. I'm sorry, I'm deep diving. I have like 50 tabs open on some of these flight manuals. You gave me some ideas to look into, actually.
There's a big challenge with measuring your velocity and the distance you're covering over the ground. Because you've got drift, you've got the wind pushing you and pulling you, like I was referencing, obviously. But then people say, yeah, but we have the ground speed, right? And the ground speed. So, you can figure out where you are if you leave one place at one point in time and arrive at another place at that point in time, and it covers X to Y distance. Okay. How did you measure that X to Y distance? Did you use globe coordinates to calculate the distance? Well, now you're engaging in circular reasoning. Right? Because it's like, well, we just know the distance from Los Angeles to New York is this. So if it took you, this many hours, then you must have been going that fast. It's like, well, aren't we allowed to challenge that distance? And then how do you know you're going that fast? I mean, you really don't have enough information at your fingertips in order to get the data you need to be that precise. These distances and velocities are just all estimates, guesstimates, and I'm sure they've gotten pretty good over time, but that's in reference to maintaining a map coordinate distance. Whether or not they cover that distance or orient themselves in that way over time in the same manner as reality. Well, then they say, well, GPS, relies on the speed of light, and extremely accurate clocks. Well, that too is circular, right? Because that's also using that to calculate distance, not measure. And GPS provides users with any coordinate reference system they want. You want a dinosaur nugget shaped coordinate reference system in 3D? Go for it. You get your 3D dino nugget coordinate reference grid. And it will work. Yes, it will work anywhere on Earth. Guaranteed. Now, it may not be efficient, but it'll get you to where you need to go.
Remember he was talking about you could see the spherical horizon on 360.
Yeah, I'm going to claim BS.
Well, look at this.
It doesn't check out.
There's an entire PDF on visual illusions for pilots. It says, the following factors and conditions affect the flight crew's ability to perceive accurately the environment, resulting in visual illusions. Airport environment, ground texture and features. Off-airport light patterns such as brightly lighted parking lots, black hole effect along the final approach or flight path, uphill sloping terrain, downhill sloping terrain in the airport vicinity. Then weather conditions says ceiling, visibility, and or obstructions to vision. Visual illusions can affect the decision process of when and how rapidly to descend from the minimum descent altitude, etc. Ironically, it says deviation from horizontal flight path or vertical flight path.
Brought up his laser targeting pod as being somehow being capable of measuring elevation change over a globe. because there's some interesting inconsistencies with it. But I don't think he understood the scale that he was working with. I really don't think he really had any intuitive grasp of any kind of what the globe's dimensions are supposed to be. I mean, the exponential drop rate over distance really gets people. And that's kind of a funny thing because history is full of stories about people who don't intuitively understand the power of exponential compounding.
Yeah, the compounding error that could occur, especially when going over many miles.
Yo, brother, how are you doing?
Here we go.
What's up, friends?
The Illuminati.
Exactly.
And your schizophrenia medication.
Oh, interesting. Why do you think so?
I mean, you told us that you were taking it, so I figured.
Oh, I don't think I told you that.
Oh, yeah, I remember you did, actually. We record conversations in here.
It's also very uncommon in my country to prescribe opioids or whatever. Basically, 0.3% of our society even do opioids instead of 10% of Americans. I know it feels weird for you, but it's not common here at all.
I didn't bring up opioids.
I mean, you brought up schizophrenic medicaments. That's probably something like Xanax or opioids or benzos or whatever. We don't do that shit. That's why we don't live in tents.
I remember reading an article where in Switzerland they're basically putting opium or heroin in freaking vending machines.
Yeah, that's not true. But you can have legal heroin in the hospital if you're an addicted person.
Maybe that was it. Well, wonderful.
Yeah.
I'm sure you're tickled pink.
Whatever you take, Swiss has no homeless issue at all. Like the junkies are cared of. Do you understand what I mean?
Yeah. Did the Rolling Stones play the hospital a couple times a year? Drop in.
I mean,
yeah. I mean, they take your money by force, call it taxes, and then they pay for all these vagrants to live inside houses and say, "There, we cured homelessness."
Yeah, but the living standard in Switzerland for everyone is pretty high. Like, it's a good society. Do you see what I'm saying?
Yeah, it's great if you want to be a do-nothing vagrant.
But most Swiss people work. The unemployment rate in Switzerland is not higher than the unemployment rate in America. It's even less, probably.
Okay.
Yeah.
Yeah, so you guys just use other people's money to put homeless people inside of buildings.
Yeah.
Right. America used to do that too. We had insane asylums, and they were quite beautiful, bigger than any castle in Switzerland.
Yeah, you're embarrassing yourself. It's called the social state, where it's important that everyone in the social society has some kind of dignity and rights.
Oh, yeah, says who?
It says everyone who lives here and appreciates it.
Yeah, well, what if you disagree?
And then it's direct democracy. You can literally start a petition that there will be a public voting to your issue if you think so.
Oh, wonderful. You can, just complain. I'm sure that'll help.
Yeah, when COVID hit, for example, then there was 100,000 signatures within 2 days, and 2 weeks later the government had to hold public votings if they are allowed to do any measurements against it. It is very functional. Do you see what I'm saying? People are not voting in Switzerland to not help homeless people because they appreciate that there is no homeless people on the street, that the streets are clean, that everyone has food, that the ill are helped like everyone else should be helped.
Too bad taxes are high, and that's the one thing that I hated about traveling through Switzerland. You had to pay fees for every little stupid thing.
Yeah, I paid 30% taxes, I guess, of my loan. I don't know what's your taxes in America, but probably pretty much the same.
Maybe half.
I don't think you pay 15% taxes in America, but okay.
Really, that's what the long-term capital gains rate is. So yeah.
Yeah, congrats, dude. So what? Like, my government doesn't use the taxes to fuck children all day.
Oh, you don't think Switzerland's involved?
I don't know. I've not heard anything about it. Have you? We're not bombing the shit out of every country around us all day. Our houses are built from beton, not from paper walls. And our streets have no potholes. Everything is clean, everything is modernized, everything is repaired. The infrastructure is like new. Free healthcare, free education.
Yeah, we should have open borders for Switzerland.
I mean,
yeah, open borders for Switzerland. Isn't that a great idea? Wouldn't that be nice and social?
I mean, maybe you Google up the American community in Switzerland. No one of them will ever go back.
No, I'm saying we need to have Somali communities all over Switzerland. I think that'd be perfect.
Yeah. I mean, you are bombing at the moment Somalia every day with drones, so obviously we will have refugees from
Why don't you open your borders to them?
Yeah, where do you think they're going?
Oh, yeah, right.
Yeah, where do you think they're going? To Europe or to the United States? Do you understand that we have 2 million refugees in the last 7 years because of your bombs? Congrats, America.
But maybe we should send more in there and see how your great society upholds itself.
First, create migrants all day, and after hate on migrants all day. That makes a lot of sense, I guess.
Yeah, and so hope you get 7 million more.
Yeah, I mean, you sound pretty boring. Not gonna lie.
No, I think it'd be great if you had open borders and we could see how your great society holds up. Like I said, it'd be wonderful.
Yeah.
Just for the entire world.
Austria is 25% of Austrians are migrants, 10% of Germans are migrants. We have
that doesn't count. No. We're talking like sub-Saharan Africa. We're talking people from war-torn countries with PTSD. You guys need to rehabilitate them all because you are in the best position to do so. Why? Because Switzerland's so wealthy. Like you're so bragging about all your wealth. Why don't you open your borders and rehabilitate all these people?
Yeah,
who knows? You might find the next great skier.
Interesting. Why don't you stop overthrowing governments all day, murdering people and destroying their homes and their economies all day so we don't have refugees in the beginning?
Oh, because what fun is that? I mean, you guys are so wealthy. You should be forced to share your wealth, right? Wouldn't that be social?
I'm happy to finish the sentence. When you overthrow the Venezuelan government and you steal all the oil, and then next year you will have 100,000 more Venezuelans fleeing their country because you have basically destroyed their income and their economy.
Oh my gosh!
Are you going to be then fucking racist all day? Are you going
Is it basically a homeless schizophrenic and he's like bragging about how wonderful his country is, living off the back of it?
Do I look homeless to you?
Can't see it, bro.
Actually,
that's crazy. Okay, bro. If you think that I look homeless,
that's you in the PFP. Yeah.
Okay.
A homeless dude's haircut.
Okay. I mean, it was 25 euros, so it's not like an expensive haircut, but it was definitely not a homeless guy who made it.
Do you get government assistance for haircuts too?
I don't get government assistance. I work.
Can you work on being more interesting?
I don't know why you have to support him when he's fucking racist all the time. Makes no sense, but welcome to the Nazi club, I guess. Congrats, dude.
Come on.
Are you finished now talking about the South
why are you even here,
Saharans?
dude?
Are you now finished talking about the South Saharans and how dirty they are and how you want to basically make Europe flat with them?
I think you're in the wrong channel, bud.
I'm not sure he's talking about all that stuff. I'm just wondering.
What are you doing? Yeah, you can wander somewhere else, bro.
Okay. And do you want to give me some proof for the flat earth or what's going on here?
Actually, no. I would prefer you stayed on the globe.
No, I was not talking to you. I think we are finished somehow.
I was talking to you, so I'm sorry if that hurts your feelings.
Yeah. Can I ask you something? When did your wife divorce you?
Never.
Oh, okay. I think.
Yeah, you're pretty boring, dude.
Yeah, probably they did. So who is the other guy who speaks?
Your daddy?
Bro, I know you have no education system going on in your country, but you people need to start thinking again. That's crazy.
Oh yeah, why don't you tell us about all your reptilian lizard overlords in the Illuminati?
I don't know, bro. The Epstein files come from America. Do you understand what I'm saying here? All the
No, why don't you be specific?
All the bombs are dropped by the United States. All the murder is coming from the United States. All the pedophiles are coming from the United States. What are you saying?
All of them, really?
I mean, 98% of them.
So wait, you mean they don't come from Switzerland? If I Google this and see about Switzerland's situation, I'm not going to find anything?
Oh, obviously, politicians are discussing.
Oh yeah, obviously, yeah. So yeah, you maybe want to retract that statement.
But we are not. We having no elite network here, having an island for children. Do you understand what I'm saying? It doesn't mean that our politicians are not doing dirty stuff. Obviously, they are discussing as well, many of them. But we are talking about different stratosphere of violence, dude. My politicians, I've never heard of them that they fucking eat children, dude. I'm just saying.
I don't know. I mean, you guys provide an army to the Vatican to protect what they're doing there.
Yeah, dude, fuck the...
Yeah, isn't there the Swiss Guard? I mean, talk about like the top pedophile protectors. The Swiss Guard.
I
you want to keep bragging about Switzerland some more?
I 100% agree with that one. Fuck the Catholic Church. Fuck these pedophile Vaticans. Not gonna lie. I'm not disagreeing on that.
Yeah, well, why don't you call the Swiss Guard back?
Yeah, bro. Do you understand? The Swiss Guard they are not existing in the Switzerland itself. No one has ever seen one of them. I mean, what?
Well, yeah, because they're busy protecting the Vatican, right?
Yeah, I mean, fuck the Vatican. Who is going there kissing his hand? Is it Donald?
No, Swiss Guard.
I mean, I'm just saying. You know what I mean? Is he going there and kneeling down in front of him, the Pope, and
yeah, your country provides protection for the biggest pedos on the planet.
Yeah, I mean, I'm not disagreeing with that one. The Catholic Church is definitely the most pedophile organization in the world. By the way, I exited the Catholic Church because of that reason. You people are still voting for your fascistic, mass-murdering, genocidal freaks, right? So there is a difference in that one.
Reason.
Yeah, I already see in 3 years how you're gonna be. Oh my God, my leader is sent from God. He gonna save America, and the other side, he's the lesser of two evil. We have to vote for this guy.
Yeah, who's the Pope in the Swiss Guard?
Yeah, bro, what do you want?
You think the Swiss Guard thinks the Pope was sent by God for divine rule too?
Yeah, I tell you one thing. I understand you people are finding Jesus again in your country, but basically no one cares about religion here. I mean,
except for the Swiss Guard.
Yeah, fuck them.
Yeah.
Yeah, I'm not voting for them. They're civilians in Switzerland. Like, they have no, they are not available here. It's going to be difficult to compare Switzerland to the United States in evilness. I'm just saying, you know, it's going to be very difficult. So anyway, what's going on with the flat Earth? Are we still flat or are we already concaved? I'm just saying, guys, the Earth is actually concaved. I mean, I'm not even trolling. It is how it is.
Can you say we know nothing, Lebowski?
I can't. I'm sorry.
Yeah, you sound like the nihilist from The Big Lebowski. You ever see that movie?
I have seen that movie.
Yeah, you're just like the nihilist, dude.
But you don't believe it's concaved?
You sound just like the nihilist. Can somebody find a clip and play it?
Thanks, bro. Maybe I have to apply there next. I could become rich. So who is already on the flat Earth movement? I mean, I have nice service and whatever. These people say all the time it's concaved. I do think concave makes a lot of sense, not gonna lie.
I knew you were brain damaged.
Bro, look, I was flat Earth as well, but you have to wake up suddenly, you know, when you see the real
I'm so
information.
glad you're off of that then. I'm glad you're not on our team.
Exactly. Have you ever read the Orwell Linde book? It's basically before Jesus.
Yeah, who cares?
I mean, it talks about the firmament and about the concave Earth and about everything.
Yeah, it sounds very religious.
I mean, I don't believe in the religious part so much, but it's still interesting.
Nah, it sounds boring, like you.
Interesting. So you don't believe in the concave Earth, I guess. I think you will get there.
We're not religious nuts in here. Belief means nothing. Empirical evidence is everything, so stop talking about beliefs. That's retarded.
Exactly, brother. I'm glad you stand strong for empirical evidence. Can we debate empirical evidence for the flat Earth, maybe?
Yeah, we can.
Okay.
You know how tall you are. You don't have to tell me, but do you know it?
Yeah, I'm 176 in centimeters.
How did you figure that out?
I measured it.
Right, so therefore, if we go to a lake that's 10 mile wide, we shoot the laser of... Listen to me. If you interrupt me, I'm just going to mute you or kick you or do whatever. Just listen to me for 30 seconds, then it's your turn. We go to a lake, it's 10 miles wide. We shoot the laser 1 foot over the ground to the other side. If it ends up 1 foot over water on the other side, that means water is flat, and that's just the way it is. If you live on a ball or if you live on a concave Earth, there would be some difference, right? If you live on a ball of the radius 3959, that laser should end up over 50 foot in the air. It doesn't do that. We've done hundreds of these tests. Now you can go.
1 mile, right? What should be the difference in curvature then? With 1 mile? Or 10 miles? What did you say, 1 or 10 mile? I didn't get it.
I thought you said you were a flat earther before. You don't know this? I'll look it up for you.
Yeah, okay. So you don't know it by yourself?
Oh, I do.
That's interesting.
50 foot.
Okay. And have you done the experiment by yourself, or who has it done?
Yeah, I have. This is the method. We can do it. Anyone can do it. I'm going to paste it in the chat so you can follow along, because there's one more example you need to understand.
Okay.
Give me a second. I'll show you the diagram as well.
Guys, you should learn from him. He provides data now. That's crazy, no?
Yeah.
Have you ever heard something in that channel that someone provides data? That's interesting.
Yeah,
I am excited, my friend. Exactly, provide data. I'm excited.
Here it comes. I'm going to put the picture in there so you can follow along as well.
Okay, but the real picture, not like AI or GIF or something.
No, it's a diagram. Even you can understand it.
Okay, but I would love more likely to see pictures from your setup and the laser and whatever.
Yeah, we'll give you a video while I'm done with this. All right, so follow along. Do you see the chat there?
Yeah. Good Google skills, brother.
I'm going to read it for you and the listeners, because we are broadcasting on YouTube now, right? So this is more for them. But you can follow along if you have easier time to read. But you have good English, you can listen to. We have been told that the Earth's radius is 3,959 miles.
Because we have that number, we can use simple math to figure out how much water needs to curve over distance. And if we look in the diagram down below, we can see that over 10 miles, there has to be 66 foot of drop at the tangent. Now, you said you were almost 6 foot tall. So for you, it would mean that it's about 50 foot because you can see a little bit further, because of your height. So if you have a friend and you bring that friend to a 10-mile wide lake, you have your friend flash a mirror on the other side. If you see that flash, it can only mean two things. Either your friend is over 30 feet tall or water doesn't curve. Now you take your pick. If water doesn't curve and Earth is covered by 71 or 72% water, it cannot possibly be a sphere. That's impossible, logically speaking. Do you understand so far?
Yeah. I mean, water curves, I understand, obviously.
Yeah, water doesn't curve. That's the point here. Because if it was curving, you would not be able to see your friend. Unless he's 30 foot tall. That's 10 meters. Is your friend 10 meters tall?
I mean, I'm just saying, in your experiment, you should not see the friend, I guess.
Exactly. Not if Earth is curving by the radius, they say. Now,
exactly.
we do this with the laser as well. We shoot that laser 10 miles to the other beach on the other side. If Earth was a ball, it should end up about 50 foot in the air from 1 foot, if we shoot it from 1 foot over the water on one side. But it doesn't do that.
Listening to him, he talks about data he is providing. That's crazy. Okay, go ahead, bro. Go ahead.
Right, and now I'm going to give you a link to a video where they did something even crazier.
Who is they? I thought you did.
Yeah, I've done it as well, but this is people who actually filmed their experiment. They did this method.
You didn't film your experiment. Is that what you're saying?
I don't have to. It's a method. You can go out and do it. Find yourself your own link.
Oh my god, bro. I was so excited and you're gonna be disappointed again. You have also found a video on YouTube where someone shoots a laser over a lake. Okay, we have all seen the videos.
Myself, but you can trust that or you cannot. It doesn't matter if you trust me or whatever the fuck I did. You can go out and check it yourself. That's the nice thing about it.
We all have seen the videos. I can assure you that one.
Yeah, well then explain it. Why haven't you gone out and tested it? Get yourself a drone, get yourself a friend, get yourself a mirror, do something. Go see if you can see land 10 miles out. Can you do that?
When did you do the experiment?
Right in Sweden, between Sweden and Denmark. You can go down to Malmö.
What year did you do it? What year did you do it?
2021.
Okay, so that's basically iPhone 14 time, right? You don't have any photos from your setup or from the laser or anything, a video or something?
I did it for myself. It didn't matter. Okay,
yeah, it's crazy. I want to cry, dude. Oh my god, I was so excited. You're just like a charlatan as well. That's crazy.
You can do this too. You go to Malmö any day.
Yeah, we can all do it. Unfortunately, no one has done it in here. That's crazy. Okay, like everyone else, guys, he has no data as well to provide. Unfortunately, we got disappointed again.
Do you know that Google has
that's depressing.
Pictures people have taken from the beach in Copenhagen?
Yeah, we have all seen the pictures, bro. We've all seen the oil islands, and we have seen the laser tests, and we have seen.
Why don't you just go out and confirm it yourself? You shouldn't take my word for it. That's the whole point.
I wouldn't. I would have. Listen, I will not take your word for it. I would have taken your data for it and your documentation of it. But unfortunately, in 2021, you were not capable of taking any pictures from the experiment.
So you can go there yourself and try it out.
I don't need a location. I have lakes enough around me, brother. I could find it out if I want.
Bring a friend.
Okay. I'm just saying you have not provided any data, unfortunately.
I shouldn't have to, because you shouldn't trust me. That's the whole point, dumbass.
Okay. I mean.
Do not trust me. I'm telling you.
Why even start the debate? And you said you want to provide something.
You, I have done this test, dumbass, and you can go out and do it yourself as well. Don't you understand that?
Okay,
Don't take my word. That's why you're a fucking dumb glober, because you took their word for it. You live on the ball.
I'm concave Earth, bro. I'm concave Earth. I'm not even a globe. I don't know what you're saying.
Concave Earth is even more retarded.
Okay, I mean, what you're saying might be true.
You don't have any experiment, do you?
I don't.
Yeah, so shut the fuck up then. At least I went out and checked my for myself.
Yeah, but you didn't take a picture of your setup. That's crazy, no?
I do have some pictures for it.
Like you were there to prove the craziest conspiracy in the world, right? And then you are like, I am going to disprove all physicists and all scientists in the world now, but I'm not going to take a picture, right? That was the idea.
I can take.
Okay,
I can show you some pictures. Fine, I'll show. I'll get some pictures for you. Here's the thing. There's a bar. There's a bar in the harbor down there. You see fucking the beach over in Copenhagen from Malmö.
Yeah.
You can Google Malmö Copenhagen pictures and you will see it right now. There's thousands of people who have done that. You should not be able to see that beach 10 miles away. If it's a ball. Yeah.
I mean, there is no Swedish science group who are actually saying we have like a phenomenon here. Maybe we should investigate it.
Why do I care
mean, why would you care about what you're saying if you're not providing your own data? We all know the YouTube videos.
I gave you a location. Go to Malmö, see if you can see Denmark.
We all have locations.
You don't live on a ball.
Congrats, you are capable of giving Google coordinates on Google Maps to show some fucking lake.
Now you have a place where you can go and
confirm. Everyone can do that, okay? Everyone can do that.
Where you can go and confirm that what I'm saying is true.
Okay, bro. I live next to the biggest sea in Europe, okay? I would have sea enough if I want.
Believe me, dumbass. Even if I showed you a picture or a video, you shouldn't believe me. You need to go check this for yourself.
Yeah, but you didn't. Just to make that clear, you didn't show video or picture what you take yourself. You didn't.
You shouldn't trust me. That's why you're.
You didn't take the most important day of your life where you can finally prove that the Earth is flat.
I go there all the time.
You didn't take a picture of that day, bro. You're just like, okay, I just keep my phone in my pocket.
Summer. I don't have to take a picture every time I'm there. Okay, I have pictures on my phone. I can just look.
But you took your laser and everything, and you didn't think it's like cool to take a picture with your laser at night and someone is 10 miles around.
I used a laser. I used a simple observation. I shouldn't be able to see the white sand over in Denmark.
Yeah, okay, bro. Let's change the topic, I guess.
For me, is 4.7 kilometers out. That's where the beach.
Bro, I was excited, honestly. I thought after 8 years being in this community, asking people to get data providing, and everyone is like, yeah, I did experiments. And when I'm like, can you provide data? And they are like, oh no, I can't. I thought you have data,
so many people here have provided you data. You won't go and confirm it, even if we show you pictures, which you should.
You are trolling. You have provided the geolocation. Oh my god, that's not data.
Yeah. Malmö, you go there. See if you can.
Guys, go to Malmö. Go to Malmö. Go to Burj Khalifa. Go to the top of Burj Khalifa and zoom in with a telescope to Saudi Arabia, guy. You can prove it there. Do it.
Flag in your profile anyway.
Unfortunately, no one of your flat earthers has ever done that. That's interesting.
Yeah, we've had enough of you.
Isn't this server awesome? Don't we just love being here?
What a dumbass.
Yeah, it was me. No, he's been around forever. That guy's a troll.
Incredible. Here's a picture of a unicorn. Now you have to believe me. Crazy.
Can't even spell losers right.
Yeah, it's a little bit more violent here than it is over on English Hub. But it is what it is. I think I just had enough of him.
Confirm. further steps toward.
Earth is round. Earth is round. Prove me wrong.
Yeah, I'll prove you wrong. If you have a second.
I got 2 seconds. Prove me wrong.
Yeah, I will. You have a look at the chat on the side chat then. We'll go over this. It'll take about a minute. Should be fairly
Alright.
quick.
I'm in the side chat.
Good. Copying some text here for you. We're going to read through this together. Super easy. There we go. Let's put a little picture in here. Pictures are good. It's a diagram. Do you happen to know the size of your ball?
Hold on 1 second. You said what now?
Do you happen to know the size of Earth, your sphere, your ball?
Yep, I do. But go on, I'm listening.
What is the radius of your ball?
No, just continue. I'm listening. I don't wanna cut you off. Just keep going. Keep saying whatever you have.
Fine.
I'm listening.
All right, so you can read along then. Look at the side chat. We have been told that the Earth's radius is 3,959 miles. Because this is the number, we can use simple math to figure out how much water needs to curve over distance. Do you understand that logically?
Mm-hmm.
I'm not asking you to understand the math, but do you understand the logic? Now, people who are smarter than me have done the math, even though I can do this. This is not that bad, right? But if you look at the picture down at the bottom, there's a diagram, and you can go in there and you can look how much water needs to curve over distance. Now, for 10 miles, that number is 66 foot. That's about a 6-story high building. So if you want to figure out for yourself if water curves, then you can take your friend, you bring him to a 10-mile wide lake. You have your friend flash a mirror from the other side. If you see that flash, it only means one out of 2 things. Either your friend is over 30 foot tall, or water doesn't curve. Which one do you think it is?
So based on your logic, the second one. But based on also the argument that you were giving me is also based on misunderstanding of geometry and optics. So I just want to give you some straight counter arguments if you allow me to. I don't know if you're okay with that.
Yeah. But what I mean is, like, you can see. I mean, maybe you use a telescope and then you see Jupiter, and then you see like the what do you call it? Like the eye. I don't know what to call it. Like the spot on Jupiter, and then maybe if you look at it another time of year, maybe you see another phase of Jupiter. Like, don't you think that's?
Do you see a different phase, or are you assuming and asking me if you see a different phase?
Yeah, well, I mean, I guess that's a logical explanation. Like it has different faces, right? Why would it change?
Listen, brother, you gotta understand. Even if the things in the sky, like the planets, are spheres, even if the moon is a sphere, even if the sun is a sphere, the Earth is still flat.
All right, but then why would they be spheres and the Earth be flat? Like,
because they're not related.
They're different things. Things in the sky versus things under your feet. You know what I mean?
Jim is saying they are, right?
They are not related.
I don't know.
The lights in the sky are not related to the ground. I don't look up at the lights in the sky and see anything that looks like the earth surrounding me. I don't see trees. I don't see rivers. I don't see animals. I see light. And they have a particular shape. That's what they are. I've only ever looked at them. I've only ever watched them move. I don't know what they are. I've never touched them, took a sample, or measured their size or shape. I never went to them, so I don't know the distance to them, but they're definitely not in a vacuum of outer space because that violates everything else that I experience. Outer space is fake. It is not real.
And how
only thing that is real is what's surrounding you right now. You and I having this conversation, that's reality. Outer space is not reality.
How does the GPS work then? Like, why does the GPS work then? Like,
because men have made a system so that we can travel. Because these methods that we've used throughout the years works. We've decided, hey, the lights in the sky are always doing the same thing in the sky like clockwork. So we're going to orient our ground to the sky.
Yeah, but like, how can you know exactly where you are at the one point on Earth? Like, how can your device follow you exactly on the map? Like,
well, if you're talking about your phone is using a GPS system, which is your phone communicating with towers and triangulating your location from those towers. Your phone is not using the shape of the Earth to give you GPS. It is giving your phone a relationship between towers which communicate with each other through a network that men have created.
All right, that works when you're like in a city or somewhere close within.
No, the towers are all over the Earth. They're everywhere, dude. They've been putting this infrastructure up for decades.
Like, what about the middle of the ocean? Like,
yes, there's towers in the middle of the ocean as well. There's even towers on top of oil rigs. There's beacons everywhere. It is a large infrastructure.
What about when you're in the middle of a valley? Middle of a...
They have the towers everywhere, and it turns out that sometimes there's places on the Earth where you cannot get a signal.
Yeah,
shocker.
And exactly, that's what I mean. And what about the satellite internet? Like, you can go to that place and have Starlink. And
it's weird. Didn't you just hear us tell you about the towers?
Yeah, but I mean,
okay.
If you're in the middle of a valley where you cannot have signal, like telephone signal or whatever, how can the internet, like the satellite internet, work? If
there's some places where satellite internet also does not work. I know this. You're hearing this for the first time. You think everything just works perfectly everywhere all the time. You keep asking these what about questions, and you're still forgetting the whole point, where the Earth is measured flat. Space is fake, and for your satellite systems to actually work the way that you think they do, the Earth has to be a ball. Since it's not a ball, it's not working the way that you think it is.
I mean, I'm just trying to get an explanation. That's why I'm asking.
Well, listen, bro. What explanation? Do you think that we're just going to all of a sudden give you every answer for every question that you have about this? There's some things that we don't know. What we do know is that the Earth is flat.
Well, yeah, I'm just trying to see if you know the answer. That's all I'm trying to see.
Well, I mean, after a while, I'm going to have to start charging you to answer all these questions.
Well, all right. Charge me one.
It's $1 million an hour.
Well, then I'm not gonna ask you, I guess, and that's it.
Okay.
I'm $5 now.
Jedi's a cheap whore. He'll answer anything.
Yeah. I'll give it away for free.
Everybody has a lot of what about questions, man. I get it. Don't worry. It's natural. The point is that, for the idea of the satellite being this piece of technology that's in the sky, tethered by some non-force force around a sphere, requires the sphere first. So if there's no sphere, then that entire idea falls apart. Now, do they have creative ways for communication, ground location, positioning? Yes, I'm very sure that they do. And it's probably way cheaper and way simpler than trying to put a piece of technology and tether it to the Earth using nothing in a vacuum.
You think that the membrane that's holding the air in is the same one that the satellites float on?
There is no satellites, bro.
The supposed ones, the ones like in...
Imaginary satellites?
No, like quote unquote in space.
There's no space.
Well, supposing there is.
Why would we go back to supposing that there's space when the entire concept is not physically possible?
It's possible with a membrane. A semi-permeable membrane.
So now you're going to create your own flat Earth model with a semi-permeable membrane? Okay, so what's on the other side of that membrane? And what's the membrane made of?
But what it does is it holds the air in and lets rockets and satellites out. And
oh my gosh, dude. Just stop trolling, please. This is ridiculous.
Right. Why did you say space is fake, though? I'm trying to understand that.
The outer space vacuum with all the galaxies and planets and stardust and comets and the crew of Star Trek, all of that violates natural law.
What natural law does it violate?
The second law of thermodynamics.
And explain what the second law of thermodynamics is for everyone in here.
I feel like you've been in here before. I'm sure you've heard this.
It doesn't matter whether or not. You should just be in it. You know it, right?
Bring us up to speed.
Bring us up to speed, like you said. Yes. Tell us what it is, and explain exactly why it's not congruent. I want to understand. Break down the science. Why is it that?
All right. So the second law of thermodynamics, entropy, states that high energy must flow to low energy. High pressure flows to low pressure. It's a direction of flow. It's essentially, and my best example of this is if anybody drinks coffee, you can set your coffee cup out in the morning. It's nice and hot. And as time goes on, if you're reading a book or the newspaper or looking at your phone, every sip that you take is a little bit cooler until eventually the temperature of the coffee is the same temperature as the room. You call it cold. It's probably in the ballpark of 70 degrees. It started out as 110. Now it's 70. That's because the heat from that coffee moves towards the surrounding air, which is colder. And it tries to heat it up to create equilibrium. Eventually it does. So when it comes to pressure, if you have a container with high pressure in it, let's say a bike tire, and you poke a hole in that tire, does the air go rushing into it or does air come rushing out of it?
High pressure to low pressure.
Yes, always. So, if there is high pressure on the surface of the Earth, and it is directly adjacent to an extremely large volume with an extreme low pressure, that air is going to try to fill the available volume to create equilibrium, meaning it will disperse freely and randomly in all directions, as we observe every time. That's why it's a law of nature. It always happens. That means that trying to create equilibrium with space around it would mean that the temperature or the pressure, which are about the same thing, are going to be the same at the surface as it is everywhere else in quote-unquote outer space, meaning that the surface pressure of Earth would be 10 to the negative 17 torr, meaning there would be no life, no water. That's the end of it. So outer space as a vacuum with all the stardust and all the cast of Star Trek does not exist.
But you're ignoring gravity, though, right?
What's gravity?
Gravity is pulling you down.
No, it isn't. I've never.
When you jump, where do you go?
Well, that's the violation right there.
Yeah, you've already violated it.
How so?
Because gas expands. It's the reason why it has the power of definite expansion is because the temperature, energy that it holds that causes it to move, and the last physical collision. Because of this energy collision relationship, gases have the power of indefinite expansion. You'll notice within the laws of thermodynamics, kinetic molecular theory, the ideal gas formula, PV equals nRT, there is no directional bias due to gravity. Things don't come back down to the floor once I've left them like gas. If they go in a direction, they're going to keep going in that direction until they have another physical collision. Please see what is cited in the side chat.
Okay.
But sorry, we're not forgetting gravity. What we're pointing out is it's irrelevant when we're talking about gas behavior and the laws that govern it.
It is relevant, though.
It is, sorry, when we state the laws that govern gas behavior, you are not going to find a G.
Are you looking in the side chat?
I am. Just give me a second.
You see those two containers, and there's a valve in between them, and there's a colored gas in the bottom chamber, and then the valve opens and it expands upward. Okay. Why is gravity not holding the gas down?
I mean, gas can move up, but I mean, as it moves up, I mean that's why, like, when you go up a mountain, the air is more dense, though closer to the ground, right?
Alright, that's you affirming the consequence.
What?
That's you affirming the consequence of formal logical fallacy. You observe a phenomena, the degradation of gas pressure with altitude, and attribute that phenomena to gravity without any proof that that's the cause. You just say it is.
You just told us that gravity holds gas down, and I'm demonstrating for you that that is not the case. You still have not even really defined for us what gravity is or what it does.
Yeah, but I mean, that's not the only, like, force, correct? I mean, in the GIF you showed, there's a vacuum, and as you said, it moves from low pressure to high pressure. You know, that force is obviously stronger than.
Yeah, the gravity would be much, much greater than the gravity, whatever that is.
Yeah, but this is like an example of diffusion, right?
Diffusion?
No, this is an example of entropy.
I mean, entropy. Sorry. No, because...
See, please see the videos that I posted, all marked
entropy, second law of thermodynamics. You might even see a black and white one with a guy in a fucking chalkboard.
Yeah. Okay, wait, Alan.
This is the simplest demonstration of this law of nature.
All right, but then, like, what about the experiments where they get a vacuum, like a chamber vacuum, and they drop two objects and they fall at the same time?
Okay. What about it?
So, well, if you put the air inside again, they're going to fall at different rates.
No, the gas is going to expand into the available space. You're not going to be able to drop from the top of a vacuum chamber a molecule of gas. Now, it might go towards the bottom because of its last physical collision, but when it hits the bottom, it's going to go up. And then the only reason why it's going to change its direction is because of its next physical collision. If you keep putting more and more particles of this gas into that container, you're going to have a container of gas.
Yeah, but you're still dropping the object, and one is going to fall.
But the gas?
What's up?
The gas.
What's up with the gas?
Yeah, you took all of the gas out. We're talking about gas behavior.
I know, but the gas interacts with the objects, the other objects.
Yeah, but we're not talking about dropping solid objects. We're talking about gas behavior. You took all of the gas out, and now we're not talking about gas. You've dropped to rock.
I'm talking about the interaction between the gas and the object. That's what we're talking about.
What gas? It's a vacuum.
Right.
Well, I mean, that's the experiment. First, you do it with the gas, or first without the gas. It doesn't matter. If you do it with the gas in the chamber, it's gonna fall. I don't know, if you drop a rock, it's gonna fall first. Then I don't know if the other. But if you drop them at the same time, when there is no gas in the chamber, they're gonna both fall at the same rate.
Exactly. So it has nothing to do with gravity then. It has everything to do with the gas interacting with the object, right?
Wait, but why do they fall the same,
Because you took the gas out. You're saying it, and it's like you don't even hear yourself saying it. You changed the state of the medium. You changed the density of the volume.
It's like you got a container of water and you put a balloon on the top of the water, and then you magically click your fingers and the water disappears, and then the balloon starts sinking. It's like, why has that happened? Well, maybe it's something to do with the medium that it's in.
But then, I mean, there are some gases that interact as well with the gravity, and they fall like.
Sorry, pardon? Which ones?
Well, I've seen some experiments with unicolor gas, or well, actually, it's in color, but you can see objects floating on the gas. Have you seen those?
Yes.
Yeah, for a short period of time, until the open container releases all of the gas into the environment, which takes time in this setup.
What's that called, Jedi?
Entropy?
Yeah, that's what it is. So then entropy takes place, and then the gas homogenizes with the other gas, and then the little tin boat falls to the bottom of the aquarium.
But would you say that gas in the container, would you say it leaves the Earth?
No, it homogenizes with the rest of the gas in the room.
Right. Yeah. The surrounding air that we breathe. That you dropped the, let's say, sulfur hexafluoride into the fish tank from one container into another, and witness over a short period of time the container on 5 sides being able to contain this gas for a short period of time, so you can float little tinfoil boats on top of it. Come back an hour later or 2 hours later, your gas is fucked off because entropy, right? Now, that sulfur hexafluoride, let's put it into a vacuum chamber. Oh, it fills the container evenly in all directions like all gas does. So no gravity pulling this gas down to the floor.
There's no gravity. Things go up and down depending on the density of the medium that they're in. If they're more dense than the medium, they go down. If they're less dense, they go up. It's all we observe. I couldn't even give you an actual cause for this. There's just a relationship. That's it.
I mean, I'm interested how, like, you can think of many things you cannot see, and I mean, would you say they do not exist just because you can see them?
You'd have to give me an example. You're talking about something like gas, right? Like, I don't see necessarily gas, but I do have an ability to detect gas, right?
But what about oxygen? Can you detect?
That's a gas. Yes, you can detect oxygen. It has a certain amount of charge to it, right? How many electrons?
But what is an electron, though?
That's a good question. I've never seen one. We just have these descriptions of things. We can detect it. We can't necessarily get a picture of it. You know what I'm saying?
Yeah, but how can you even detect it?
Sometimes it gives off a different flame when you set it on fire. Sometimes other things it will pop. There's loads of experiments going back to 200 years. The different types of what happen.
I'm talking about the electron.
Well, they just have a way to detect the charge from whatever the substance is. And that sort of is what identifies it. That's why you have the periodic table. They just count electrons, essentially.
I mean, that sounds kind of like something you wouldn't be able to see or measure with your eyes or with something in nature, you know? I mean,
well, not necessarily with your eyes, no. That's why we have very sophisticated equipment to sort of parse out what the stuff is that we're dealing with.
Yeah, but
now when it comes to gravity, there's not even anything anybody can point to as a substance, as a force, as anything. There's nothing that anyone can detect. So if there's nothing, then gravity is nothing.
I mean, do you know how, like, how do we know why electrons exist? Or how do we measure them? Because electrons have mass. Right? Are you there?
I don't know about anybody else, but I cut out there for a second.
Sorry, I had to do something. Was there a question? Take off.
Oh, I'm glad you came back. I thought I'd completely lost communication with everyone. Something about electrons, I think.
Riley B, did you have a question?
Yeah, no, I mean, I was just waiting for you to follow that up.
I had to step away for a moment. I may have not heard the follow-up question. Anyway. Yeah, no, gravity, as far as I'm concerned, does not exist. What we call gravity is a density medium object relationship.
Said electrons exist, right?
What?
You said electrons are that's how we can tell when gas is different from another.
Yeah, basically. I mean, you have your periodic table, and all of these particular elements have a weight, and they call it a weight, but it's really just more of a number of how they count. I believe it's electrons. Is that right? Yeah. Of the particular substance, and that's what essentially identifies the substance. It's not even really a weight. It's just an amount.
Yeah, but I don't know what.
Say again, I didn't catch that.
An amount of what? I mean, if it is an amount, like you have to.
All right, let's just. Right. Listen, I don't pretend to know how exactly the instruments that they use work, but they're detecting a charge on the substance. And the amount of charge that they get, they quantify that with a number. And that's what identifies the element. Other than, there's some other properties, obviously, but because they section everything off. These are the metals, these are the gases, these are the noble gases, and so on and so forth. So they file them in different categories, but they all have different quote unquote weights to them.
So, like, you're suggesting gravity does not exist, then you're saying it's the interaction between the gases that is.
No, I'm saying it's an interaction between the object and the medium that it is in. Take for instance, all right, this is a good way for you to think about this. Think of having a block of wood, all right? And you hold your hand out and you let that block of wood go. What's going to happen to the block of wood?
Yeah, if you can you read that? I lost you for a second.
Okay, so if you have a block of wood in your hand and you hold your hand out and you let go of that block of wood, what happens to it?
Yeah, it falls.
Okay, great. Now let's take that same block of wood and let's get ourselves some scuba gear with the gas in the tank. Oh my gosh, these trolls, man.
Yeah, I'm a troll. I'm a troll. You guessed it.
Anyways. You get yourself a scuba tank, you swim down to the bottom of a lake, you still got the block of wood in your hand, you're breathing because the gas is in a container, and you let go of that block of wood. Now what's it going to do?
It'll fall down.
A block of wood is going to fall down in water?
Well, it depends. I mean,
no, it doesn't depend.
Float up.
It's going to float up. That's what wood does when it's in water. Now, why does that happen? It falls in the air, but it floats and goes upward in the water. This is not difficult.
That's because
the water is more dense than the air. And the wood. Right?
Yeah.
Okay. So that's all we ever observe is a relationship between an object and the medium that it's in. If it is more dense, it will go down. If it's less dense, it will go up. That's what happens.
well,
It's kind of like mentioning earlier, somebody was talking about, maybe it was you, the bowling ball and the feather in the vacuum chamber. I think that's a great demonstration of exactly what I'm talking about. If you put the air in that chamber and you drop the balloon, or if you drop the bowling ball and the feather at the same time, obviously that bowling ball is going to get to the floor a heck of a lot faster.
no.
The feather is going to slowly drift as it moves through the air because of the friction and eventually reach the floor, well after the bowling ball. If you take the air out, yeah, they fall at the same rate. There's no air resistance. There's no fluid to resist the feather. Now, let's go the other direction. Let's fill that shit up with water. What is the feather going to do? It's going to go up with the water. And the bowling ball is going to stay on the floor. There's no gravity in any of this. None.
No, there is gravity in both cases.
Okay, show me where the gravity is. Where's the gravity? Why is the feather going up? What happened to the gravity?
It is still there.
Because
However, it is weaker. It is still there. However, it is weaker than the force upwards, given by the amount of water.
There is no force upwards.
There is.
Then how does it go up?
That's a good question. How does it go up? It just does. It's just part of the relationship.
Relationship with what?
The same happens with a boat. Imagine a big ship, for example, a big ship.
Yeah, right.
So if you fill it with water, it will go to the bottom of the sea. However, if you don't do that, it will float. So it's the same. It's the same object. Where is the gravity? You are telling me that in one scenario full of water there is gravity, and without water there is no gravity?
What? No, I'm saying there's no gravity, period. What are you talking about?
Okay, there's no gravity, period. So why then is going down?
Why is what going down?
You have a ship, for example. Okay, a ship which usually floats. However, imagine that you are filling the entire ship with water, and then it goes to the bottom of the sea. Why it goes to the bottom of the sea?
Because the metal is more dense than the water and it sinks.
It's made it non-buoyant.
Okay.
Yeah, you've removed the buoyancy of the situation, right? So now if you have just a regular old boat, which is steel, and it really wants to sink, but it's a basin, right? You've sealed off all the edges. There's a container to basically hold the gas. So part of the boat wants to sink, but then you have gas inside the volume, and it doesn't sink all the way.
Okay, you're talking about the density, okay? So the density of the metal makes it go to the bottom of the sea, correct?
Yeah, because it's more dense than the water, yes.
Yes, but it's the same ship. It's the same piece of metal. Why in one case it floats, in another case it goes to the bottom of the sea?
Because it doesn't have all the water in it?
Yes, exactly. Exactly. Right. So when you do the calculation, of the entire weight, in one case you have only the metal itself, Okay, in the other case, you have metal plus water, and then you calculate the entire weight of everything, and then it goes to the bottom of the sea.
No, it's not about weight. It has nothing to do with weight.
It has to do with density, correct?
Exactly.
So in this case, you have to take the metal plus the water it contains inside of it, and then make a calculation and calculate the entire density of the entire system. Yes,
exactly.
You have to do that. Yes.
Right.
So
hold on a second.
Okay.
Well, go ahead, Jedi.
I was just going to say you can calculate this because it's going to go down. Okay. It's not proving gravity. Just because you've got the boat going up and down when you change the buoyancy of the boat, or maybe you've made the water more dense because it's now like the Dead Sea and it's got more salt in it. All right, this is just going to be the object and the medium relationship. You, the researcher, are going to change one of the two, and something's going to change. Scientifically, it's that then what you changed is the cause, right? If we're doing this as scientifically as we can. What you changed, like the density of the water, made the object rise, for example. Or if you took the salt out of the water, the object sunk, for example. If that's all we're doing, then that's the cause.
What is the cause? Can you
you change? So the boat, for example, why it sinks when you don't make it buoyant anymore, the thing that you changed in the scenario is the cause.
Yes, exactly. So I'm putting another object inside the boat, which is a lot of water, and then it sinks.
Yep.
Yes.
Because the entire system, which is the boat itself plus the water inside of the boat, so this is the entire system, and this entire system has higher density than the density of water.
Yes.
Right?
Mm-hmm. And?
Yeah. Yes, okay. And then it goes to one direction, which is the bottom of the sea.
Okay.
So it goes to one direction. Why it doesn't go to another direction?
Don't know.
Why?
Dude. We don't know. Every single time we do these things, the object will either go down or go up.
Yeah. So why there is preference for going down, straight down? I would say, instead of another direction.
Don't know.
Okay, this is a good.
Just the way it is.
This is a good method to research.
Okay, thanks.
Yeah, people have been researching this forever, and they have not come up with any answers.
Have you got an idea as to why it goes down?
But you're saying so you're saying space does not exist, right?
Yes, that's correct.
Wait, but why would? All right, so to you, like for you, space is not even a concept, like anything possible, right?
No, it's only a concept. It only exists in the mind.
All right, and why would that concept be? Like empty?
I don't know. Someone made it up. I don't know.
Yeah, and I guess it's vacuum, right? So no particles or stuff.
Dude, right. I don't even know what you're talking about. The idea of outer space that we discussed earlier with all the supernovas and the galaxies and the space dust and the asteroids, all that stuff, it's inside the thing that's a vacuum. It's all nonsense.
I'm talking about, yeah. Okay, so, I mean, what about do you know how an altimeter works?
Yep.
All right, so it measures the pressure, right, of the air.
Yep.
So, okay, so when you go at sea level, it has some particular measurement, right? Then you go up on a mountain, and there's less air, right?
There's less pressure.
Yeah, and there's less pressure and less gases, right?
I don't know if they're completely attached at the hip, but go on. Yeah, you've got less pressure.
Yeah, and less gas, because you go up in a mountain, what's going to happen to you? You're going to have problems breathing, right?
Yeah, because there's less oxygen. There's the same ratio of gases, oxygen and nitrogen, it's just less of it per space.
Yeah, right. So it is a pattern, right? It's decreasing the higher you go, correct?
Yes.
Yeah. Right.
Wait, no or yes?
Yes.
Yes.
Okay, so if you go even higher, you can assume there's gonna be no gas, right?
I mean, you can go real high and there's still air. So I'm asking you where this air pressure is coming from. How do you have gas pressure without a container?
Well, yeah, but how does that even happen then? Why does the pressure?
No. Well, most of it has to do with temperature. They're kind of locked at the hip. Plus, most of the gas that we breathe is all circulated down here at the lower levels. But everywhere that people live, there's gas.
What do you mean? There's gas?
There's air for them to breathe.
It's produced on the surface and within the surface of the Earth. Chemical, biological cycles like oxygen cycle, nitrogen cycle, photosynthesis, all takes place on and within the surface of the Earth. So just don't be surprised that there's more gas where the gas is produced and cycled. Right? It also goes back into the Earth, absorption, for example.
Yeah, correct. But still, the altimeter is saying the pressure is lower. It's not only
So we understand the cause of pressure is the force the gas exerts upon the walls of its container. If you want to have a gas pressure gradient within inside a system, you just muck around with the temperature and maybe put some gas in and take some gas out from time to time.
But
it's a dynamic system we live in, dude, is what I'm trying to point out.
Yeah, but I mean, it is colder on top of the mountain. It's not
exactly.
The pressure is not like, it's not going to be dropping down to zero because of heat. No, it's freezing cold.
Okay, so temperature, like Cecily pointed out, and gas pressure are kind of locked to the hip. Because temperature, whatever it is, hot, cold, whatever you're going to say that is, it's going to make the gas move more or less, which means more or less physical collisions, which means more or less pressure. If you're talking about the worldly environment, you've got to take every single factor into account. Temperature, where the gas is produced, how it's cycled, where the temperature predominantly is, where it isn't. Right? We don't have layers of gas, right? As I pointed out, when you go up to the mountain, you've still got the equal ratio of nitrogen and oxygen and all of the other gases. They're just dispersed more.
Okay, but then still, you're not explaining how they're, or well, at least I'm not.
I can give you a demonstration of a gas pressure gradient with inside a container just by very manipulating temperature at one end. Understanding temperature is going to make the gas move faster, causing more collisions, i.e. more pressure. At the other end of the container where it's colder, not as much energy given to it by temperature, it's not moving as fast, less pressure. It's really simple to understand, dude. If you're trying to say, well, we go up a mountain and there's less pressure, that's because of gravity, that is, then you're going to have to demonstrate that. Not just point to it and say, this is because of gravity. We require an experiment where gravity is manipulated to cause that phenomena that you keep pointing at.
Well, no, yeah.
Go
on. I'm saying not proving gravity, just saying the point that the fact that he said, or I don't know who said that space was not real, was not a thing.
It's not. Because the gas that you're breathing would fill the available volume, would it not?
Well, and then why is the pressure lower at the height of the mountain?
Well, there could be multiple factors, but we've already discussed a few of them. It just seems like you're ignoring them because you're way fixated on the fact that there's different pressures at different altitudes.
No, I'm trying to understand. I don't know if you can.
Well, then okay, so if you're trying to understand, we've already explained this to you. What did we tell you?
Well, could you walk me through it again, please?
Could you at least tell us that you weren't listening?
Yeah, I was, of course. I'm here.
I wasn't. Sorry, I wasn't. I was out for 5 or 10 minutes. Can you please explain?
So the gas is being circulated at the surface of the Earth.
Okay.
Most specifically, the most oxygen that we get is from the ocean, the phytoplankton in the ocean. Most people don't even know this. They always think about trees, and then they think that trees turn carbon dioxide into oxygen. It's a little bit more nuanced and complicated than that. There is a cycle going on, and it has to do with photosynthesis most specifically. So this is where all the vegetation is, and where all the surface area is, where the gas is being circulated. That's where the most of the gas is, and that's where the most of the pressure is, because this is where the gas hangs out, gets cycled, gets used, gets pushed around, creates weather systems closest to the surface. The pressure decreases as you go up. You'll also notice that the temperature also decreases as you go up. Several reasons for this. Not as much surface area to heat up to create the pressure, excite the gas molecules and make them move faster. Right? So we all understand this. This is the observation. This is what happens. This is what's going on. That's why you have more pressure at the surface, especially lower altitudes, than you do at higher altitudes. Higher altitudes, typically less surface area, less vegetation, really far from the ocean most of the time. So you're going to have less the higher you go. That's just how it is.
Let me see if I understood. You are saying that the pressure is higher at the sea level, for example.
Yep.
Because the observer is closer to the sea, closer to vegetation, which is producing oxygen.
And also closer to the surface where the sun is heating up the surface, right? And that energy is transferred from the ground to the air. The air moves faster. It gives you more pressure. It's always attached. Higher pressure, higher temperature, usually locked at the hip. Lower pressure, lower temperature. Lower temperature, lower pressure. It's all the same.
Lower temperature, lower pressure.
Like using your logic, wouldn't it also mean that there would be less pressure in landlocked or areas away from the ocean?
No.
Yeah, because you said most of the oxygen is produced in the ocean.
That's the oxygen.
They are oxygen rich environments.
But
hold on 2 seconds, Fordo, they are oxygen rich environments. So if you go out to sea, that's good fresh air that you breathe in. You go into a forest, right? That's good fresh air that you breathe in. Right? Depending on the local environment, I'll give you that you have local phenomena. But on the worldly scale, where we have winds, we have so much volume of gas in the first instance, dude, that obviously it has been spread out over an awful lot of time. This is entropy that has taken place, right? The mixing of these gases.
Exactly. Exactly. That's yes. So it's spreading. So use it from winds and everything. So then what's holding them down? What's holding them closer to the ground?
Nothing's holding them down.
A container is holding them in their volume.
Well, yeah.
What? You just said that, like in the middle of the ocean, it's being like the what was it? Like the oxygen is spread with winds and everything, right?
So when the gas is produced from the surface, it goes up into the environment above the surface, and then moves around in that environment because of all the collisions that it has. Yeah.
Yes, it's moving and spreading from all the collisions. Okay. But then there's more air or more oxygen, at least there's closer to the ground.
The concentration of oxygen, in my opinion, is going to be a little bit greater in the places where it's cycled most efficiently. But however, for the most part, it is being homogenized. It's always mixing. As soon as you get away from the surface area that is being radiated by the sun, when you go up in altitude, now the transfer of energy becomes less and less the higher you go. So you're going to have less pressure, less excitement of the molecules as you ascend. This is all very consistent. This is what's observed. This is not our logic. You said our logic. No, this is just what's observed. This is all in the gas laws.
Yeah. Wait, could you repeat the part as you go up? I think it was cutting.
You understand if you heat air, it moves faster and typically wants to go up, right?
Right.
Now, energy can be transferred from one molecule of air to another. However, there's going to be a decrease in the energy between both the atoms because it's sharing energy as it goes up, right? So entropy is going to occur. The warm air is going to begin to try and cool and warm up all the cool air above it. So then it gets less and less in pressure, slows down, and as the temperature decreases, as everything goes up, the pressure decreases as everything goes up.
Okay.
So I'm pasting the ideal gas law onto the chat window. PV equals nRT.
Awesome.
Yep.
Okay, so there are many things. We're discussing many things here. I'm a bit confused. So we are talking about different pressures. So we are talking about on the left side of the equation. We're talking about a bigger number or a lower number, assuming that it is the same volume, correct? Are we assuming that the volume is the same on sea level and 1,000 meters high? Is it the same volume?
Has a volume. Don't know what the volume is. Don't know whether the volume acts like a balloon and expands and contracts. But if we're going to use the ideal gas formula and we're going to look at the P and the V, we understand that the pressure is the force that the gas exerts per unit area on the walls of its container, and the volume and the V is for the volume, the three-dimensional space the gas occupies. So the gas is occupying a three-dimensional space and it's enclosed on all sides.
Correct. Cool. So we take a device which has a given volume, and then we measure the pressure of the gas at sea level, and then we take the same device, we don't touch anything, we just move the device to 1,000 meters, whatever, okay? And then we measure the pressure. Is that what we are doing, correct?
Yeah, all we're doing is measuring different pressures with altitudes.
Yes. So we don't change the volume. We just move the container to a higher temperature, correct?
We do lower temperature. The higher temperature is at the bottom of the container, so it decreases. Temperature decreases with altitude. The higher you go, the colder it gets. Subsequently, pressure reduces with altitude too. There is a relationship, as you notice, within PV equals nRT. The T stands for temperature.
Yes.
That's very important.
Yeah. So the temperature is different.
Mm-hmm.
Okay. Okay. I'm okay.
And correct me if I'm wrong, Jedi, but the ideal gas law essentially is treating it. It's ideal because it's kind of assuming like an isolated system, right?
Well,
yes.
Yes. Yeah, a closed system, not isolated, closed.
Oh, okay.
I guess if you're talking about an isolated system, it's because there's no extra energy coming from the outside. Right, and coming into the system and heating the system up. I can't remember which law that is, but the temperature variable in that's where we're increasing and decreasing. I don't think it matters if the temperature is coming from internally or externally. Within a closed system, the temperature is still going to be able to enter and leave. Ideal or systems like you mentioned are kind of hypothetical, right?
Yeah.
Okay, but we can assume that near the surface, the temperature will be higher because the surface reflects the sunlight and then heats up the gas, correct?
We can assume that to make things simple, yeah.
Yeah, okay. So this is why the temperature is higher. And then taking out other factors, because the temperature may be higher on a desert, but lower if there is vegetation, etc., or water.
Well, yeah, exactly. At the same altitude on the surface of the Earth, desert, or it's hot, or Antarctica or the Arctic where it's cold. Still at sea level, but you can still have varying temperatures and relative to the same pressure. So temperature isn't always the variable. You have to understand that the system is already working. Entropy has already taken place. All right, the gases have already mixed. We're already here within the system that is already working. Right. We have to understand that the churning of the atmosphere and how the temperature is moved by how the sun moves across the earth, that's been like thousands of years, let's say, already happening, dude.
Okay. So the question here, so basically we were, okay, why we're discussing this? Because we were discussing whether or not this proves or not gravity. Correct? That was the.
So this was brought up because Says Who said that the vacuum of space violates fundamental laws of nature. The one that we're discussing is gas behavior and entropy. Now, according to those laws, the one that you wrote, the one that you popped down, PV equals nRT, you'll notice that gas pressure is caused by the gas hitting the walls of its container. In the heliocentric model, there's no container surrounding the Earth, so there's nothing for the gas to press against. According to the second law of thermodynamics, gas expands into available volumes. So if there's nothing stopping the gas, a container, between us and the vacuum of space, entropy will dictate the gas will fill the space. Exactly.
It should escape, yes. Which is what people say about Mars, correct? People say that in Mars you have a okay, you cannot breathe in Mars because there is no enough oxygen, okay, but also because the pressure is very low, isn't it? Something like that. There's not sufficient air to breathe.
Well, the story about it.
Suppose that you believe that people sent equipment to measure that in Mars. I'm supposing that. I don't know if you guys believe that.
No, Mars doesn't exist either, and not in the way that you think. But continue.
Okay. I'm not going to that. Otherwise, we will get to a tangent. Let's go back to this.
Right. Continue. Yeah. Let's pretend that there's some kind of device on Mars measuring pressure that is supposed to be like it's like 1% of the Earth's pressure. Right.
We don't need to pretend that. We just need to think about what would happen with Earth if the atmosphere escapes.
Well, the pressure on the surface of the Earth would be 10 to the negative 17 torr. And there would be no moisture on the surface.
Okay. I can understand what you say. Okay, I can imagine. Okay, even though I don't know the unit you are mentioning, but that's okay. Okay, and then another question, which is what would be the velocity of that? Let's say that the atmosphere escapes from Earth. That would be immediately instantaneous or not?
Well, let's think of it this way. So, supposedly, right, there's a story about a Big Bang theory out there, and everything came from nothing that exploded 13.4 billion years ago. That's the story, right? And then all this gas and all this rock and everything was really hot because of the explosion, and that's where all these planets and galaxies come from. And so the Earth, right, was this big rock that was molten in its early stages because it was really hot from the explosion, but it was apparently cooling, which I find to be interesting. It's been cooling over whatever 4.6 billion years, however old the Earth is supposed to be. Well, if it's cooling, that means that the energy and any gas that might be present is leaving the surface and going out into the volume of outer space, which is supposed to be an extremely high vacuum, higher than any vacuum that we can create on Earth, by the way. 10 to the negative 17 torr. You may look that up later. But if that's the case, then at no point in all of this cooling could there ever been pressure built on the surface of the Earth at any time, no pressure, because as soon as the gas leaves the surface, it's going out to fill the volume, right? So there can never be any pressure on the surface of the Earth.
Okay.
Never.
Okay. Okay. So, okay. When I say okay, it means that I understood what you said. It doesn't mean that I necessarily agree, but we don't need
if you understand
disagreements. We don't need to discuss disagreement. I have another question. What is the sun? Is the sun basically a big ball made of hydrogen?
It's a light in the sky that seems to give us a lot of heat.
Yes, but
when you say hydrogen, what state of hydrogen do you mean?
I'm asking basically what the sun is made of.
Sorry, my friend. To be clear, hydrogen can come in many forms. I'm just asking.
Yeah. I know. But I'm asking, what the sun is made of?
I've no idea. Might be hydrogen. That's as best as I can give you.
Okay, roughly. It doesn't need to be any super accurate answer. What would it be mostly? Hydrogen?
Maybe.
Oh, yeah.
Okay.
But
but
not gas or not plasma. Might be a liquid hydrogen. Maybe. I don't know. Spectrometry is like not really that accurate when we're looking at like things in the sky and stuff. But if that's the best we got, maybe hydrogen. Maybe.
Okay. Let's say that it is a given percentage of hydrogen. More than 90%. Whatever. It doesn't really matter. Okay. Is this hydrogen escaping to space
like gas?
As well?
Like gas?
Yes.
I don't think it's gas.
You don't think it's gas?
Yeah, remember I said, don't think it's gas, don't think it's plasma. Gas, hydrogen can come in many different forms depending on its temperature and pressure. So it could be a liquid metallic hydrogen, for example. Some people suggest this. It's interesting. I don't know.
Okay. Doesn't really matter what it is.
No.
Can be plasma, can be whatever. It doesn't really matter. But the point is, why it is not escaping onto the space, whatever state
it might not even be physical.
Yeah.
Well, what do you mean by not physical?
Well, the thing about the sun is that it's always at an apparent location. There is no way to actually determine the sun's location from the Earth, like where it would be in the sky. No way to know that. So,
tomorrow can point a telescope to the sun, then you find the sun there.
No. What I'm saying is that we see the sun in the sky, but that is just an apparent position, meaning it looks like it's right there. Now, I wouldn't know a way to tell you how high it is, how big it is, what it's made of, or even if it's a physical object. That's how mysterious the sun and the moon and the stars are. It's also very interesting to find that people who do extremely high altitude, like high altitude balloons, even Jeff Bezos's flying penis, when they go really high up, the blue sky goes away and no stars can be seen. You can see the sun, sometimes you can see the moon. No stars in that blackness can be seen. Now we can see them from the Earth, but it seems like the higher you go, and there is a limit to this, all of a sudden you can't see the stars. So even the stars themselves are in apparent positions.
Oh, that's interesting. Can you give me a link to that or? Okay, you are already pasting, correct? Okay, great. I'll have a look later. Great. Do you know if this kind of observation, or better saying, not observation of stars, is it during the day or during the night?
I guess that's hard to say, because if you put a camera on a weather balloon, it could be in a place where it's nighttime, or it could be in a place where it's daytime. However, the same phenomena occurs where at a certain altitude, the sky or whatever is black.
Right? That's interesting.
So,
okay.
Yeah.
Nice. Okay, I will have a look at this later. Nice.
These are not the links for that, but let me see if I can find some high altitude balloon footage.
Oh, that's interesting. Okay, but we were discussing. Okay, so I asked I asked about the about the sun, the hydrogen, and why or if
Can I
it is
just
escaping.
can I just pull you up for a sec? Like, it's not really our primary focus is like to give you answers to life, the universe, and everything. Our main focus is on the surface geometry. Like, so when it comes to like answering the sort of questions that you're asking, like what is the sun and everything, it's like, well, it's not really what we're here to do. It's not what we're offering you. It's not the sort of information that we're offering to people. Like, it's just going to be a speculation. And we'd also challenge everyone else that claims they know what those things are or the answers to those questions. We'll challenge them. We'll say that they don't know, that they think they know, but they actually don't.
And if they present information given from satellites, you turn it down because you don't believe that people are launching satellites, correct?
I have no way to independently verify that.
Okay. What would be necessary for you to verify that? Is it possible for you to verify that?
The thing that we would have to have. Yeah.
Sorry?
The thing that we would have to have for the satellites that you're imagining, right? The space technology that orbits around the globe, you'd have to have the Earth be a sphere first for that to be the case.
Okay.
So if the Earth is not a sphere, then your idea of the sky technology is debunked. Now, is there sky technology? Yes. What is it mostly? High altitude drones, high altitude balloons.
Okay, so we are saying that the GPS is high altitude, whatever.
No, I'm not even saying that. Most people don't understand that.
I'm asking
GPS or global. Right, I know you're asking. GPS, although people think it has something to do with technology in the space, like 90% of your ground positioning, if not more, is all tower based on the surface of the Earth.
Okay.
So, space satellites to kind of triangulate your position on a sphere is all kind of silly and debunked. It doesn't work that way.
So we'll talk about cellular or mobile towers locating, giving a position, correct?
Yeah, mostly. I mean, for the end user, the people that have their smartphones, they're using cell towers almost primarily. But the signals that they do send, even from your phone, can be using, proprietary GPS as well, ground positioning through towers.
Okay. And what happens if you go to the middle of the desert, very far from anything, no mobile signal, and you still have?
Yeah, well, there's still towers out there. There's still towers out there. There's towers out in the middle of the ocean.
Towers in the middle of the ocean.
Yeah.
Transmitting cellular data. Why you cannot call people in the middle of the ocean?
Well, sometimes you can, but
maybe your device doesn't have enough signal strength because of the power occupied within your device.
Okay. You don't have enough signal for keeping a conversation, but what about positioning? What about your coordinates? Do you have enough signal to give you a position?
You might have if you're out to sea buoys that send and receive signals. You may have, if you're local to land, you might have things up in the sky. Things that just repeat signals, right? So an aircraft that's going overhead.
But what?
a geostationary balloon, for example, meteorological station.
Okay. But why they are repeating positioning data, not voice or some other kind of data?
Because all they require is one small signal. It's a ping, and I don't know what frequency that they broadcast these pings at, but it's not a lot of information. It's just a beacon. It's just a tone, essentially. And that tone can travel much farther, not near as much information required, and it can be repeated or amplified, whatever they need to do to triangulate or trilaterate your position.
Okay, you are talking about, for example, short waves. People using amateur radio, for example, using short waves and transmitting data over very long distances.
AM, yeah, VHF, LHF, yeah.
Okay, why we are not using this for transmitting voice when we are using mobile phones?
You'd have to ask the manufacturer. I think it's because of development of like 4G to 5G, the waveband is like really, really tight. It requires a lot of energy to get that tight waveband dispersed over a lot of area. That's why we have more and more towers around, because we need more energy for the signal.
I understand. So in this case, if I take a mobile phone and I disassemble it and examine the circuitry, etc., I should find two kinds of circuitry. One for 4G, 5G, etc., and another for short waves in order to obtain location, correct?
Yep, depending on the device.
Okay, can we find that? Can we find the circuitry involving short waves in mobile phones?
For what end?
In order to receive location data, because you are saying that we can obtain location data in the middle of a desert or in the middle of the ocean.
Someone's at the door.
Not here. No one at the door here.
I thought that was you. Sorry.
No. Someone else. Yeah. So my question was, okay, let's say that in the middle of the ocean or in the middle of the desert, very far in the middle of the Sahara Desert, okay, very, very far. Let's say that we get positioning, okay, location positioning, but we don't get voice, we don't get any other internet or whatever, other data. We get only positioning. So the supposition we have here is that we get positioning because two possibilities. One is there is a repeater in the air, there is a balloon or whatever in the air repeating signals. This is the first supposition. The second supposition is because the mobile is able to receive short waves, VHF, whatever, UHF, whatever, and then this signal transmits positioning. These are the two possibilities we're covering here.
We can be all of them.
Okay.
We can have things on the floor and things in the sky, all at the same time.
Yeah, but the core of the questioning here is why we are getting only positioning, not voice, not internet. Because internet is so useful. Why are we not getting internet?
All right. Bro, listen, we're going to have to actually switch the topic to something more pertinent, like, the fact that the Earth is flat, to try and figure out exactly how all these GPS systems work, why they use the technology that they do, how it all works. Not really the topic of the server or this channel.
I don't really understand, because with due respect, okay, I don't really understand, because one explanation, which is the common explanation, and everyone here already heard about, is that we have geostationary satellites around the Earth, which are transmitting positioning.
Okay.
And this circuitry or this channel and this channel is apart, is separated from voice and the internet. This is why this would be an explanation why we get positioned in the middle of the desert or the middle of the sea.
Are you under the impression that internet is delivered via satellite?
He's put us in a position where he's taken us away from the towers stuff, right? So we're in the middle of a desert. We're going to be away from the towers that says the only access he's going to give us is from the sky, right?
Oh, yeah, that's fine. Yeah,
you
can do that.
Yes,
on a flat
yes.
Okay.
In the middle of...
So and I want to follow you because I want us to give you a decent answer. So in this instance, we must and can only get a signal from the sky, right? Now you mentioned a balloon earlier, right? What do you think a satellite is? Is it and can it only be a thing in orbit around a sphere, or can it be something else?
Could be a balloon. Could be a balloon. I can I can accept the idea. Okay, could be a balloon. Yes, could be maybe flat, Earth is flat and there is there are several balloons on top of that at a certain altitude, and they are transmitting positioning data or whatever. Could be that.
Because the reason why we say, yeah, definitely could be this is because we've got images and NASA admitting and talking about the history of using balloons to put payloads underneath and put them up into the sky, because helium's relatively cheap, even though we're running out of it. And it's basically the same premise of, meteorology. Stick something up into the sky and measure and observe from high altitude. In this instance, you can put a repeater, something that can receive a signal and send it on its way again. Now, we can do this with lots of different technology. We can and have done for over 70 years, 80 years, done it with balloons, maybe longer now. Aeroplanes, they've also got computers and devices on them which communicate between each other, which can be used to relay signals. We have military balloons that they talk about that have a high field view over the theatre they're observing. We have things that are called satellites, which appear to be something that you're pointing at. Now, maybe there is something that's a satellite that's in the sky, a metal box type device that isn't on a balloon, but it doesn't necessitate that the object is falling around a sphere to keep going on its way. Now, the reason why I bring this up is because if you actually went on NASA's website, like nasa.gov, and looked into how they keep satellites up in the sky, it's not necessarily due to the gravitational speed and falling around the Earth. They've been doing things called dynamic electric propulsion, which is basically, because there's a high magnetic potential high up in the sky, if you put like an aerial that's made of aluminium and you travel through this intensely charged area, you start to attain voltage. Because of this, you can either attain energy or potential motion. So it's very possible that the things that they keep up in the sky are only kept there because of the electrodynamic potential that's high up in the sky. Now, the only reason I'm saying that is because that's what NASA says. This is not, something that I believe. It's just look on NASA's website and you'd find electrodynamic tethering. So the only reason I bring this up, dude, is just because we get signals in deserts and out to sea and they come from the sky doesn't mean that because they come from the sky that the Earth can only be a sphere.
I fully understand what you said. I fully understand what you said. The point is, how can we, for example, if someone says, if a company says, or if a government entity says, we launched, let's say, 50 balloons and we are transmitting satellite, we are transmitting positioning data Okay, how can you tell it is true? How can we investigate if that information is true or not?
Are you talking about balloons, or are you talking about the idea of the satellite around a globe?
I'm talking about balloons. If someone says that, how can we investigate if that is true?
Well, I don't know. I mean, I could probably try to go get one of those balloons, although I'd need a lot of money in a pretty fancy airplane, and then I'd probably get shot down because that's their stuff and it's not mine. Right?
Okay.
So where the signal's coming from, a lot of the time, there's no way to know. Like, it's over the air. You can't see the signal. Sometimes, sometimes you can sort of triangulate or figure out where the signal's coming from, but I don't have the means to do that. What I do have the means to do is to measure the surface of the Earth and find that it is indeed flat. I really don't care what they're doing as far as the data or the positioning technology that they have. Because as an end user, I just use it, right?
Okay, right. Okay, I understand. I understand what you say. Okay, so maybe we should move from this investigation to another investigation. Maybe another path, another investigation would be more fruitful, because this path is unfruitful because we don't have ways to falsify the information. If someone launching satellites or claiming, if someone claiming launching satellites are lying, or if someone claiming launching balloons are lying, we don't have ways to test, correct? So we should forget this, we should ignore this and move on, move to another investigation.
That's very wise.
Right. So what we can falsify is an Earth radius of 3,959 miles, because there is no Earth curve to be measured consistent with that radius.
There is no Earth curve? How can this be demonstrated?
Well, I think it'd have to be more so demonstrated that there is Earth curve, because you and I, everybody that works for JAXA, NASA, Lockheed Martin, you name it, any aerospace company, right? JPL, anybody who builds bridges, large infrastructure projects, roads, railroads, huge warehouses, airports, the people who navigate, everybody measures the Earth to be flat. So I'm actually hoping that someone can show me where I would be measuring any Earth curve.
That's interesting. Okay, so someone is posting here, Finland laser test proves Earth is flat. Okay. What is this about? Is it someone launching? I cannot watch now, but I will watch later. I saw. I'm sorry for that, okay? I saw a video on YouTube, okay? I'm sorry for that. YouTube is not a good source of information. But anyway.
I disagree. I think YouTube is an excellent source of information.
I think
sometimes it is, sometimes it's not.
Depends on where you go.
Sometimes it is, sometimes it's not.
I appreciate, my friend, that you noticed the laser tests that I was putting in the side chat. You asked, how do we demonstrate this? By measuring, using devices like lasers over the surface of the Earth to see if there's any curvature, working on a direct line of sight or not premise. If the surface was flat and you had the laser and the target at the same height, you would have a direct line of sight to the target and a parallel between the laser and the surface. If the surface was curved over distance, the laser would pass over the top of the target. You would effectively be a tangent on a curved surface. This is basically what we're measuring. Using this premises over distances of, let's say, up to 50 kilometers is probably the best distance I can reliably give you. We have a direct line of sight between the laser and the target.
demonstrating that the surface of the Earth is not curved.
Okay. Okay, I understand what you say, and I saw the same. I saw a video about the very same subject, showing it is curved. Okay. The point is, can we repeat the experiment and
yes.
we ourselves do that? So,
yes. So before you continue, would you be able to tell me who made the video or where you saw it and what it was? Was it actually a laser test? And can you describe it to me? Who did it?
No, it wasn't. It was a laser test. It was observation using a telescope. Using a small telescope, not a big one. Okay, but it was a small portable telescope. And so they were observing, for example, which part of a ship you see when the ship is very far, kind of 10 kilometers, 20 kilometers, whatever. Okay. So maybe we could repeat the same experiment. Okay. Maybe we could, for example, take a ship and then there is. Sorry for my bad English. I do not have enough vocabulary on this thing. But anyway, you have the ship and then you have a big piece of wood in the middle of the ship. I don't know the name of that. Okay, and then we fire a laser on that when the ship is very close to the shore, and then we'll be able to do that, obviously. And then if we try to do that when the ship is very far, what happens? So. Maybe we could repeat the same experiment and see what happens. Why I say that? Because apparently the same experiment, there are people claiming one result and there are people claiming another result.
Well,
you see?
What you'll have is anti-flat earthers or propaganda using badly constructed laser tests or observations to try and defend the observations and measurements that not only flat earthers make, but are made by everybody across the earth all of the time, using the devices that we're using. So that what you're seeing is propaganda, my friend.
Okay. So can you point me to your propaganda? Okay.
Yeah, I've posted some of it in the side chat, and I tell you what, I can go and find some really high-end stuff as well, done by not flat earthers, but because of what they did, they're flat earthers now, which is, I always find that quite interesting. So the conversion process. But yeah, I'll see if I can go and find you those ones as well. But this always comes down to this, friends, right? Don't believe anybody that you hear on the internet just because it sounds good. You, if you can, should go and be able to repeat what is done. Try and keep this as scientific as possible, because if it's true, it should always be repeatable.
Exactly. And
cool.
Let me tell
I'll encourage you to do that then. That's the best thing to do.
Yes, exactly. And let me tell you, I'm here with the highest level of respect possible, imaginable. Okay. Because I really think that you guys are really into scientific investigation, and this is really good. And I find that it's really good. You are challenging the status quo. You are challenging, the system. Let's put it this way. Challenging everything and willing to do your own experiments and find reality. Okay, so I find that this great. Okay, so I have a enormous respect here, even though my position is opposite to the position of you guys. The scientific investigation you guys are doing, the skepticism you guys keep is really beneficial for humanity. If everyone would be skeptical like you guys are, I think that we could get rid of many illusions humanity has. I find this great. Can you? Okay, there is this Finland laser test. Should I follow this, or is there a better article or a better video, whatever?
Well, from my personal opinion, it's always good to look at different people's results based on they're trying to do the same repeatable thing. Maybe with a different standard of laser, maybe with a different distance in mind, but ultimately trying to repeat the same premise. I've posted 4 for you, I think. So in your own time, some of them are longer than others. I do apologise for that. But look through all 4 of them and, add them together and see what conclusion you reach. Because when I was looking through the library just a moment ago, I lost count at 30. So I just got you what I think are good ones. There are better ones in there, maybe. There are longer ones as well. But yeah, there's at least 30 I could give you. But I think I gave you 4. Just start with those, I think.
That's enough. That's sufficient. Okay, my friend. Thank you very much. Thank you very much. It was a very interesting conversation. It was really great. Thank you very much for your time.
We appreciate you. You're welcome back anytime, my friend.
Okay, thank you very much. I will have a look later. Not now, but I will have a look later.
Yeah, in your own time.
Thank you.
Yeah, no worries.
Thank you.
Bye-bye.
Thank you, guys. Cheers. Bye-bye.
Turn to this question. Anyone here?
Yeah, we are. We're just really slow, but we are here.
Fine. One question I had since I joined is, wouldn't your model imply like an edge of the Earth? Right.
No. What do you mean by our model?
I mean, it's flat, right?
Yeah.
So what do you get? So what happens when you get to the end?
I don't know.
Okay. But okay.
You seem confused by my answer. It's really weird. I don't understand. I can't tell you about something that I've never experienced.
Okay, for example, yeah, but you can fly around the world though.
Yeah.
Right?
Yeah. I can walk around my living room. I can jog around my park.
Yeah, but that wouldn't be possible if it was flat though. So for example,
I couldn't jog around my living room and jog around my park if the Earth was what?
No, that wouldn't be possible if it was. No, I mean it wouldn't be possible to fly around the Earth if it was flat.
So you couldn't fly around in a circle if the Earth was flat.
I mean around though. So for example,
around. Around. Yeah.
Yeah. So for example,
in a circle.
Okay. Yeah, around the sphere.
No, you're saying that you can't fly around in a circle above a horizontal flat plane, which seems weird to me. Have you ever got like a remote controlled like drone or helicopter and stuff, like the small ones you have in your living room and shit, and like it's flown around in circles?
Okay.
Yeah, cool. Is your living room now a sphere?
Okay, let me give you an example of what I mean.
Okay, cool.
So for example, if you fly from like Europe to East America, so
okay, so traveling west,
like maybe like somewhere in the and then you go to and then you fly again to maybe to the
California.
West. Okay, yeah, California. So, for example, you go to Massachusetts, and then you go to California. And then if you fly again to your initial destination, okay, then presumably it should take it should take more time, right, to go back.
What?
Like, wait, let me think if I get it. Like, for example,
at the moment I was with you, we left Europe, we travelled west across the Atlantic, we got to the east coast of America.
No.
Had
let's
some
start
bagels.
even. Okay, let's start even like east. Like, for example, let's start
east.
your initial place. You were initially in Japan. Okay.
Yep.
Okay, in Japan, and then you fly to maybe France.
Okay. Which way?
Okay. West.
West.
Okay. And then you flew
so
again
across China, across Asia, to Europe,
right,
and then France.
Correct. And then you went even more west to the eastern region of America, maybe Massachusetts, for example, and then
New
you
York
flew
for
one
bagels.
more, and then you flew again to California, and then so
across the Pacific, and then back to Japan again.
Yeah, exactly.
Traveling west the entire time, pretty much to the best of your ability. Okay.
Yeah.
Okay. So, are you sitting down?
I am.
Good. All right. You travelled in a circle around a pole. That pole being north, and you went east. You could have gone west. Well, actually, no. You did go west. Well, you could have gone east. You could have gone in either direction around that pole. That being a circular direction. If at every single point along travel you use a compass and your compass points to, let's say, magnetic north, and then 90 degrees to your left, well, that's going to be west. As you keep traveling around that central pole, you're going to be going in a circle, aren't you? If you've got a magnet that your compass points to, right, we call that magnet north. You with me so far?
Yes.
Cool. And we got the compass that's in our hand, and we align the compass underneath the needle that's pointing north. So the compass is now underneath the needle. East is 90 degrees to our left, to our right, and west is 90 degrees to our left. Okay. Now, if we put that magnet on a table and we were to keep west 90 degrees to our left, you would notice that you would travel in a circle, wouldn't you?
Sure.
Cool. Now, can you get in an aircraft and travel west in a circle above a horizontal plane and end up where you started from if you always went west?
Okay, could you repeat that?
Could you, on a horizontal flat plane, travel in an aircraft continually west in a circular path and end up where you started?
Yes.
Cool. So that's what happens when you fly around in circles.
All right, and
circumnavigation is a circle.
Okay, but then if you fly in a straight line, you'd end up back where you were initially.
Straight line.
Yes.
When's that happen?
Well, I can't. Well, obviously, I don't have an example at the top of my head, but
okay. So you gave. We know the example around on a sphere. Now I'll give you that you could potentially follow one straight line around a sphere and end up where you started. Now this can be done, for example, on the equator, or following all lines of longitude through the North and South Poles to end up where you started again. That would be travelling in a straight line around a sphere, I guess. So, if we're going to be travelling east and west, those are going to be circles around poles. The circumnavigation north through south and back following longitude around the sphere hasn't been done. Now, I'm not just saying that. I've looked into this for 10 years, right? No one has flown from the north to the south and back to the north again following one line of longitude. But circumnavigation on a flat surface, if you want to go east and west and all variables in between, that's completely possible.
Okay. Wait. So I mean, in your example, the center would be the what's it called? The North Pole?
No.
Then what would it be?
I don't know. For me to know what the centre of the Earth is, reality, to calculate where the geographical centre was. I don't know where that is. And why would you suggest that I say that the centre is underneath the North Pole? Could be underneath the South Pole then, right?
I see.
So yeah, I don't think it's underneath the pole. If you talk about the centre of the Earth, or the middle of the plane of the Earth.
All right. Then actually, let me pull up a more, I guess, concrete example.
on my part. It's a presupposition of anyone's part.
Okay, so maybe you can help me then, right? Biting the bullet, coming to you in good faith. If there's a fact, for example, that the surface of water is horizontal, then couldn't I then use that fact as evidence that the surface of the earth was indeed horizontal?
It depends on what surface of what water you're talking about.
The surface of the earth, or all bodies of water, but the surface of the earth, like a lake or a sea, for example. So if I was to measure...
So horizontal is about an axis, right? Oh, well, I'm going over your question. Horizontal requires an axis. What's the axis?
Yeah, so perpendicular to vertical, right?
So you're saying that you're making an observation that the surface of water is horizontal relative to the surface of the earth, right? Because that's your x-axis?
The surface of the earth is the water, right? So I'm trying to ask you, if the fact is that water is horizontal upon the surface, then isn't that evidence that the surface of the earth is horizontal?
You can say that, but I can say that it's not. I can say that it's not evidence of your position because your perspective is too narrow.
Okay, because the perspective is too narrow. Why is that?
Right. Because if you and I are standing at the surface and you say, my observation is that the water is horizontal, ergo the surface of the world is, that the world is flat. And I say, actually, we are not noticing enough of the water to notice a curve if there is one. And so all you're doing is injecting a paradigm.
Gotcha. Okay. So if I was to measure that surface of water to be horizontal over, let's say, any and all distances that I could measure, right? I'll give you a frame of like maybe 30 miles just to keep it local. If I could measure over distances of water at all times over 30 miles that water's horizontal, wouldn't you then be injecting a paradigm that the earth is a sphere, I just can't measure it because it's so big?
No, not necessarily.
Why not? Why would you say that the earth is a sphere then when I measure it to be horizontal?
No. We're talking about
there's no need for an injection of a paradigm here, is there? I just measure it to be what it is.
Yes, there is. Again,
but I'm just measuring it to be what it is.
You're measuring it to be what it is, and you're saying that the fact is evidence of your paradigm.
Well, yeah, the fact of the surface of the earth being flat when I measure it factually to be so, it is.
No, the it is begging the question, because again, we're talking about when facts become evidence.
This is what I'm trying to get to. Right, without the paradigm even involved, you've only got two choices about a curved or a straight line, right? Over a distance, it's either going to be
No, there are not. It's not just two choices. Well, there's a curve or there's a straight line, and that proves the entirety of the planet. No, that's not. Those aren't the. That's a false binary. Those aren't the only two options.
So, what options have you got if it's not straight or curved?
The shape of the vessel,
which would be.
That would be dependent on the shape of the water basin that the water is in.
Okay, and that water basin would be what shape? Straight, curved? A combination of straight and curved lines?
It would depend upon the measurement.
Dude, right? I'm pointing out that when you measure something to be horizontal, it's only going to be somebody else that injects a barotyme to say, no, it's curved. If it's factually measured to be horizontal, that's it.
No, it's not just that's it. Because now what you're saying is that brute facts, quote unquote, which I've agreed already exist, are now de facto evidence of your position. And that's not how it works.
Okay, how tall are you? And how do you know how tall you are?
I'm 5'10", 5'11".
And you measured yourself to be that?
Sure.
Cool. Do we need to argue about a paradigm here?
Of course we do.
Why? You're fucking 5'10", dude. You've measured yourself. Now, maybe 5'10", a little bit, depending, like the shoes you wear or whatever. The accuracy of the measuring tape, I don't know. But why are we arguing about a paradigm? It's just a measurement.
I don't see what measuring my height has to do with whether or not the water is completely
Because if I measure it to be horizontal, then it's horizontal. We don't need to argue about a paradigm.
No, we do, because the point is that you and I could both observe that the water is horizontal.
Measure,
that's not proof.
not observe,
that's not
measure.
proof. Okay,
Measure.
a measurement. Okay, we can observe the measurement. Because observing the measurement is an observation, is it not?
Yeah, but we're going to make a measurement. It's just not an observation. It's a measurement with a tool that we're going to be specifically talking about. So when we measure
an
the
observation of
surface
a measurement,
the water,
which is an approximation. Yes.
Yeah, so when we measure the surface, and we measure it to be horizontal, isn't that just a factual demonstration that it's horizontal on the surface?
The measurement would be an objective fact, yes, but the moment that you say, well, it's now evidence of my position that the entirety of the Earth is flat, you are injecting a paradigm and you are making an argument. These are no longer facts we're dealing with. These are supposed evidences.
Yeah,
you do not make an argument with facts. You do not make an evidence with facts.
Right, dude, I'm biting the bullet. I want to learn, right? I want to follow. So me measuring the surface of water over distances multiple times up to and including 30 kilometers in different locations all over the Earth, and every single body of water that I measure is measured to be horizontal, where it should, if I was to believe the paradigm that the Earth was a sphere, measured to be curvature, then my empirical measurement would be evidence against the idea that the Earth had a radius of 3,959 miles.
No, not necessarily.
Why? Because the rate of change of slope is approximately 8 inches per mile squared, something I should most definitely measure over 30 miles. If I was to believe the paradigm that's been injected that the Earth was a sphere, right?
No.
No? I would measure that factually on the surface if the radius of the Earth was that, wouldn't I? Curvature at that value.
You can measure it, sure.
Can we? How do we do that?
Measure the distance?
No, measure the rate of change of slope over the distance of a ball Earth.
Well, there are many different ways.
Okay, how do we do that?
I'll use your guys' favorite example. We could use a laser. You guys like talking about lasers, so.
It's really weird that you now want to do this. We were talking about paradigms.
I know, we're talking about, well, I'm answering your question. You asked how would we do it, and I'll say I'll use one of your guys' favorite examples. We'll use a laser.
Okay, and who's doing this?
The person that we've all agreed to be some objective third party. Or I'm sorry, some third party without an obvious bias.
Who's that then?
Whoever we agree to have measure it.
Who's that?
We'll call him Dr. Cool.
So this is hypothetical. Hypothetical man's measuring a hypothetical curvature.
Sure.
Oh my God.
Dr. Cool.
No.
You and I crowdfund some guy.
We start inviting imaginary ideas into the conversation about reality, dude.
You and I. What's wrong with hypotheticals? You and I. Hypotheticals are used to test logic. Hypotheticals are used.
Says hey, welcome to the conversation. He's all yours.
Now, if you and I crowdfund some guy that we agree to be some non-biased, objective third party to do this measurement, what's wrong with that?
So what you're telling me is that this hasn't been done? No one's measured any curvature of the Earth with a laser?
Well, I'm sure it's been done, yeah.
Oh, okay. Could you get that for me? I just want to see it.
Sure.
$5 is Stephen Hawking.
It might be Jaron, though.
Does he actually think that was a laser?
They always think it's a laser.
I guess in his paradigm, flashlights are lasers, right? God, yes.
What's the difference between a flashlight and a laser?
Columnators. range, accuracy. I mean, geez.
Intensity.
Yeah, all of that's fine. Those are all differences. Yeah. I'll agree to that.
I think that was code word for Jaren.
Yeah.
Hey, what's up, guys? How's it going?
What up, dude?
Hi.
Yeah. Like, what's up?
Waiting for Floundering's evidence.
Oh, you guys are doing like a debate or something?
No.
Oh, good. Okay.
Epistemological masturbation, maybe.
Masturbation.
I'm trying to get to these experiments. There's a YouTube series on experiments over Lake Pontchartrain, but for some reason the playback isn't working.
Before we continue,
Don't waste your breath.
If I find really weird. Not 10 minutes ago, somebody suggested Floundering was actually Mark, and here comes in Mark.
I'm here.
Anybody else find that odd?
Nope.
I don't know who Mark is. I've been here for 45 minutes? 15 minutes?
Yeah, that's fine. I just found that kind of strange. But anyway.
Anyways.
Well, wait, no, I do know Mark. I argued with Mark a couple days ago in the Christian chat.
Why?
Well, you're philosopher monkey. Yeah.
Oh yeah.
Yeah. We had an argument about metaphysics and presuppositions.
Oh, okay. I forgot. So, are you a flat earther too?
No.
No? Okay.
Oh, what was the problem with the video?
I went to get to playback and it said this video is unavailable, and apparently it's just not. It was deleted. So the source that I pulled up said, "Hey, look, check out this Reddit post," and I went to the Reddit post, and the video doesn't exist anymore. So I'm on another one. I'm on Lake Balaton. I'm grabbing the forum post right now. I want to post a link.
All right.
I don't know why you're bothering with these guys, to be honest.
That's a good point, Mark. Let me help you out.
Am I going to get muted?
Yeah.
I posted a link.
So this is a laser test.
Over Lake Balaton.
Okay.
Or Balaton, if you're from there. Map of LiDAR measured ellipsoidal water surfaces and modeled gravity potential isosurface height with the same elevation color scheme. Shows detailed high distribution of water surface measurements. Histogram refers to LiDAR measurements. Histogram refers to water surface normal heights. On Lake Balaton, currents are driven by wind and Saichi Wild. I've never seen that word before. Thermal convection remains hardly observable. The flow of water from the tributaries toward the outlet is also very weak because significantly more water leaves the lake through surface evaporation than through the outflow. Okay, so basically it's describing that the surface of the lake is pretty uniform.
Right, so how much drop over distance did they find?
Well, we can go to the PDF. The PDF is a PDF of measurement data using 18 different positions with a, let's see, over a 20-minute time span, and it gives the GPS coordinates as well, and the distance in meters above. And there are measured beam heights and globe Earth assumed measured beam height and flat Earth assumed measured beam height.
I don't need any of the assumed. I just need how much drop over distance did they find?
Well, I'm getting to that. I haven't read this before. The results of the new, let's see here. Both cases, in cases of the 2013 LiDAR experiment, confirmed that standing water has a truly level surface. The accuracy of the test is negligible to the difference of the calculated and measured value. Let's go here. There's another link.
Hang on, did you say you didn't read this before?
No, I've never read this before.
Everyone heard that?
I've never had a conversation before about these laser experiments over surfaces of water. This stuff's new to me, so.
But then why was it earlier when you were asked the question, you answered it with such a high confidence yes?
Yes, about what?
You were asked, are there laser measurements proving curve? And you said yes. And then you pulled this up.
Because I was talking about this. Because I was talking about this with some guys in here last night, and all of them were pretty confident about the laser tests. And so I've been looking them up, and I looked some of them up earlier today, and I've been reading about them.
But are there any that you actually have read yet? So you don't need to spend so much time just reading it out now to learn about it to make your point, like on the fly type shit.
I mean, didn't you just say effectively the surface of the lake is level? That doesn't sound like drop over distance to me.
That's what the experiment conducted.
Okay. That's level water. So no curve then.
Yeah, again, dude, at the very least, you could have pulled up something that you actually read about beforehand.
No, I like this.
Well, it's either evidence. It's either evidence of your position or it isn't. My disposition on the matter is irrelevant.
Yeah, well, it kind of is because you're spending all this time.
It's not.
Yeah. I mean, dude, you're spending all this time learning about your argument in the middle of an argument. Like, maybe you want to take 5 or some shit?
No,
like, I don't know.
Let it happen, Cups.
All right.
I know you guys really want to pull people away from the globe conspiracy, but the moment that we begin the conversation and I begin to learn and I use the evidence that you guys prefer, you're condescending. I mean, come on.
Dude,
well, where's drop over distance, man?
It's either evidence of your position or it's not. That's what I'm getting to.
Dude, yeah. So at this moment, the evidence that you thought was measurement of the curvature of the Earth isn't. It's measurement of our position. The evidence that we like, that you've gone to go and get support your position, doesn't. It supports ours.
I pulled up 6 pages of pro flat Earth laser tests. That's what I pulled up. I didn't pull up any evidence of my position because right now a globe Earth is not what's on trial here. You made a claim that a level surface is evidence of a flat Earth. Flat Earth is what's on trial here.
Hang on. Dude, no.
Yes.
The question asked of you Dude, hang on. The question asked of you earlier was, are there laser tests proving curve? You said yes. You went to go to get this video, and you fucked up because the video was gone. Now you're off trying to find something else, and then here you are trying to spin it as if you're trying to do our research for us. Like, what the fuck are you talking about,
I'm not doing your research for you. Jedi asked me, well, what test could we use over a water surface to demonstrate curve or lack of curve? And I said, well, you guys really like to bring up laser tests, and Jedi said that was acceptable. So what did I do? I pulled up a compilation of evidences used by the pro-flat Earth perspective from people that have performed these experiments personally and then put them on forums. And I am reading them and attempting to adjudicate them, because the globe is not what's on trial here. Jedi made the claim that a level water surface proves a flat Earth. That is his claim.
I asked for a laser test that had drop over distance or curvature. That's what I asked for.
Right, and that was after my conversation with Jedi, and so
No, when I wanted the same thing, dude, you've misunderstood. I can see that you've misunderstood by what you just said. The contrary evidence that we measure curvature is what you said, and I said I'd like to see the measurement of curvature. You said that we could do that using the standard of lasers. I agree to that standard. I was hoping that you were going to go away and get a laser test that measured curvature.
Well, that's exactly what I did.
But they're all
where's the curvature? Where's the drop over distance?
Man, I hate to laugh at the guy, but I mean,
It's all right. He doesn't have hands.
Oh shit, maybe he's what's that guy's name again?
Floundering.
No, the no hands guy. Dr. Blitz.
Dr.
There we go.
Blitz.
Maybe he's a fucking Blitz apprentice or some shit. Sounds like it.
Yeah, over fences, I saw that table and I was like, I don't see any deviation. So I don't. What do you do?
Oh, Banhammer's here. So this is what I meant. Like, 5 minutes ago, I asked the guy, maybe you want to take 5, go do some research and come back. Because here we are sitting, waiting for this guy to say something about his position. Like, do we still want to do this? Floundering, you want to take 10 now, maybe? Come back when you have something? Or do you guys rather do that than talk to somebody else? If anybody's here. If not, then whatever.
Is there anybody else to talk to?
I'm looking now. If not, then all right. Now, one thing that I can say to this that I can appreciate is supposedly this guy is actually reading the material, which is a kind of a breath of fresh air over the last little while, because most people come in here and just recite ChatGPT or some shit, right? So at the very least, good on you, Floundering, because you're actually, studious.
Well, I'm not going to give you Grok or ChatGPT. I'm going to go straight to the source. And this forum post has a lot of math, and I'm learning right now. The important part here is that immediately under the post of this experiment on this forum is people immediately issuing corrections about refraction. And I'm not an expert on refraction, but what matters is that over still cool water, the refractive index changes the observable measurements. And so it's...
I get you. So we can go on to that. I was just saying, I appreciate you actually taking the time. As long as it is there, the fact that you're doing that is relatively not novel per se, but over the last little while, it's pretty novel. Because most people don't do that. At least not that I've seen. So good on you.
Yeah, about halfway down the page, there's a correction from, let's see. Standard refraction correlation is 1/7 of the standard curvature correction. This makes a total correction over the observed distance of the table 34 millimeters, which would mean this is an extreme, what would you call it? This could cause extreme deviations in the expected data. So I don't know if that's him saying that the data is unreliable, but
they're claiming floundering. They're claiming extreme refraction. That's what that means. Is that what you see there?
Well, he's talking about the refraction gradient on average. I don't think he's talking about an extreme case. Because it says here, the standard refraction correction is equal to 1/7 of the standard curvature correction, which is 6 millimeters. And we're talking about how the temperature
Have you heard him talking about the 7/6?
You cut out, I'm sorry.
Oh, I'm on my phone. Have you heard others talking about over 6? It gets baked into their refraction.
Over 6 what? I'm sorry.
For radius.
Yeah, Ben, you're actually choppy. But Flounder, what he's asking is, is there anything in there, or have you heard anyone talk about the 7/6R that basically gets implicitly baked into the calculation?
Is that the standard correction made for refraction over still water?
Terrestrial refraction, based on a sphere with a radius. Yeah,
that's fine.
The correction is standard refraction 7/6R, yeah.
Okay. I don't see it here, but if he's talking about standard refraction correction, I assume he's using the same math you guys are. That's fine. Okay, are you guys familiar with the Decimal Z YouTube channel?
Decimal Z? Yeah, I've heard of it, mate.
I've got Laser Test Proving Flat Earth Part 2. Let's see here.
Forgive me for being ignorant, but why do you keep giving us laser tests that are showing the Earth is flat?
Because we're talking about falsibility here. Falsification. Okay. Or falsifying.
Well, okay. So in this instance, what we've got is a test for curvature that appears to be falsified with lots of people in lots of different locations.
to see if they can measure it with, in this instance, lasers. So over a body of evidence done by individual people, separated by thousands of miles with the same idea in mind, they appear to be measuring the same thing, that the surface of water is horizontal over the distances that they measure.
Oh, I can't. Oh, I'm trying to copy paste this. It's more than 2,000 characters. Hold on one second. Okay, these are some criticisms of the video of that same experiment over the lake. Now, I'm not using this as evidence of my position. I simply want to know, are criticisms based on refraction valid? And even if we're all using the same math, does the interpolation of the data result in, well, accounting for all of the possible errors? The data is evidence that the Earth isn't curved, or we should go over the errors because there are problems with thermal issues involving lasers over still water.
You know what? I think you're onto something there. Okay, but one thing in particular is it seems like you're choosing to critique a claim to a position that we happen to hold ourselves, right? But you're critiquing something that none of us cited, right? So say, for example, we get into it, and this example here, the guys, what the guys did is completely flawed. He didn't account for this, that, or the other thing, right? I mean, it doesn't really get us anywhere. It just means that the guy didn't do, the proper work.
Okay, well, what it means actually, what I'm trying to get at, is that can we extrapolate from criticisms of a study that claims to prove flat Earth that it's possible that other experiments that attempted to prove the same thing using the same methods also fall under, the same category of experiments conducted under assumptions and mistakes?
If they did follow the same method and failed to account for things that are, validly being critiqued upon, absolutely, you can critique.
This isn't about proving a globe. This is about methodology of the experiment.
Yeah, I get that, right? But it's like you're under the assumption that everybody who's doing these types of tests is following the same method, or worse yet, failing to account for the necessary variables that this guy, for example, might be doing. Right.
Well, yes, but it can be easily, Googled by anybody. It can be easily. We all have access to the internet. Well, is it the case? For example, if I make an observation that the temperature change, like something that we all already know, right? That a temperature gradient changes the data. We all already know that's true, right? I could look that up based on the criticism of the video, and I could say, well, as it turns out, other experiments might fall under this same category of mistake.
Yeah, absolutely. And that's why what might be better use of your time and everybody's time is that we actually get into...
You're watching 24/7 Flat Earth Discord live.